Dr. Sudhakar sir, you can switch on your video, sir. Good morning, Dr. Sudhakar. Can you hear me?
Sir, time is up. Can I start?
Yeah, we are waiting for the session chair. So we can
Okay,
we can wait for another 1 minute and we'll see.
okay, no problems.
So Dr. Sudhakar, if you can hear me, please unmute and switch on your video. So I think there is some technical glitch at the end of our session chairman, Dr. M. Sudhakar. So who is former director of CMLRE. So just I think there is some technical glitch in joining of Dr. M. Sudhakar, who is the session chairman of this session. So by the time he joins, so let us just for the sake of time constraint, so we can start the proceedings of this session. So at the outset, let me first welcome you all. So very good morning to the all the session chairman, invited speaker, coordinators, and other speakers of oral and quick presentations, and delegates who are attending this session live through different channels. A warm welcome to the technical session number 13 of Osicon 21. This topic is on an important theme of polar science and cryosphere studies. We have with us our session chairman, Dr. M. Sudhakar, who will be soon joining us, and coordinators as myself, Vimlesh Pant from IIT Delhi, and Dr. Babula Jena from NCPUR Goa, and invited speaker, Dr. Anil Kumar. I request Dr. Anil Kumar also to please switch on your video. Yes, thank you, sir. I can see that our session chairman, Dr. Sudhakar, has also joined. So welcome, sir. Now I request Dr. Jena to introduce the session chairman, Dr. N. Sudhakar.
Yes, am I audible, Dr. Vimlesh? Am I audible?
Yes, we can hear you.
Okay, yeah, thank you. Thanks, Dr. Vimlesh. Good morning, everyone. Indeed, it's my great pleasure and honor to introduce our session chairman, Dr. M. Sudhakar, who is the former director, Center for Marine Living Resources and Ecology, CMLRE, the Ministry of Earth Sciences. And he obtained his PhD from Indian School of Mines, Dhanbad, and a master's degree in Law of the Sea and Marine Policy in 1990 from the London School of Economics and Political Science, UK, as a British Council Fellow. He served two premier Indian research organizations such as NIO and NCPUR Goa. And he is a veteran oceanographer with more than 35 years of professional experience, and spent more than 1,500 days at sea on board research vessels as a leader to the Southern Ocean as well as to the Antarctica. And I'm sure you'll find very few scientists who has such an immense experience. And Dr. Sudhakar represented India at the Preparatory Commission for the United Nations Law of the Sea, PrepCom, and involved in the deliberations for allocation of a pioneer area of polymetallic nodules in Indian Ocean in 1987. Dr. Sudhakar is an elected member of the Legal and Technical Commission of the International Seabed Authority for the term 2007 to 2011, and elected to the second term again from 2012 to 2016. And he is also a member of Scientific Committee on Ocean Research, ICSU, served from for second term until 2014. And he was a visiting scientist to the Aachen University of Technology, Germany, and a research person of the International Ocean Institute, Malta, and a member of a National Steering Committee for Science and Astronomy Olympiads. And also, he's a member of Scientific Committee, International Geological Congress. He was the Commissioner General of Government of India for the ESU World Expo 2012 held in the Republic of Korea. He published more than 60 research papers in referred international and national journals, books, and equal number of research papers presented in conferences and seminars. And I would say he's a motivation for all of us, and in fact to the entire scientific fraternity. So now I would like to request Dr. Vimlesh, please take over.
Thank you, Dr. Jena. Now I request our session chairman, Dr. M. Sudhakar, to please take over the proceedings of the session from here on. Dr. Sudhakar, please.
Good morning to you all. I hope I'm audible. Okay, you say yes. I want Dr. Vimlesh Pant and Babulal Jana to say that they are
Yes,
able
sir.
to hear me.
Yes, sir. We can hear
Yeah.
you. We can see you.
Yes, sir, we can hear you. We can hear you and we can
Yeah,
also see you.
excellent.
Yeah.
Excellent. The reason being, last night I was to travel to Chennai from Mumbai, and there have been some issues and all problem. The flight I could not catch, and all. Early morning I took a flight and I just came into the room and all. In fact, and here this actually the place where I'm staying, the Wi-Fi is not effective. In fact, it is very, very slow. Actually, we tried on laptop. Ultimately, I got it on my mobile. So, should there be any kind of actually a disconnection and all that, kindly, bear with me, and I would give you all the, rights of continuing the session to Dr. Vimlesh Pant and Dr. Babulal Jana can continue. Suppose it get, that is in case I get actually disconnected. Actually, otherwise I'll be, throughout up to 12:30, I'll be here. Yeah, I think, I must, thank Dr. Babulal Jana for introducing me and all. In fact, I think it's an effort of actually also Center for Antarctic and Ocean Research, and then subsequently at the Ministry of Earth Sciences, and then CMLRE was my last institute from where I have come out. That is on superannuation. However, actually, it is still fresh in my memory as far as NCAOR was concerned. Now it is NCPOR. Okay. Otherwise, I start from ASC, Antarctic Study Center, and then NCAOR. Okay. So I'm indeed, I have a great pleasure to, in fact, hear about, Dr. Anil Kumar has got a lead talk today and all. Okay, that is on the variability in the Southern Ocean and all that. I'm sure that, Dr. Anil Kumar, the kind of experience he has gained since 2004 when we launched the first expedition to the Southern Ocean, that is on board Sagar Kanya, we could just go barely up to 56 degrees south. And of course, subsequently, we went to Larsman Hills with the help of Boris Petrov and so on and so forth. And so the rules of the game for today is that the lead talk will be for about 30 minutes, out of which 25 minutes this speaker, Dr. Anil Kumar, will take. Another 5 minutes we will have for discussions. We will entertain up to 2 questions for discussions. In fact, had it been, I think, physical conference and all, it's easy. We can see and then moments and all. But here, it is all virtual.
We lost connection to Dr. Sudhakar.
Yeah, actually, are you hearing me?
Yes, yes. Now we can hear you, sir. Yeah.
Okay. As long as you are hearing, it's okay. Suddenly some software update is going on my mobile. This is great. My son has set it for me on the laptop also. This is what is the younger generation can do for us. Do wonders and all this thing. Otherwise, I would not have been able to do. However, I think it's important that as far as the technical, presentations are concerned, we will have about 15 minutes each, and all out of the 12 minutes will be for the presentation, and 3 minutes we will have it for actually discussion. Let us accept the rules of the game and all. I will actually, in fact, Dr. Anil Kumar doesn't require an introduction and all this thing. That too, when I have to say so many things about him and all, because from the day he joined NCPOR, I know him and all that. And actually, he is an excellent human being to start with. And then, actually, he has excelled with his experience of being in NIO earlier, and then, with Cochin University. And actually, he has demonstrated through time that he is a capital scientist, and he has got that tenacity and acumen that is required to be a scientist. And all. He is very humble, and he is gentleman and all this thing. I have rarely seen him getting even angry about issues or even anxious. Except when I get angry and all, I used to see his face, whether he actually he accepts me or not and all. He always accepts me with a smile and all these things. This is a a great quality of Dr. Anil Kumar. Dr. Anil Kumar, after the actually, I left the reins at NCPOR and all. Actually, he took over as a project leader of Southern Ocean, group director, and all the activities he has taken over and all this thing. It gives me an immense pleasure to, in fact, introduce Dr. Anil Kumar and all, actually, who has a lot of scientific publications, and a lot of work has been done for the first time in the Indian Ocean sector of the Southern Ocean. This is the first reports of Indian sector of Southern Ocean. And religiously has been continuing that legacy of following those tracks and all that. And so many expeditions. Actually, he also has led the expeditions and all. With all these things and all, he has created an immense database and knowledge in the Southern Ocean part and all this. And therefore, with this, actually, I would request Dr. Anil Kumar to start his lead talk, and I will also congratulate him in advance. He has got a good skills of doing the presentation, scientific presentation, and it's a long time I have not heard him. Therefore, it's an opportunity to me also to hear him. Dr. Anil Kumar, please. I think Dr. Anil Kumar requires introduction and all this thing. Somebody said that introduction is over now. Okay, Dr. Anil Kumar can straight go ahead with his presentation. And actually, I request Dr. Vimlesh Pant and Babulal Jana, one of you can track the timing and all that. Timing, you track it and all, and you can actually alert the.
Of course, I will do
You
that.
can also, for 5 minutes early, you give him an alert, so that it's always rushing to the slides is important and all at the end, and always important slides will come at the end and all. Let us not rush him. Okay, we would like to hear him carefully. Thank you.
Thank you so much, Sudhakar Saab, for giving me a nice introduction about my activities at NCPOR and how I came to as a group director and how we launched the expeditions. Of course, I know that we have started Southern Ocean 2004, and 2004 and 6, you were there with us for leading. And we went up to Las Manis, and the first time we entered into Las Manis, and a lot of survey we have carried out during that time. And a lot of observations we carried out in the Indian sector of the Southern Ocean. And now we have completed 11 expeditions. That is a great achievement for us. A lot of publications and PhDs and special issues also we have made. Now let me start my presentation. Thank you so much for giving me a nice introduction. Is it visible, my slides?
Yes, sir.
Yeah.
Slides are visible in full screen. Please go ahead, sir.
Okay. So this is the information about the Indian expeditions to Southern Ocean what we have carried out. This is mainly for the students, research scholars, and young scientists, those who are interested to learn about Southern Ocean, and those who are interested to participate in the Southern Ocean expeditions. They should know what is happening in the Southern Ocean, why we are going to Southern Ocean. So what is the importance of Southern Ocean? These kind of things I'm explaining, and the future plans, what we are going to implement. So that will be more useful for you to join with us. So decadal Indian observational campaign in the Southern Ocean to understand the ecosystem process and future perspectives. So the platforms what we have used is in here. Sagar Kenya in 2004 and Boris Petrov 2006 and 9. And afterwards we have used the ministry vessel, that is Sagar Nidhi from 2010 to 2015. Afterwards we have chartered a vessel from South Africa, that is Agulhas 1, and 3 expeditions we have carried out in this platform. So this is what the 2 transects what I am showing here. That is, one is at 45 to 48 degree east, and one is at 57.5 degree east. So there will be a question why we have selected these 2 transects. The first transect is above the southwest Indian ridge, and just after the Bedell Jam. So these 2 influences are affecting the flow in this area. That is especially the current flowing through this area. That is known as Antarctic circumpolar current. It is a big current system. It is covering all the oceans, that is Pacific, Atlantic, and Indian Ocean. So whenever it reaches this region, these 2 factors are influencing it, and it is moving towards more southwards, and it coming to the flat bottom. So how it changes and what are the ecosystem changes happening because of this influence? These are all the important aspects we would like to study. So we have selected these 2 transects. So what are the significance of why it is Southern Ocean is important? So signatures of global changes are more pronounced, very clear in the Southern Ocean. Afterwards only it is affecting the tropical regions and all. So very sensitive regions of the ocean. And we have to understand about the air interaction and the biogeochemical cycles and marine productivity and all. And you know that a lot of greenhouse gases, especially the CO2, is getting produced in the tropical region, and all these are getting absorbed in the Southern Ocean. So what is happening with this and where it is going? These kind of things are very important. And a lot of nutrient supply is coming from Southern Ocean. It is a HNLC region, high nutrients, low chlorophyll region. So a lot of nutrient supply is happening from the Southern Ocean. And the heat, what is getting produced in the tropical region, are getting absorbed in the Southern Ocean. So you know that as an oceanographer, a lot of studies has been carried out in the Indian Ocean. And we know that the northern side of Indian Ocean is landlocked. And because of that, a lot of differential heating is happening. And the flow of the wind flow is from land to sea and sea to land is happening. And our monsoon reversal is also happening, northeast monsoon and southwest monsoon. So Southern Ocean is connected with the Indian Ocean circulation. The Agulhas current, when south equatorial current in the Indian Ocean comes and joins with Agulhas current, and Agulhas joins with the Antarctic circumpolar current, and it goes to the coast of Australia, and West Australian current it reaches, and it is complete circulation. So that is why this Indian Ocean circulation and Southern Ocean circulation are connected. So whatever is changes happening in the Southern Ocean, it is affecting the Indian Ocean. So this is what I told about the major current system. That is in the Indian sector of the Southern Ocean. The current system, when we are coming to the Indian sector of the Indian Ocean, the current system changes. That is in the northeast monsoon as well as southwest monsoon, the current system changes. Accordingly, the changes are happening with the ecosystem also. So this is connected with the Southern Ocean. And you know that the conveyor belt, it is connecting the polar regions and the tropical regions. A big belt is there, and this flow is there, the current flow, that is known as the conveyor belt. So I told about the nutrient concentration. When we are going south, the nutrient concentration is getting reduced. I mean, it is getting increased, but productivity is getting reduced. Why? Because we know that the southern region and all, there is no land nearby, so there is no iron supply. Or iron or cobalt supply is not very, very less. So that is why the productivity is not much high in the southern ocean regions. So this is known as the current system, frontal system in the southern ocean. So you must be thinking about what is a frontal system. Frontal system means the subtropical water masses and the subantarctic water masses. Subtropical water masses are warm and saline, and subantarctic water masses are cold and less saline. These two water masses are getting mixed and forming the drastic change in the hydrographic parameters. So these regions are known as the frontal regions. When we go down more south, then different kinds of fronts we can see. The first front, what we are seeing is subtropical front. Then we can see the subantarctic front. Then we can see the polar front. Then when we are going more south, southern Antarctic circumpolar current front and the southern boundary. These are all the various frontal systems what we are seeing in the Southern Ocean. The Indian sector of Southern Ocean, you can see that there is a bifurcation of the fronts. You can see that here. That is PF1, PF2. It is getting bifurcated because of the influence of what I told earlier. So the Southwest Indian Ridge and the Weddell. Yeah. See, the water masses, what is water masses? Water mass means a system water which is carrying the same characteristics and it will not be changed. Unless it goes and getting more diluted, then only its characteristics will go. So based on the water masses, we can understand that from where this water is coming. So this is a major hydrographic component. There are kind of water masses in the Southern Ocean. That is subtropical surface water mass, subantarctic surface water mass, Antarctic surface water mass, subtropical mode water, Antarctic intermediate water, circumpolar deep water, Antarctic bottom water. So this is from north to south. When we are moving, this kind of water masses we can see. And these are all the fronts that I already told. With the temperature and salinity changes, various fronts we can see in the Southern Ocean. So the main focus of our study is to understand about the role and response of Southern Ocean to the region and global climatic variabilities. So the major questions to be addressed when we are going to Southern Ocean are: how do the atmospheric and the ocean dynamics in the Southern Ocean affect the tropical weather and climate? How the physical process and atmospheric aerosols and other gases are modulated by biological pump or biogeochemistry and vice versa. These are two major questions to be addressed by doing this expeditions in the Southern Ocean. So for this, you know that a lot of enormous data set is required to see the climatic variabilities and how the climate is getting changed because of this impact. An enormous data set is required. And seasonal data sets also are very, very important to understand about this, to address these questions. So for seasonal data collection in Southern Ocean, it is a very, very big question how to do it. So we made an attempt, but we could not succeed because of the very, very dynamic system in the Southern Ocean. So again, we are planning to do with the time series observation in the Southern Ocean to understand about various seasonal changes, what is happening with that data, we can come to at least some input for the climatic changes what is happening and all. Some inputs we can give from this observations. That is what we are planning to do in the future. That will come in my later stage of this presentation. Until date, we have our studies were mainly concentrating on air-sea interaction and role of anthropogenic aerosols over Southern Ocean, and interrelation between physical, chemical, and biological elements across Antarctic circumpolar current and their role in the carbon sequestration and biochemistry. So the SOOS, that is one of the major international body but is mainly studying about the Southern Ocean observation system that is mainly concentrating on. So from SOOS, we have taken two themes to include in our studies. That is, how do the changes in the Southern Ocean meridional overturned circulation and the water masses, intermediate as well as bottom water masses, affect the thermocline variability and CO2 dynamics, acidification rate, biogeochemistry in the Southern Ocean. These kind of things we have taken as one of the component for our study. And does the ocean and sea ice shelf interaction in the coastal region of Antarctica influence the freshening and warming of the bottom waters? So this is a very, very, very interesting thing, because recently a lot of studies are going on with the freshening of water masses in the Southern Ocean because of the melting of glacier as well as the ice shelf. It is not sea ice. Ice shelf and the glacier melting, it is coming and it is mixing with the water masses there, and water mass is getting diluted. That means salinity is getting reduced and becoming warmer. These kind of things are happening. So this is very important with the Southern Ocean ecosystem, because there is one major water mass known as the Antarctic bottom water mass, and if its characteristics changes, though the entire carbon dynamics and the ecosystem and the species and everything will be getting affected. So that has to be studied in a detailed way. What are changes are happening? That we are planning in our future studies. So this is just for understanding about the implementation plan, how we are implementing the expeditions. So first, we are giving the advertisement in the websites. So that will be coming in May, June, and an internal and external review of the external experts for the proposals, and the proposals will be invited in as per this advertisement. And after getting the proposals, it will be reviewed with an external expert committee, and that committee's the presentations has to be made by the project principal investigator. Accordingly, the committee will approve, recommend it, and with the consolidated recommendations and the projects will be sending to the ministry for approval. Accordingly, once it is approved, we will be planning for the launching of the expedition. That will be usually coming in December, January. That period it comes. And up to February to March, expedition can be carried out. Why beyond March we cannot do? Because after March the winter starts, all ice formation and ship cannot move. So we have to come back before the end of March or before the starting of the winter. So this is in 11th expedition. We went up to the Prince Bay region, and we have collected a lot of observations during this period, and a lot of national and international organizations and universities have participated in our various expeditions. So this is one of the studies what we have carried out in the recent expedition, a black carbon. So we identified that the black carbon, for the main source of the black carbon is from Madagascar region and South African region. That is what our study says that. So this is what we observed with the changes in the frontal system, how it is changing when we are moving from west to east. There is a meandering or a moving shifting of the frontal system is happening when we are moving from west to east. That is our observation says this, and it has been studied, several years of study we made, and it is very, very clearly it is seeing that this shift is happening. And we know that one of the things we have to understand about the Southern Ocean is the eddies occurring in the Southern Ocean. There are two types of eddies are there. There is cyclonic eddy and anticyclonic eddy. Cold core eddy and warm core eddy. So cold core eddy means it is coming from down. The water is coming up. So the center will be cold. So cold core eddy. Whenever convergence comes, it is warm water comes, their center will be warm. So warm core eddy and cold core eddy. This is mainly affecting the system, and its ecosystem is getting affected, and the species, everything, it is getting affected because of the eddy changes. So a lot of eddies are coming in the Southern Ocean because of the mixing of water, various type of water masses. And another major thing in the Indian sector of Southern Ocean is the Agulhas retroflexion. The Agulhas current goes when it reaches the down south of Africa. before entering to the Atlantic sector, it turns and come back to the Indian sector of Southern Ocean. So that is also producing a lot of meandering, and it makes a lot of eddies in the system. So this is what one of the major findings from us, from tropics to when we are moving towards the south, what are the various types of species what we are observing here. So when we are seeing in the tropical region, prokaryotes are more dominating. When we are going to the subtropical region, we are finding the flagellates. And when we are moving very down south, we are getting the diatoms. So there are various these species dominating in the Southern Ocean system. This is the zooplankton biomass from our studies. And we are getting the zooplankton biomass more predominant in the south, that is polar front and subantarctic frontal regions. This is some of our salient findings. So I am very glad to say that we have come out with 3 special issues from our 11 expeditions. First special issue was published in 2010 in Current Science. And after that, after 5 years, 2015, another special issue we published in Deep Sea Research, 2015. And now 2020 also we published another special issue in 2020. That is, every 5 years we are publishing one special issue like that from the observations what we carried out and based on the results. So these are all some of the major results. That is zones and of zones of sink and ventilation of CO2 that we identified in the Southern Ocean. And whenever the CO2 is getting absorbed in the Southern Ocean, when the saturation comes, it can come back the tropics. And when the tropics it reaches, it's a warm region, again it is getting ventilated. And whatever is going down south, it's coming back again. So we have to be very careful about this production of this CO2. And we know that recently it's a very sensitive issue, and it has to be studied in a detailed way to understand about it. And dominance of known sea salt aerosols in the Southern Ocean. And fast-raised freshening of bottom water, I already told about this. And eddies also I told about it. And the different phytoplankton groups, what we found, that also I told about. These are all the various observations what we are making when we are going to the Southern Ocean region. Then these nutrients, dissolved inorganic carbon, alkalinity, hydrodynamics, isotopes. These are various kind of studies by various institutions. When we go to the expedition, there will be around some 15 to 16 institutions are joining for the Southern Ocean expedition from various across the country and from outside also. So these are all some of the equipments what we used. That is CTD. CTD means conductivity, temperature, depth for measuring that. And this you can see that some of the bottles connected in that, and that bottles can be used to collect the water samples at different depths. This can be used to study about at different various depths how the water changes and what are the parameters getting changed and how it affects the system. This kind of studies can be carried out with this. And XCTD is a expendable disposable type CTD. That means when we use the probe, it will go up to 1,000 to 1,100 meter, and it will collect the data. And this will be the sea. It will go, and we will get the data. The ship is not required to stop to collect this data. While moving itself, we can use it. And the multiple plankton net and bongo net. This is for the plankton studies we are using. Zooplankton, phytoplankton, and all different nets we are using. And grabs for sediment collection, and gravity core for sediment core collection. So this is one of the mooring what we made in the Southern Ocean, but we could not succeed it because of I already told about the dynamic system problems and all. And this is already we started the mooring programs, and now we are planning to make one mooring observations in the Antarctic region. That I will come later in my presentation. These are all the various instruments what used for mooring as well as other observations. This is what we I told about Agulhas. This is the ship what we used, and when we are going from Mauritius to Southern Ocean and coming back to Mauritius. So Mauritius is the port which we are using for the launching the expedition. So when we went there, and our High Commissioner from Mauritius visited our vessel, and to understand about what India is doing in the Indian sector of Southern Ocean, what kind of studies we are carrying out. And the Honorable President of Mauritius also have visited. We have visited the President also we have visited, and we have exchanged our idea what we are doing there. And this is the Argo floats. Argo floats is the floats we will deploy in the Southern Ocean during our expeditions, and this will go up to 2,000 meters. And while going down, it will collect all the data. And after 10 days, it will come up. Again, it will collect data while coming up, and it will transfer the data. Like that, every 10 days, it will come up and transfer data, and it moves along with the current. So wherever the current goes, it moves along with that. And with the GPS, we will come to know which location this information is coming. So through satellite, it will come to the land station. The data you can download the land station. That is the Argo floats. The same way, SOCOM floats. SOCOM floats actually used by the Scripps Institute of University. They have participated in our expedition, and this has been deployed. So this Argo float deployment we are carrying out in our 11 expeditions. We were deploying this Argo floats in collaboration with INPOIS. So this is our achievement. The 11 expeditions I already told, and more than 100 papers and 90 papers published, and 90 papers in conferences and conferences we presented, 90 papers, more than 90 papers, and 14 PhDs already awarded, and 15 PhDs are in progress, and 20 MSc dissertations and 3 special issues already told, and the book for publication is in progress now. And Horizon 2020 is one of the programs under CRIS. That is, this program is known as CRIS, Climatic Relevant Interactions and Feedbacks. So this is in collaboration with European Union. We are doing that already. The projects, everything is materialized, and this has to be implemented during the next expedition. So we have a membership in international bodies like the GOSHIP, SUS, SCORE, SCAR, etc. So future plan. So we have to fill the gaps, the observational gaps. Where are the gaps? We have to fill that area. We have to go and make more data collection and modeling. That is very, very important aspect to be studied. That will be already the modeling team has joined, and we will be starting the modeling studies very soon. And this implementation of in-situ observations and the satellite observations, modeling, and national and international collaborations we are planning to make, and capacity building. So this is one of the major studies what we are planning to do in the future. This is about the Antarctic bottom water. So I already told about the bottom water is the freshening of the bottom water is happening. This is mainly because of the warm, deep circumpolar deep water is coming there, and when the warm circumpolar deep water enters in the coastal region, because of it is warm and it melts the ice shelf. The ice shelf is getting melted because of this intrusion, and this melted water will dilute the Antarctic bottom water. So more intrusion of this deep circumpolar deep water, warm circumpolar deep water, affects the formation of Antarctic bottom water. That is a major study, because whenever this bottom water, this circumpolar deep water enters into the coastal shelf region, the production of Antarctic bottom water is getting affected.
Sir, we have completed 25 minutes in this talk, sir.
Okay, I'm stopping now. This is another. This is what I told about the Antarctic current and intrusion of current at different because of the easterly wind, weak wind condition, how it is behaving, and if the wind is strong, how it is behaving. That is here, and this is the our mooring program what we are planning in the future. That is the tropic this coastal region as well as the open ocean region. This is the mooring profiles also. It will move through this wire, and it can collect the data from around some 100 meters or 200 meters to the bottom, like that. And this is we are planning to the gliders also we are planning in the future, because ship cannot go all the areas in the Southern Ocean because of the ice formation and all. So we are planning to use gliders, and even the seals fixing this sensors in the seals, and it can be wherever it goes, transmit the data, that data recorded, and it can be collected. That is also we are planning in our future studies in collaboration with Australia. And this is the numerical modeling, I already told about it. And this is the microplastic study. Already we have started because it's a very, very important thing. It is affecting the system, and this is a major pollution, polluting the system, especially in tropics, as well as it has moved to the southern ocean region also. That also we have to make a detailed study. Thank you. This is what I would like to make, and this is one of our Republic Day celebration on board. And the chief scientist, Dr. Anu Mahajan, is hosting the flag. Thank you.
Thank you so much, sir, for your wonderful presentation. Now, I could not find here any questions in the chat box or YouTube.
Okay.
So,
Shall I stop share?
Yes, sir. You can unshare your screen.
Okay. Need to be done. Okay.
Yeah, Dr. Sudhakar, sir. Please unmute. Dr. Sudhakar, unmute yourself.
I am there on the screen.
Yeah, I think it's okay now. Actually, we heard from Dr. Anil Kumar the decade of Southern Ocean journey of NCPOR along with other allied institutions and all, and the significant, contributions they have come out with in terms of the understanding of the Southern Ocean sciences at large and all. Of course, this has started in a humble way, and it has almost become like a regular affair on par with the Antarctic expedition, exclusively into Southern Ocean. So there has been always a number of unanswered, questions were there and all, which I think, our scientists, along with the international collaboration, are trying to address. And I'm sure that, the seed that has been sowed, it'll go a long way, and it'll start. It's already a tree. It has become a tree now. It has to, and it'll offer, I think, some kind of fruits and all that. And the younger generation will definitely get benefited by this. I think Southern Ocean activities of NCPOR and India at large. I think with this, I would again, I can request everybody to applaud the excellent presentation of Dr. Anil Kumar, and actually he has shown his sharp completing his presentation, as well as come out with a significant compilation of the results. Thank you very much, and we will all applaud. And at the same time, I would also invite other speakers and all, actually, who are there in this session, to go through, okay, sequentially, and it is actually Dr. Vimlesh Pant and Babulal Jana have got their scheme of I think inviting one by one and speaking about their abstract and all that. And I'm sure that it will go on and all. I'm available, and at the end and all, we will do the compilation of actually all the scientific presentations happening in this session. Thank you, Dr. Anil.
Thank you. Thank you, Dr. Anil. Thank you, Dr. Anil, for your invited talk. Now, we will move on with the oral presentations. And first in the list is Professor Sivaji P. Chavan. So I request Professor Sivaji to please share your screen.
Yes, sir. Yes.
Yeah. So yeah, we can't see your presentation.
Yes, sir. Just wait, sir.
I request all other speakers also to keep their presentation file open and minimized so that we don't lose time in sharing your screen at your turn. If there is any issue, I can share it from my end.
Yes, sir. It will be better, sir. I think here is a little problem.
Okay.
Yes, sir.
Yes. So
Shall
if
I start?
yes, please start.
Okay, sir. So thank you very much. On occasion of this Osicon 21, I'm going to present here presentation for the 13th session. And myself, Professor S.P. Chavan, Shivaji Chavan from Swami Ramanand Tirth Marathwada University in Nanded in Maharashtra, Department of Zoology. And my presentation, the title is related to the studies on South Polar Skua, Stercorarius mccormicki, which I conducted during the 39th Indian Scientific Expedition to Antarctica. So this is the way we reached Antarctica, that is in Shemachar Oasis near Maitri Station. And this was my project for approved project for the studies on South Polar Skua, that was breeding ecology and biology of South Polar Skua at and around Maitri Station, Antarctica. So as we all know, skua is very famous bird at Antarctica, and from various species of the skua, South Polar skua is one of the dominant and very commonly found at the Antarctica, especially in the peripheral region. And I focused on the breeding ecology of this particular species. So next, sir. So the study was related to search of the nest of South Polar Skua in Shemachar Oasis. As we know, the South Polar Skua reach at Antarctica, and especially particularly to the selected study zone what I selected, Shemachar Oasis. This is endemic area for this species, what I found. No doubt it breed in other parts of the Antarctica in peripheral region, and it has distributed. The data shows its distribution up to the South Pole. But as we know that our expedition, my particular topic was restricted to Shemachar Oasis. That's why I searched the nest in this particular area, 34 square kilometer area, and I found 13 13 nest of that. The 11 nests were active nests. I mean, the nests were used for laying and incubation of eggs and the care of the chicks developed there and various developmental stages at the nest site. Whereas 2 nests we found as abundant nest in particular area. So this map shows the number that up to 1 to 13 I have shown in this the map. These are the nest sites as I will try to explain that the 2 nests were found near Maitri station and then in various parts again here. The major highlight of the observation of nest of this South Polar Skua, the nests were near landlocked lakes. As we know, there are various kinds of lakes we found in Shemachur oasis. Major are landlocked lakes, as the Priyadarshini we found there. We found 2 nests and near Long Lake as well as around the Maitri station in various parts, as I've mentioned here in arrows, we found these nests. So data I collected by using the GPS markings, that lat long I may mark there. I marked the nest and we found the 13 nests. So for searching this nest, there was no way other than walking this hard terrain of the Shemachur oasis and ups and downs and boulders and the rocky area and mountains and hilly area. I crossed nearly entire Shemachur oasis except the extreme parts that Dakshin, that is Digi Snout, what we call. But I reached to Novo station, Novo Lazarovskaya station of Russia. Near that also we reached, but in extreme other end of the Shemachur oasis we could not reach due to lack of time and so on. So this is the environmental temperature I recorded, and I had a very small probe thermometer with me, and I tried to measure these things, and I used this thermometer for measuring the temperatures. So these are this is the data shows the landlocked lakes, pro-glacier lakes and epichelf lake, and this was possible by this photography was possible by using the drone camera. I carried simple small drone there, Spark, DJI Spark, and with that I could see various topography and the lakes where, because I was very new for this, instead of going and searching the lakes, I tried to use this kind of photography. So this is one of the area we searched, that is the continental and sea shelf area, but very few nests we found in such a region. Next, sir. So SCOA is very curious about the human activities, and I'm sure that it never attack you. There is a blame on SCOA that it attacks the human being and it harms or it injures the human being. But the problem is we don't understand the behavior of the SCOA. I never found any attack on me because I wandered around 110 kilometer, maybe plus kilometer area in the whole Shemachur oasis, and I could found 13 nests of that 11 were active, means the SCOA were there. But how to reach there and how to follow the distance, safe distance, as per the Antarctic Treaty, we have to follow the safety measures that the animal should not disturb. I observed this nest by using very sensitive camera with a very good zoom that could see the area from around 1 kilometer up to long distance, and due to that I could see that various activities of this particular bird. So this is one of the photo of field observations and behavioral studies. You can see the SCOA has reached me very close, but I never found any attack on me or any interactions with you. It's very calm bird, I feel. So this is another area of my field studies, and it was very chilling weather. As we know, it was minus 12 degrees centigrade that time. There is a date in November. Next, sir. So this slide I would like to show about the SCOA nesting. It's very highly camouflaged. The nest in one of the left area, we can see this SCOA is at nest site and is in incubation position. And in right corner, we found the chick there and the eggs. So it's very difficult. In first instance, we could not see there is a nest and there is SCOA. We have to see carefully the flight activities and the because it's a very calm and noiseless bird, and it stays for a longer time, up to 1 hour sitting in incubation position. So this is very happiest moment because I was wandering with my buddy person, and I usually wander alone. We reach to the study area, and my buddy person or my accompanying person stays somewhere long distance, and I searched this. I could see the nesting sites. It was earlier side. I will show that it was abandoned nest, but it was a very happy moment that I got the nest. And then this is a very rare scene I found that usually it is well known that SCOA laid 2 eggs and it incubates. But I could see in one of the nests from active 11 nests, 3 eggs were laid, and 2 were under incubation and 1 chick already developed. And it may be some exception, or it may be a rare activity. I don't know. So this is a simple, very simple nest. There is no any nest material. Whatever the loose ground they get, they scratch in a circular manner and used to sit there. But the specialty of this nest is the temperature of the nest site proper, nest area, nest proper is definitely it was more up to 10, 12 degrees centigrade. When if environment temperature is -1 or +2 in this range, the nest temperature I measured, it was 12 degree or something, 12.5 degree in that range. So the chick rearing process in the nesting site, the food for chick was omitted by the parent SCOA. What they carry, the food items consist marine fish, the snow petrels, Adelaide penguin chicks, and the kleptoparasitism kind of a mode. So this is another different kind of a mode of feeding. Why we observe in the SCOA that they chase other birds and they snatch the food from their beak and they carry to the nesting site. Any food which they carry, that is in the engulfed form, and that was carried to the nest site. They omit that, and it was fed to the parent SCOA, which remained there for care of the chicks as well as so this is the way food omitting and share to the partner SCOA and the chicks what we observed. So here this is in a site near the station. And as the title of my presentation, it was a brutal.
You have 3 more minutes, Professor Chavan.
Yes, sir. I'm going fast. The thing is, by very sincere care, the both parents SCOA day and night, they carry the food from sea and nearby area. They also scavenge the food, the dead bodies and all that dead material they carry. But the chick, with the intention they rear, they also kill the same chick which they reared. And I found, next slide, sir. This is the way they kill their own chicks. So I found the nesting success percentage value as mentioned here, and the hatching success was very good, 65%. The fledging success was very low, 6%. The breeding success was 0. The breeding success means whatever progeny they grow, none of the chick up to the last highly developed stage, that is fledging stage, could develop there, because they cannibalize their own chicks, their own eggs, and the highly, that is advanced stages of the chicks, the parents kill them. And this was very wonderful and very nervous for me, that I monitored this all activities for 3 months and I could not get the final success. This SCOA which came there, they completed breeding and they reared the chick, but they killed the chicks. And this was very wonderful observation. I will say the very nervousness for me, that I could see the very small chicks, but final result was 0. So in these are various days of age, the chicks were killed. This is a predation time, what I found. So the final conclusion is, in Shemachar oasis, 13 active nests, 13 total nests were found. Active nests were 11, and the cannibalism of all stages of the brood, that is eggs, chicks, then fledglings, advanced fledglings, they were cannibalized by same parents, but not from the other nest. So same nest, they killed their own brood, and final result was 0. So it need I don't know why this happened, but it need continuous observations. I was in 39th
I think your time
Antarctic
is.
expedition. Yes, sir. Yes, sir. Yes. So it need continuous observation. This is my conclusion. Thank you. Any questions from audience, sir?
No, there are no questions. So we may please go ahead with the another presentation then.
Yes, sir. Thank you. Thank you very much.
Thank you, Professor Shivaji, for a nice presentation. Now we will move on to the next presenter, Jensen V. George. Please unmute yourself and share your screen. Yes. Make it full screen and go ahead.
Can you see my slide and hear me?
Yes, we can see it, and make it full screen and start your presentation.
Yes. So my name is Jensen, and good morning to you all. And we'll be talking about upper ocean mixing during austral summer in Prithvi region of East Antarctica. So these days there is a huge hue and cry about sea ice variability in Antarctica for right reason. But in this presentation, we are talking from a different perspective, not from the climate perspective, but from a perspective of the feedback from ocean, that too from the small scale processes. So it is quite intuitive to see the required preconditioning for sea ice formation in the late summer is quite simple. It is the reduction of heat content in the upper mixer layer to freezing temperature. And then because it's saline water, brine ejection is the second step, and third is the sea ice export. If sea ice export is necessary to continue the production of sea ice, because if sea ice is not exported, the existing situation is insulated, and further sea ice production will stop. So these are the three steps before the sea ice production. And now the next question is, what is the role of small scale mixing in the sea ice production? So mixing mainly influence the reduction of heat content in the upper mixer layer, and it can be both way mixing. Mixing can be horizontal or vertical, but typically we see a major role for vertical diapixnal flux across the base of mixer layer. And vertical mixing also helps in exporting the salt, which is rejected or oozed out of the during the sea ice formation from the sea ice crystals, and the salinity, the salt has to be exported downward, or otherwise there will be a balance and the further sea ice production will stop. So mixing helps in these two ways. And we will now focus on the temperature, because we don't have much of mixing observation during the ice formation period. So this is the temperature profile of temperature and salinity profile during summer and winter. Winter is shown as dotted lines, and summer is shown as thick line, and very thick line represent all air condition. So you can see from in the winter, the winter temperature is very uniform in the mixer layer, and the thunderbolt symbol or the lightning symbol shows that the turbulence reaches very deep to the major thermocline. But in summer, as this sun comes up, light intensity increases, heat trapped in the upper layer, and a warm upper layer will form, while maintaining a temperature minimum layer in the subsurface layer. So this is where at late summer microscale mixing has role. If we mix this low temperature minimum layer with the subsurface layer, there can be reduction of heat content, and it can easily start the production of sea ice, or in the onset date of sea ice production, freezing time can be well before the main winter starts. So onset time and CA's production rate is very much controlled by the subsurface mixing. This is our study region. This is Spritz Bay. Spritz Bay is the third largest bay in Antarctica, and this is possibly one of the regions where deep water formations, still solid informations are not there. One or two observations are there, but not regular observations are there. There is a wide shelf in the region, and there are a lot of bathymetric features. So our observations were scattered throughout the Spritz Bay region, and we were focusing on Spritz Bay region. So this is the Southern Ocean Expedition 2019-20 cruise track, and as you can see, our cruise track majorly transfers across the deep ocean slope and shelf. And we made several meridional section across the Spritz Bay region, and the idea was to understand the open ocean coastal water interaction in the Antarctica. And why we are interested in this interaction is because there is a lot of heat supply from open ocean side to the coastal waters. So these are the hydrography of Southern Ocean, and you can see we have a the inset is small, but you can see that the inset, the first panel, the leftmost panel shows the shelf section across the zonally across the Spritz Bay, and then we have a slope region zonally across the Spritz Bay, and then we offside region and a representative temperature profile also shown in the lower panels. And as you can see, the shelf region, we don't have a temperature minimum layer as kind of things. It is just two layer, one a high temperature layer, mixed layer, and then suddenly a thermocline region, sharp thermocline, and then suddenly very low temperature. And most of the temperature is in minus, less than 0. But freezing, remember that freezing temperature is less than -2. So we didn't reach there. And as you go to the slope region, our temperature is still less than 0, but we have a temperature minimum layer exactly roughly around 75 meter, and then temperature increases. And as you go out of the coastal waters, like at offshore region, we will get a very sharp and proper temperature minimum layer with minus degree temperature, and then the subsurface values increases higher. So from this it can be very clear that the mixing between mixed layer and the thermocline region is an important way of reducing heat content in the mixed layer. But it also depends on the stratification we experience. So you can see the salinity. Salinity also pretty much forms same way. The upper layers are relatively fresh, and down below are high saline waters. And the more important part is the Brent-Weissala frequency, the stratification. You can see that the temperature minimum layer is highly stratified. So if the mixing has to occur, the stratification has to break, and then mixing has to occur. So I have mentioned that there are horizontal intrusion as well. So this is an example of horizontal intrusion. This is a meridional transect across our shelf, slope, and open ocean. And you can see open ocean region, the right top of the temperature section. The open ocean regions are really warm, and the coastal waters are cold. So if these warm waters intrude to the shelf region, there can be serious repercussion of sea ice melt, calving, and subsurface sea ice melt. But the problem again is that the subsurface intruded water has to reach subsurface, and mixing has to break the existing strong stratification as shown in the lower right Brent-Weissala frequency section. So now measuring turbulence. So how we will measure turbulence? Turbulence is nothing but fluctuations of velocity. So we have to measure fluctuations of velocity at the millimeter scale. So the most straightforward method is a shear probe, where the shear probe sensor has roughly 0.5 millimeter in size, and if it interacts with velocity fluctuation, it bends, and when it bends, it produces a current, and which gives the rough shear of the water column, and we just free fall the shear probe. Other method is velocity meter, which directly calculates the velocity fluctuation, but this velocity meter and ADZP has limitation of the minimum observation size. It can't measure 1 millimeter, it measures at the scale of maybe centimeter. So we will focus today on the micro shear structure probe, and assuming isotropy, the rough estimate of epsilon, the turbulent kinetic energy dissipation rate is 7.5. Mu is kinematic viscosity and shear. Because there is a lot of noise associated with the small scale shear, we typically convert the shear into wave number spectrum and then we infer the epsilon. So these are the locations. The left side panel shows the sea ice area fraction and our microstructure observations. You can see some of the observations are underneath the ice. What we do is we take the ship and push the ice a little bit. We'll make a free area and then we will do the microstructure observations as shown in the right hand side figure. And the red dots shows the location where we have lowered ADCP with us. So this is the distribution of turbulent kinetic energy. One thing we have to understand about turbulence is that it is highly transient and highly variable. And transient means it changes with time, and variable with what I mean is that it's high spatial variability. So as you can see, turbulence typically varies from the 10 raised to minus 11 watt per kilogram to 10 raised to minus 2 watt per kilogram. 10 raised to minus 5 and above is considered very high values. And our observation is typically upper layer is 10 raised to minus 6, and by the 150 meter depth we will go to the background value of 10 raised to minus 9. You can see we have three sections: offshore section, slope section, and shelf section. We see pretty much same variability throughout, but in later stage we'll find that our offshore region has a better higher variability than the shelf region has a higher variability than the offshore region. So what we have to understand is here from this figure is that the upper layer is highly turbulent and subsurface regions are stratified and their turbulence is weak. But occasional patches of 10 raised to minus 7 are there in the thermocline region. So this is a sample profile where the rightmost is the temperature, and you can see this 40 to 60 meter is the region where thermocline is there, and then we have turbulent kinetic energy rate. We typically
Jensen, you have only 3 more minutes remaining, so you may please summarize the result.
Sure. So we have turbulent kinetic energy mixing. You can see that it typically depends on 10 raised to log 10 scale. So you can see it is of the order of 10 raised to minus 8. What we have to interestingly notice is the stratification is of the order of 10 raised to minus 4, and the shear generated both by the lowered ADCP and shipborne ADCP showed in the third panel is of the order of 10 raised to minus 5. It clearly shows that the water column is highly stratified, and it results in very weak eddy diffusivity. So this is the thermocline mixing variability with depth, and we segregated our old station with respect to station depth. That means offshore and shelf. You can see that the offshore regions are pretty much hovering around 10 raised to minus 8 watt per kilogram, and our diffusivity is of the order of 10 raised to minus 6. But you can also see that at occasionally this thermocline diapicnal heat flux at the thermocline is reaching up to 10 watt per meter square, which is quite high. And if it lasts for one day, it can cause strong heat content reduction for the mixer layer. And all diapicnal heat flux were downward. That means all diapicnal heat flux was from the mixer layer to deeper layer. So in summary, turbulence mixing is highly variable, transient, and strong mixing has potential to alter the heat content and thus influence the onset of ice formation. Our observation consistent with previous studies. The temperature, mixing rates we observed is comparable with the previous studies. But the takeaway message from our observation is that for better understanding the system and prediction, addressing and monitoring small scale processes are very necessary. Thank you very much.
Thank you, Dr. Jensen. And let me congratulate you for this wonderful presentation. And there are no questions in this talk also. So if the chairman permits, can I ask one question?
Yes, please. You go ahead asking question.
Okay, sir. Thank you, sir. Jensen, what about your this underwater radiation budget in the mixed layer? I mean, particularly in the mixed layer.
Yes, yeah, that is important. That is important as well. But I was focusing only on the small scale processes in this thing. That's why I didn't address that part.
Okay.
But the underwater radiation budget already incorporated in the temperature profile.
Okay.
So whatever flux happens, it
Okay.
happens addition to whatever that happens.
Okay. Okay. Thank you.
Due to radiation, because it's already incorporated in the temperature profile.
Okay, thank you, Jensen, for nice presentation. We now move on to the next speaker, Jane T. Bhaskar. Jane, you please unmute yourself and share your screen.
Yeah, can you see the screen?
Yes, we can see your screen. Make it full screen and start your presentation.
And am I audible?
Yes, you are audible.
Okay.
Can you make it full screen?
Yeah. Yeah. Okay. Good morning, everyone. My topic for today is mixotrophic plankton and Xenococcus distribution in waters around Svalbard, Norway during June 2019. I'm Dr. Jane Bhaskar, DST Women Scientist in NCPR. In the present scenario of global warming, as compared to the lower latitudes, the higher latitudes are very vulnerable and sensitive to minute changes in the climate. Previous studies have indicated that the air temperature, atmospheric air temperature, has increased by over 3 degrees in the Arctic region from the year 2000 to 2014, as compared to the previous years of 1971 to 2000. Whereas the Arctic Ocean temperature has increased by over 2 degrees Celsius over the last 20 years. So this has consequently decreased the ice cover, and this sea ice is projected to further decrease by the end of the century. And the Arctic Ocean temperature is projected to increase by at least another 7 degrees by end of the century. Such changes in the temperature will cause the marine organisms that are surviving in the Arctic, in the polar regions, to the small shifts in temperature. They are susceptible to these changes. NCPR launched the Arctic program in 2011, and the flagship Arctic program is concentrated on the Kongsfjorden region in the Svalbard, Norway. And this is a major site for the Indian Arctic program studies. And this site has been studied from the year 2011 onwards. The main objectives of these studies are carbon dynamics, the food web structure, and the biogeochemical cycles. To give a brief overview of the Arctic ecosystem, we see that there is a very short summer period from July to August, where the temperatures are warmer and there's 24 hours daylight, which has increased glacial meltwater, and because of which there's an increased nutrient supply and increased primary production. Whereas contrastingly, the winter is longer from October to March, and it has 24 hours darkness, and the productivity is restricted to the ice algae. So as I said earlier, from 2011 onwards, the Indian Arctic program is concentrating on the Kongsfjorden and Crossfjorden region. There is very less information available from other regions in Svalbard archipelago. Therefore, with this objective in mind, we got the opportunity to study different other regions in the Svalbard region, and we had the objectives were selected as the phytoplankton community structure, the picoplankton and bacterioplankton distribution, and factors regulating the distribution. So to give you a brief idea about the Svalbard region, this archipelago is situated from 76° north to 80° north, and from 10° east to 28° east. If you can see this red line which goes from south to north, this is the warm West Spitsbergen current, which flows northwards, bringing the warmer Atlantic waters into the Svalbard region. This increases the SST and makes the southern and the mid regions ice-free, whereas the Arctic waters, which are shown in blue, the cold Arctic waters, come from the Arctic Ocean, and as a result, it brings the cold frigid waters, and the northern regions are mostly with affected by the cold waters. And in summer, the previous studies have shown that the phytoplankton population is not diatom dominated, and the SST ranges from minus 1.8 to 3.5 in the northern Svalbard regions. Coming to this study was undertaken by the National Geographic Explorer during 19th to 25th June 2019. For this study, we had 6 stations, one along the southern part of the Svalbard, which is a nesting site for black-legged kittiwakes, and the western and the eastern Storfjorden, which is influenced by the freshwater influx during summer, and Belsen region, which is station number 5, which is a close landing site for seabird droppings, and the open ocean in the north, which is influenced by the Arctic waters and the warm Spitzbergen current waters. And the parameters analyzed were nutrients, phytoplankton, heterotrophic nanoflagellates, bacteria, picoplankton, and SST, that is sea surface temperature, chlorophyll, and TSM was done by remote sensing. Okay, coming to the results. The SST ranged from 1.2 degrees Celsius in the north to 3.7 in the south of the Svalbard region. These black star marks are indicating of these stations. And if you see, this red marking is very close drift ice. And the northern stations are influenced by the drift ice, whereas the southern stations are not influenced by the drift ice. There is a Storfjorden, these S2 and S3 stations were comparatively warmer as compared to the northern stations. And throughout the station, the nitrate and phosphate was limiting throughout the study. However, the silicate concentrations were higher and ranged from 0.46 to 5.39 micromole. The TSM was lowest at S6, whereas it was highest at S3 because S3 gets a lot of meltwater into it. Then there was an inverse trend observed between the TSM and phytoplankton abundance. We did a flow cytometric study of the picoplankton, and this is a reference material which was used, and this is the field sample. As you can see, in the field sample, based on the size structure, we could only find the presence of Synococcus. Synococcus was observed in the northern Svalbard and along the western part of Svalbard in the year 1999 to 2004. These values were there only for that. This study was done only for the last decade. But in this decade, we have done the flow cytometric readings, and we still find higher abundance of Synococcus in these waters as compared to previously observed. And the abundance of bacterial counts were also observed at the mid waters, which were close to the glacial meltwater, S3. Cryptophytes, one of the mixotrophic, was observed only in S5, the northern stations. Whereas if you can see, the dinoflagellate contribution was throughout all the stations, and the diatom was only seen at the open waters. Moving further, we see that the distribution, as I said, the distribution of diatoms were only seen at the northernmost stations, S5 and S6, and navicular distance was the only diatom which was observed. This could be because of this coincided with high TSM, because the TSM reduces the euphotic depth, and this could be one of the reasons why it affected the low phytoplankton abundance. However, we have found a lot of the dinoflagellates, and the diversity of dinoflagellates also were more compared to the diatoms, and the ciliates also were found at most of the stations, but highest at the open, northernmost stations. And chlorophyll showed a significant correlation with picoplankton and nitrate. The less diatoms will be due to the nitrate limiting conditions and high abundance of the Strombidium species, which is one of the ciliates which feed on the diatoms. So take-home points from this study are: it is a first report of Synococcus species in Svalbard waters under the Indian Arctic program using flow cytometric data. And a clear north-south gradient in sea surface temperature was observed, with the lowest being there at the northernmost station and the highest at the southernmost stations. The SST was warmer than observed, was warmer than previously reported. In previous studies, it was reported at minus 1.8 to 3 degrees, but here we have reporting higher temperatures. And less diatom was there, and phytoplankton and the abundance of phytoplankton also was lower. This could be due to the nitrate limiting conditions and high TSM and high abundance of the ciliate Strombidium species, causing grazing pressure on the phytoplankton. The dominance of the mixotrophic dinoflagellates were observed, and the Synococcus has contributed to the chlorophyll A by the linear significance we are seeing between Synococcus and the chlorophyll A. The conclusion here of the study was the dominance of Mixotrophics and Synococcus species may fuel the microbial loop as compared to the traditional classical food web, where it is diatom dominated. So this could be an alternate carbon pathway in the Svalbard region. The presence of Synococcus and warmer SSTs may be due to the increased influence of the warm Atlantic waters which are being brought in by the West Brisbane current. For further details on this study, you can, we have already published this paper in Polar Science, and I would like to acknowledge my mentor, Dr. Sharat Tripathi, Director NCPR, Ministry of Earth Sciences, TST WASE, and all the contributors for making this study possible. Thank you.
I think in this presentation also we have no questions, so we may please go to next presentation.
Yes, thank you, Dr. Jain, for your nice presentation. And we have now next presenter, Sahid. So Sahid, unmute yourself and share your screen. Yes,
Sir,
yes, we can see it full screen. Start your presentation.
Okay. Thank you very much for giving a chance for presenting at Osicon 2021. I will be talking about our NCM modeling system. We have a couple of model system and the standalone ocean system here. We are running it in forecast mode, and I will be doing presenting some of the evaluation of those ocean forecasts. In fact, so at NCM we have a different kind of modeling frameworks, and of course we have for the medium range forecast in the atmosphere. We have the NCM, it's 12 kilometer daily forecast up to 10 days, and it is running global. And also we have the coupled model, which is a coastal version of the atmospheric coastal resolution in the atmospheric, but we have the 1/25 1/4 degree of the fourth in the ocean resolution, in fact. So it's not moving. Okay. The ocean system, the coupling system, actually you can see that we have the CIC model and the Nemo ocean model, and the NCM atmospheric model. That is a 12 kilometer model, and you have the land surface model over here. And the global data simulation running, we are having global data simulation system over here, which is having 25 kilometer resolution in the ocean, and which is posted with our NCM forecast. In fact, atmospheric model, we have atmospheric model 12 kilometer. In fact, that is we have 10 days forecast here. That is posted with the model is posted with NCM 12 kilometer daily forecast. In fact. And then we have the 15 days couple model, which is actually we provide initial condition for the atmosphere, both the atmosphere and the ocean, in fact. And it is run for 15 days. And then we also have extended range forecast, which is we have 6 ensemble members and then 4 initial conditions in a month, and it's forecasted for next 4 weeks, in fact. And of course, as I already mentioned, in fact, the couple model, we have the N26-216 resolution, 0.83 approximately in the atmosphere, and then we have the tripod of 0.225 degree in the ocean, in fact, with 75 levels in the ocean depth, in fact. So I'll be, we know that actually Antarctic and Arctic, we know that is completely opposite of the seasons. In fact, we have the peak seasons in the Atlantic in September. We have the maximum sea ice, whereas September sea ice in the Arctic is actually minimum. And the February, March season, you can see minimum sea ice in the Antarctic. And if you look at this climatology, you can see exactly over here. March, you have the minimum sea ice. February, March, you have the minimum sea ice, and the peak comes in the September. If you look at this movie, you can see that there is large spatial variability you can see in the model, because it is starting from February, January, February, and then sorry. Slide is not moving on.
Yes, no problem. Go ahead.
Okay. We can see that actually there is large variability. Suddenly, you can see that after February, March, and the winter starts in the southern pole, the sea ice is expanding extremely all part of the Antarctic region. And if you zoom into the Maitri region, in fact, this is actually the forecast that we used to give to NCPR when they go for expedition to Southern Ocean and Antarctic. And you can see that, of course, in every day, actually, you can see the sea ice. This is, generally, you don't see multi-year sea ice in the Antarctic region, but exactly opposite to what we see in the Arctic. But you can see that actually due to the ridging process happens in the Weddell Sea, you can see a lot of thick sea ice have been formed in that part of the region. And zoom into, you can see Maitri region, you can still see, if you look at, if you zoom it, actually, you can see that there is large variability over there, in fact, because the sea ice is moving. If you go over there for an expedition or any kind of scientific activity, you can see that the sea ice is varying so fast, in fact, every day. So these forecasts are very important, in fact, so that actually we are just assessing how this forecast looks like, in fact, how actually you can see that the upper one is actually our NEMO standalone model, which is actually we forced with the 12 kilometer our NCM forecast, and then down you can see the couple model, which we provide initial conditions, and then model runs by itself by extending the fluxes to the coupler, in fact. So you can see that because both have different characteristics, you can see that we can in the sea ice edges, you can see some most of the negative biases in the sea ice edges, day 1, day 5, and day 9 in the standalone model, which is actually forced with very high resolution, comparatively very high resolution atmospheric forcing, in fact. And but here you have the post resolution atmospheric version, in fact, even though the ocean version is actually the same as the one above, but extremely different characteristics you can see. In fact, the biases are different from what you see in the standalone model. This could be because of the coarse resolution in the atmosphere. And in the sea ice thickness as well, you can see that in the interior sea ice regions, you can see that the sea ice biases are, there is a positive biases in the couple model, in fact, compared to the standalone model. And if you look at the Weddell Sea, actually, as we see, actually, we have seen that there is thick ice formation in the Weddell Sea due to the sea ice drift against the shelf regions. And you can see this over here as well, in fact. This is a sea ice drift bias, in fact. So if you look at, there are, compared to the standalone model, you can see a little more thicker, more bias. You can see bias per person. You can see against the shelf region, so that the model of simulation also the bias will be more. In fact, in this region, in fact, you can see these biases over here could be because of the strong drift against the shelf region, which is actually due to ridging process, the thickness having formed in that region. In fact. So that was actually for the September, July, August, September 2019. In fact, this is actually March, April 2019. In fact, this is a time actually during which we give a forecast for NCPR. In fact, you can see that, of course, if you Maitri region, if you zoom into like day forecast from day 1 to day 15, the biases are getting increased like from day 1 to day 15. But the good thing is that you can see the entire Antarctic, you can see that from 1 million square kilometer to almost 6 million square kilometer within 2 months of time, the sea ice has been growing. In fact, once the growth season starts, actually it's an grows exponentially. In fact, so even day 15 itself, you can see the blue line is observation. From day 15 is where the model can exactly clearly give an indication of the fast growing sea ice in the Antarctic region. In fact, this actually another we have done a seasonal endcast for 14 seasons, and then we have looked into, because it's a couple model. In fact, we wanted to see how the couple model system responds from atmosphere and the ocean, and how the sea ice is represented. So you can see that sea ice, this is basically the sea ice thickness, in fact, and then you can see sea ice thickness biases in the exterior sea ice region, negative bias. In fact, the model is underestimating sea ice impact. So we have looked into the counterpart in the other parameters in the ocean as well. So what we have seen is actually wherever there is a warm bias regions, from there is a polar current bias from those warm bias regions, that actually spreading most of the Antarctic sea ice regions, and then that warm bias causes would be one reason for the negative underestimation of sea ice, apart from the model ability to simulate the sea ice. In fact, and we have a couple more system. We have looked into 10-meter wind. The 10-meter wind actually there is an anti-clockwise pattern you can see in the Antarctic. Similarly, you can see that even in the sea ice drift also you can see that pattern. In fact, and these tick, you can see a negative bias over here, and there is a slight positive bias over here in the Bharati entire region. In fact, that could be because you can see the sea ice drift is actually here. There is a drift away from the shelf region, and there is a drift towards the shelf region, the ridging process. So you can see that the model could be giving a negative bias. Means sea gas has been underestimated in that region. In fact, so as a whole, actually, this is actually a global modeling system we have, and then when we assess the skill of this model, of course, the model have got good skill in predicting sea ice.
You have 2 more minutes. You have 2 more minutes.
Yeah, I'm finishing. So, skill is good actually, but of course, we are giving this forecast to NCR whenever they go for. Last 3 times we gave NCPR this forecast. Definitely, about the sea ice, I don't know how much helpful for them, but at least to get a large view of sea ice, it may be helpful. And moreover, the wind forecast that give definitely will be helpful for them. It was helpful for them actually, as we heard from them, like this forecast for planning that journey. And of course, mainly the sea ice detacher from the main sea ice area will be the most difficult thing for navigation. But anyway, I mean, high resolution models in the coming years, and of course, attached to that, actually, the floating sea ice models will be helpful in navigation as well. In fact, make it more comfortable. Thank you.
I think in this presentation also there are no questions. And can I please ask a question, Mr. Said?
Yes, sir.
It's a very good presentation.
Thank you, sir.
Just I have a question, like do you force the model with a realistic representation of the actual physical processes that influences the Antarctic sea ice? I mean, the true conditions I'm talking about. Like you might have heard.
Yes, sir. In fact, actually, we are forcing with the real.
Yeah, like you might have heard the presentation from Dr. Jensen. And or you use the default boundary conditions, the climatological conditions.
Yes, yes. Actually, no, this is actually real forcing. In fact, actually, we use our own date. We have our own NCM model. We have the NCM model, which is giving a global forecast in the atmosphere. So that forcing we use to force the ocean model. In fact, the real model. In fact.
Okay.
And in realistic way, and then we get the ocean forecast back.
Okay, thank you, Sahid, for your presentation.
Thank you, sir.
And we are running late, so we'll move on with the next presentation, Dr. Divya David. Yes. Yeah. So please share your slide.
Yeah, sure.
Yes, make it full screen. Yeah.
Sorry, Dr. Imles, there is a question. So shall we ask Mr. Sari to answer that?
I think now we have already moved on, so I think we can.
Okay.
Yeah, so we can start with the Dr. Divya. Yes. Please go ahead. Yes.
Thank you. My name is Divya David, and I'm working at National Center for Polar and Ocean Research. Today, I will be giving an overview of our 5 years of Indian Arctic Christendos Indark mooring, which is deployed in Kongsfjorden, a Svalbard fjord, which Dr. Jain has already talked quite about. So this mooring program, the other researchers associated with are Dr. Subesh, Mrs. Archana Singh, and Dr. Ravichandran from NCPR, and Mr. Keshav Kumar, Mr. Arul, and Dr. Venkateshan from NIOT. So, as Dr. Jain has already talked about the changes that the Arctic undergoes in the recent times. And like she told, the Arctic has warmed by 0.75 degrees Celsius, outpacing the global average. And the predictions also shows, since Earth approaches 2 degrees Celsius warming, the Arctic region may reach an annual mean of 4 degrees Celsius. And the other relevant and serious implications that we observe in Arctic are ongoing land and sea ice loss, increased precipitation, methane emission, greening, the state shifts and species invasions, threats, wildlife and traditional human livelihoods. And this may also causing extreme weather changes at the lower latitudes. So these changes are also seen and reported in our study site of Kongsfjorden. So this picture shows the loss of land and sea ice loss from 1922 to 2017, where in the last picture, you can see a chunk of glacier has carved out of the main glacier and has fallen to the fjord system. And there is an evidential increase in precipitation, which NCPR is studying. And for handling and to find out the reasons and mitigate it, and international cooperation is very crucial. So coming to the setting of Kongsfjorden, as Dr. Jain already told, it's the West Spitsbergen Fjord, east of the Franz Strait, which is the largest opening that connects the lower latitudes with the Arctic. It is a small fjord system whose length is 20 kilometers and the width varies between 4 and 10 kilometers and having a maximum depth of 400 meters. And two contrasting currents flows to the west of the fjord that carrying warm saline Atlantic waters from the North Atlantic region by the West Spitsbergen current at the slope region, while cold fresh Arctic waters brought by East Spitsbergen current at the shelf region. So this contrasting currents always causes the dynamic instabilities that further results in the intrusion of the Atlantic water into the fjord. Therefore, this fjord always undergoes seasonal shifts between Arctic and Atlantic predominance. The winds are by moderate And mean annual freshwater discharge is approximately 1.4 kilometer cube with 30% annual variation. And the recent reports and studies shows there is a substantial decrease in the fast ice coverage in this fjord over the last decade. And the fjord has more Atlantic water inflows than even the southern fjords because of its topographical reasons and this more dynamic instability is happening at its mouth region. The fjord has shown a warming over the recent years with high Atlantic water intrusions. And coming to our intact mooring, the mooring payloads measures different variables at discrete depths in the using Seabird CTD ODO, then Teledyne ADCP, NOTEC current meter, single point current meter, photosynthetically active radiation, fluorescence, chlorophyll, and cyanonitrate sensors. And we have two more sensors in collaboration. The one which measures the ambient noise in Kongsfjorden with NIOT Ocean Acoustics team, and another PCO2 sensor in collaboration with Norwegian Polar Institute. So the first picture on the left-hand side is the mooring layout of Indak. And the upper portion, you can see a small yellow float, which is the weakling assembly part. So this is a technical design that we made particularly for the polar region in Arctic. And this weakling, if the ice, a carved ice portion is coming to the fjord, then and it's hitting the mooring system, then this weakling assembly will be detached. We have sensors in this weakling assembly, but it will not be lost as there is an Argos beacon also attached to it, which will send the signals so that we can retrieve it. Same thing has happened recently, last month, and we have retrieved that weakling assembly with two CTD audio sensors. And the rest of the portion is yet to be recovered in August, by end of August. So the mooring was first deployed in July 2014 at Kongsfjorden. And here is the overview of mooring data availability, the mooring data that we collected so far from July 2014, and it is ongoing. The last is ongoing. So this orange shade shows the data availability. We have the data collected at a resolution of 1 hour for all the sensors except ADCP currents, which measures at 4 meter depth, brings and 15-minute time interval. So coming to the data and the signs, the internal variability in Kongsfjorden is already a reported part of science. And this is the water temperature, water temperature over the years. And from this, we see that 2017 is the warmest year, closely followed by 2014 and 17. So this is the subsurface mooring. So here what you observe is from below 20 meters. And here comes the salinity. So 2017, as I told, is the warmest and most saline year. Subsurface warming with the temperature greater than 3 degrees Celsius is detected till January, February, which are actually the winter months in 2016 and 17 years. The temperature minimum was observed in February or March, which is actually delayed than the earlier decades. Salinity minimum was observed among these years in October 2015, followed by 2017. And these lower salinity coincided well with the highest air temperature records. That particular picture is not presented in this presentation, as my focus is to give the overview of the data collected and the direct signs from the data, observation data. So coming to the 5-year mean, monthly mean fjord water column temperature and salinity. The upper picture is for the temperature. The middle one is for salinity, and the last one is the depth average of this. So as we have seen already that the winter water column have never attained a freezing point during our observations, any of our observations. Temperature maximum of 4.4 degrees Celsius was observed in 3 months from September to November, and minimum was obtained in the month of March. Mean salinity has never been below 34.65 PSU during the observations. The salinity maximum of 34.86 was observed during April, June, and minimum was observed in October month. Now we have compared this 5 years of our data with the past data that has been published. by the Norwegian Polar Institute. So here the left-hand side picture shows the temperature at 100 meter depth, and the right-hand side is the salinity at 100 meter depth. So the blue dotted line is our mooring location. So here you can see that the earlier decade, from 2001 to 2010, the temperature at 100 meter is not going much higher than 3 degrees Celsius. And the salinity on a mean is of 34.7 to 34.6 to 34.7 PSU. And this is the depth average figure. The red line is for the summer period, and the blue one is for the winter period. But as the summer is more continuous data is having during the summer season, we are focusing on this red line. So the right-hand two plots, upper one is the temperature and below one is the salinity, which is collected by the India from 2011 using the portable vertical profiles, CTD profiles, followed by the mooring, summertime of the mooring data. So this shows that the mean summer temperatures were less than or equal to 3 degrees Celsius during 2001 to 10, and greater than 3 degrees Celsius during 2011 to 19, which includes our observations. While salinity showed a gradual and very slight increase over the last 2 decades. The rate of increase in the summer water temperature from 2011 is found to be 0.12 degrees, which is again increased from the earlier decade earlier. And to understand this increase in the Atlantic water temperatures over from 2011, we have analyzed our observational data, and we have used the ROMS model set up for our study region. And it has been shown that the high subsurface floor temperature is related to increase in Atlantic water intrusions as found in the observations and ROMS simulations. Coming to the details of the Atlantic waters, this is the Atlantic water, which is characterized by the temperature greater than 3 degrees Celsius and salinity greater than 34.65 during our observational period. And this is the second picture is of the time series net fluxes, the net atmospheric flux and the fjord flux. So here we can see that even—
You have 3 more minutes.
Okay, net atmospheric flux is negative, where it is a low term. Our fjord flux was seen increasing, which coincided with the periods of Atlantic water advection as seen in the leftmost left-hand side picture. And this is the ADCP current that we have drawn for the upper and lower layers. And this shows clearly a current that is flowing towards the fjord, inside the fjord, during the periods of strong Atlantic water presence. So hence, we are concluding that the ADCP is acted as a tool to verify periods of Atlantic water advection, and the flux analysis also came out as a way of detecting Atlantic water advection periods, and it can be used to determine the advection in case of current data unavailability. And we have checked, related it with larger scale climate modes, such as the North Atlantic Oscillation Index and that Arctic Oscillation Index, which is dominant in this study region. And that also has shown that most of the time when the NAO was in its positive phase, more Atlantic water was seen flowing inside the fjord system. And here comes the sensor-based higher resolution fjord biogeochemistry. The first picture is for chlorophyll, second one nitrate, third one photosynthetically active radiation, and fourth one is turbidity. So all these biogeochemical variables showed strong seasonality, and the spring blooms, which is this, in the Arctic region, here, as in our data, coincided with the drop in wintertime high nitrate and increase in the photosynthetically active radiation. The spring bloom started in April, and it has never stopped actually. It is just extended with a reduced biomass till end of the summer period, which is, this extended period is actually longer compared to the earlier decades. This data, which is a high resolution data at a hourly resolution, enabled us to check the coupling between the physical and biogeochemical variables at higher resolution time scales. And we have checked it for the first year, which is 2015-16, as biogeochemical variables started measured from 2015. So this showed us subsurface blue phenology nitrate variability very clearly. And there was no distinction between the spring bloom and summer and hence chlorophyll. And this bloom actually evolved from rather quiescent autumn-winter seasons and reached an active state in spring summer during the bloom period with return of light and resultant thermal stratification supported by high nutrient availability. And from the atmospheric perspective, winds are found playing a dominant role in the bloom sustenance. During breaks in the spring bloom by high wind events, nitrate rebound due to non-utilization. As these winds calm down, the stratification is again established with the bloom picking up. And the deep winter convection in the fjord replenish nitrate in the upper water column, helping in the further bloom during the spring, besides the glacial melt source of nutrients. Pronounced share of nitrate, the cane was found coming from the Atlantic water intrusions, especially during non-bloom and non-stratified period. So many research is ongoing, published, and is yet to communicate from the data. I have just presented the overview of our observational data, not any other analysis are shown here. So this presentation will not be complete without properly acknowledging the people who have helped and was part of it. So starting with the Ministry of Earth Sciences, I would like to thank then and now directors of NCPR, Dr. S. Rajan and Dr. M. Chandran, NIOT Ocean Observation Team, who are really a part of it, and then acoustics team who have some sensors in collaboration, and the NCPR Arctic Logistics Division, without whom we can never do these things successfully. And then our foreign collaborators, University of Svalbard and Norwegian Polar Institute, Kings Bay, New Allison, and those who have helped us in difficult times over the years, and especially during now the retrieval, which is going to be now, Scottish Association of Marine Sciences, Abbey, Germany, and Inox, Italy. Thank you.
Excellent presentation, Divya. And in fact, there are no questions in the chat box.
Thank you so much.
Yes, thank you, Dr. Divya. It's a very nice and informative presentation. Thank you.
Thank you,
and now we move on to the last oral presentation by Anthony P. Thomas.
Yes, sir.
Yeah, share your slides.
Okay.
Yeah, make it full screen. Yeah.
Yes, sir. Okay.
Yes. Okay.
Okay.
Yes,
So good
start.
morning, all. Good morning, all. I'm Anthony P. Thomas. Today, I would like to discuss about the internal variability of sea surface temperature in the Indian sector of Southern Ocean during austral summer. So we all know that Southern Ocean is the fourth largest ocean in the world, and it is actually very unique due to its circulation patterns, overlying westerly wind belts, minimal solar insolation, and the seasonal formation of ice cover. Southern Ocean is also the region where the Antarctic bottom waters are forming, and hence it is considered as the limb for the global conveyor belt. So the Southern Ocean is also a region where the formation of eddies are happening. These eddies are helpful in transporting the momentum and as well as the buoyancy fluxes. Southern Ocean, which is actually connecting the Atlantic, Pacific as well as the Indian Ocean, consists of the world's largest current, which is the Antarctic Circumpolar Current. This Antarctic Circumpolar Current actually plays an important role in the transport of global heat, mass, as well as momentum. So the Southern Ocean consists of three sectors: the Pacific sector, Atlantic sector, and the Indian sector. My study is actually focusing on the Indian sector of Southern Ocean. Indian sector of Southern Ocean is restricted from 20 degrees east to 100 degrees east, and is from 35 degrees south to the 75 degrees south, 75 degrees south. So Indian sector of Southern Ocean is the least studied sector of Southern Ocean among the three sectors of Southern Ocean. My study period is from 1994 to 2018. I'm concentrating typically on the summer period, that is the DJF period. So we all know that the SST is a very important parameter because SST is directly related to the heat release, and it is an important parameter to understand the global heat or the global warming. Especially in the polar regions, SST has got a very important role because whenever the SST is increasing, it is actually directly affecting the sea ice melt. So whenever the sea ice melt is happening, it directly affects the thermohaline circulation as well as the global sea level rise. So SST is actually a very sensitive parameter in the Southern Ocean. So in our study, what we are trying to address is that earlier there were no studies which were focusing on the long-term intraannual sea surface, intraannual variability of sea surface temperature in the Indian sector of Southern Ocean. So we tried to understand or we tried to address the long-term intraannual variability, the seasonal variability of sea surface temperature in the Indian sector of Southern Ocean. And we tried to understand what are the features or what are the factors that is affecting its changes. We also try to understand or we try to accommodate the internal variability of frontal positions in the Indian sector of Southern Ocean. Also, we try to understand the impact of major climatic events like ENSO and SAM on both SST variability and the frontal variability. So these are the datasets which we have used completely the open source datasets. For finding, during the study, we have calculated the net heat flux, mixer light depth, the stability, heat content, depth integrated Ekman transport. Also, we have found the oceanic fronts using the criterion which was listed by Anil Kumar et al. 2006. So moving on to my results and discussion. This is actually the observed sea surface temperature variability in the Indian sector of Southern Ocean. So here we can see it is from 1994 to 2018 I have represented. The region within the red contour represents the region with anomalous, sea surface temperature anomaly less than 0.5 degrees Celsius. And whereas the regions within the black region represents the sea surface temperature anomalies greater than 0.5 degrees Celsius. So from this, we can see that in some years like 1995, 1996, 1997, 1999, 2000, 2011, 2017, some years are having drastic anomalous sea surface temperature anomalies. If you're checking the northern portion of Indian sector of Southern Ocean, that is where the northern subtropical front, Agulhas return front, as well as the southern subtropical front are located. There we can see that during the years 1997, 1999, 2000, and 2011, 12, during this period, we can see anomalous warming in those regions. Whereas during the years like 1999, 2000, 2002, 2008, 2011, in those years, we can see very strong cooling near the Antarctic continent. Especially if you're looking at the years like 1999, 2000, as well as 2011, we can see much intense cooling near the Antarctic continent. So we try to understand what is the reason for this. We performed a trend analysis for the sea surface temperature anomaly for the last 25 years period, and we found that the eastern region of the Indian sector of Southern Ocean is having a warming trend with respect to that of the western region. If you're checking, this is the sea surface temperature anomaly of the whole Indian sector of Southern Ocean. It is actually having a positive trend. That is, it is in accordance with the other global scenarios, like it is also increasing. But if you're coming inside the Indian sector of Southern Ocean, we can see that the eastern portion of the Indian sector, the western portion of Indian sector of Southern Ocean is not having that much warming trend, whereas the eastern portion is having a positive trend. This is actually reflected in the heat content variability also. You can see that the eastern portion is, the western portion is having a negative trend, whereas the eastern portion is having a positive trend. Okay, whereas this trend was not reflected in the stability, but still in the both two boxes or two regions, the stability of the water column was increasing. But we can see that more stability was observed at the eastern portion. We tried to accommodate the frontal variability in Indian sector of Southern Ocean. We have already calculated the fronts locations, and from which we used to understand that during the years 1997 and 2000, polar front was shifted around 1 degree south. These are the years when more warmer waters were seen at the northern portion. So when more warmer waters were seen in the northern portion, the polar front was seen to be shifting 1 degree southward. Whereas during the years like 1999, 2011, 2012, where the more cooler waters were seen to near the Antarctic continent, we have seen the shifting of northward shifting of polar front. So we understood that SST has got some influence on the shifting of frontal regions. We try to understand what is the major factor which is controlling the sea surface temperature anomalies. We analyzed the net heat flux variability, but sadly we couldn't find any kind of coherent feature. The SST and net heat flux variabilities were incoherent in nature. So we concluded that the net heat flux is not playing a major role in the sea surface temperature anomalies, whereas maybe advection, horizontal advection as well as vertical mixing might be playing a responsible factor behind this variability. While analyzing the air temperature at 10-meter height, we got a very good correlation. Like the whatever the pattern we were observing in the sea surface temperature, it was reflected as such in the air temperature also. So while doing a correlation of sea surface temperature and air temperature, we got to understand that within the Indian sector of Southern Ocean, the SSTA and as well as the air temperature anomalies are very much pretty correlated. So we got to understand that something is linking this air temperature as well as the SSTA. So we got to understand, we tried to understand what is the climatic event in the Indian sector of Southern Ocean. While analyzing the SAM, we got to understand that SAM was in positive phase during the DJF period of our particular study period. During these years, SAM was in positive phase, and during these years, SAM was in negative phase. Okay, we can see 2011, which was a very very positive SAM year. So during a SAM year, what happens is that the wind belt, the westerly wind belts will be coming closer to the Antarctic continent. And also whenever wind is more, we know that the SST will be cool. Wind will be acting as an important forcing for SST. So if you're checking the 1997, where we have seen more anomalous warmer waters, there the wind speed was very less. Well, if you're coming back to 2011, where we have observed maximum anomalous cooler waters, there we can see strong westerly wind belts associated with strong westerly wind belts, and also we can see more strong winds at that particular region. So we try to understand how the ocean surface is responding to this wind pattern, from which we have calculated the Ekman transport, the net surface Ekman transport. So whenever the whenever the westerlies are stronger, or whenever the westerlies are stronger towards the Antarctic continent, by theoretical definition, we can see that the net Ekman transport will be directed towards the northern.
You have 2 more minutes, so please summarize.
Okay, so yeah. So as per this theory, we have also got, like during the anomalous years like 2011, we can see that more positive, the surface water is moving to the northward. And in accordance with this, we have also seen the positive, the negative anomalies in the near the coastal regions of Antarctica. In accordance with this, we have also got the CS concentration variability. Here we can see that whenever the SSTs negatively anomalous SSTs were observed, during those years, we can see more CS concentration. If you're checking 2011, we can see more CS concentration. Whereas in 1997, we have got positive anomalies. In 2017 also, we have got positive anomalies near the Antarctic continent coastal regions, where we can see that the CS concentration is very low. We then try to understand what is the climatic event, which climatic event is playing the major role. We just try to confirm whether it is SAM or the ENSO. So we performed an EOF analysis, from which the first mode was showing about 30.67% of variance, and we correlated this first mode with the SAM index as well as the NINO index, from which we understood that the SAM was actually explaining more variance than NINO. So we concluded that SAM is SAM is a major climatic event which is playing the role in sea surface temperature variation. So coming on to the conclusion, we have seen that there were the SST variability was majorly observed in several years, and there was a warming trend in the eastern region of Indian sector of Southern Ocean, and it was reflected in the mixer layer heat content also. The net heat flux was not the reason for the sea surface temperature variability, whereas we have also seen the frontal movements in according to the sea surface temperature variability. And during positive SAM years, whenever the strong winds were seen near the Antarctic continent, northward Ekman transport was also observed. And in response to that, we have also seen the cooler waters getting accumulated or shifting slightly northward. And CS concentration was also showing positive anomalies during positive SAM years. So the NEOF analysis was confirmed that the SAM was a major climatic event in the Southern Ocean. So we concluded that when SAM is in positive phase, so together the SAM, the winds, the Ekman transport has made the sea surface temperature to vary in this particular manner. So further studies has to be required to understand the eastern and western anomalous warming, which we have observed in the Indian sector of Southern Ocean. That's all, sir.
I think there are no questions in the chat box.
Okay.
So may I please ask a question, Anthony?
Yes, sir.
The presentation is quite interesting. It is very good. And but I'd like to just add into this.
Yeah.
See, index that you are using, that sum. Sum is basically, it is just an index that you use it for explaining the large scale climate variability of the southern ocean, entire southern hemisphere.
Okay.
So when you are looking into the regional heterogeneity, so I think maybe you need to look into your geopotential height or your means level pressure.
Okay.
So that I think you'll find out from there only, like where is your annular pattern and where is your non-annular pattern. So eastern and western side that you're getting that contrast. So maybe I think you can explain better way, just instead of using just the index.
Okay,
so
sir.
that will be my suggestion.
Okay, sir. Thank you, sir.
You can unshare your screen.
Okay, sir. Thank you.
Thank you, Anthony, for your excellent presentation. And so now, actually, there was a scheduled tea break in the schedule, and because we lost some of the time at the beginning, so and it is almost the time to start the quick presentations. So which is scheduled at 11:45. So with the permission of chair, so we are now starting with the quick presentations and going to skip the tea break. So if that is okay, just for the confirmation, Dr. Sudhakar.
Yeah, actually, I have no problem. In fact, and all, unless somebody is really wants to have a cup of tea and all, they can go out and come back and all this thing. And we as a actually as a chairman and you two are co-chairs and all, we will remain in the to listen to this short presentations and complete it on time. This activity.
Okay.
Okay.
Okay. Thank you, sir. So we'll start with the quick presentations now, and as these are only 5-minute presentations, so we will not have any question answers at the end of any presentations. So we'll give give an intimation 1 minute before your 5 minutes, and you will be able to wind up. So we'll start with the first presenter, Shailesh Pednekar.
You can hear me?
Yes, and just share your slides and start. Yes, we can see it and start your presentation.
Respected session chairman, coordinator, and the audience, good morning to all. Today's my title of the talk is Signature of Seasonal Surface Warm Water Core along the west coast of Svalbard, Arctic. In the left-hand side, you can see the Arctic Circle. Arctic Circle is comparatively small part of the global surface, play a crucial role in determining the global climate change due to the complex coupling between cryosphere, atmosphere, ocean, and land. Presently, Arctic is undergoing significant environmental change and has been the focal point of the climate science society. Many physical systems must be responsible for the possible change. The overall change affects the expanse of glaciers, ice, and the surrounding regions. As you can see, the Arctic, there is a warm North Atlantic current going towards the north. This warm Antarctic one branch splits into the west Spitsbergen, warm Spitsbergen currents along the Svalbard. And due to the freshening and glacial melting, freshwater inputs because of this forms the strong thermohaline gradients along the west coast of Svalbard. General solar irradiation pattern, if we see, you can see the warming region, warming months around May, June, July, August, September. So this study examined changes of the surface warm core of sea surface temperature in respect to sea ice concentration in the vicinity of the Svalbard. This is my study area, and the data we have used is the SST from the around NOAA, and the data are the monthly averages made using 38 years of data set from 1982 to December 2019. This analysis product is obtained by mergings of satellite as well as in situ observations and having resolutions of 1 degree by 1 degree. As we know, the northern Arctic, the winter season is the longer as compared to the summer seasons. So these are the monthly maps of sea surface temperature. This blue color, you can see the sea surface temperature, and the bottom is the sea ice concentration. During the month of February, you can see the temperature is very much lower, cooling, is very much cold temperature is there. And sea ice concentration, if you see, the concentrations also varying from 0 to 10 to 20% sea ice concentration. And the winters.
You have 1 minute left. So please conclude.
One more, yeah. Okay.
And during the summer period, you can see the warm core of the sea surface temperature along the west coast of India starts from the June to July, August, September. In the month of August, it becomes the especially more than 8 degrees centigrade temperature. And if you look at the sea ice concentrations also reduces. So during the summer, the net heat flux, surface flux is around 100 watts per meter square, associated with the sea ice melt and ocean sensible heat gain, exceeds the atmospheric energy and transports transport convergence of 91 watts per meter square, according to the.
Shailesh, you have to come to the summary.
Yeah.
Yes,
Summary
conclude now. Yes.
SST has shown a warmer surface water core along the west coast of Svalbard during the August and coolest during the February. Warming and begins in the May and cooling begins in the December, intensifies in August, and for winter it intensifies during February and further diminishes in the November, and for winter it diminishes in April. Off the west coast of south of Svalbard reveals the higher temperature than surrounding and lower during the winter region. The studies have confirmed seasonal spatial variation in surrounding temperature during winter and SST magnitude in different ranges. Further studies will be continued with the atmospheric forcing parameters. Thank you.
Yes, unshare your presentation, and we have next presentation by Suraj Ravindran.
Okay, sir. Hello. Good morning.
Yes, we can see your slide. Start your presentation.
Okay. Good morning, one all. First of all, let me thank all the team behind Osicon, OSI, and NCPR for conducting this Osicon 2021, and the co-authors of my work which I am going to present today. That is Arctic sea ice variability using an Earth system model. So we have used one of the model participating in CMIP6 and one of the diagnostic project in the name SIMIP, that is sea ice model in the comparison project, and the name of the model is Community Earth System Model version 2, Whole Atmosphere Community Climate Model. We have considered 3 ensemble members, which is having both historical and future scenario SSP 585 simulation spanning from 1850 to 2100. We have considered 5 variables, that is sea ice concentration, sea ice heat content per unit area, sea ice thickness, sea surface salinity, and sea surface temperature. All the variables were regraded to 1:1 spatial resolution from the model's native grid. So here figure 1 corresponds to sea surface temperature, and figure 2 corresponds to sea ice concentration. Here I have considered both September and March. September corresponds to the minimum sea ice extent period, and March corresponds to the maximum sea ice extent. And I have averaged the 30 years of monthly data. For present, I have averaged 1991 to 2020. Past is the average of 1851 to 1880, and future is the 2071 to 2100. So the main interesting result which we can see is that even in the winter month, that is March, we can see the Greenland Sea Edge region and Barents Sea region is having a warming even in the present relative to the past. And when we see the future also, there is a entire Nordic Sea region and Barents Sea, entire Barents Sea is having a high warming, mind the magnitude in the scales also. Also in the sea ice concentration, it is evident that this present situation, it is on the edges of Greenland Sea and Barents Sea opening only. But in the future, when relative to our present, we can see the entire Greenland Sea and the Barents Sea is having a major sea ice decline. So moving on to the next, this is the linear regression plot of sea surface temperature and sea ice heat content. Entire Arctic domain is having a increasing trend, and the stipulations shows the significance, and the shaded region is the plus or minus standard deviation of the ensemble members spatial grids. So in the lower panel, sea ice heat content is concerned. Sea ice heat content is the enthalpy integrated over the depth, which if the sea ice heat content is high, the more easily the sea ice can melt. So we can see that average value of sea ice heat content is almost 0 by the 2050, which is of we are expecting maybe the first sea ice free summer in the September. So moving on to next, this is I have considered the regional scales: Greenland Sea, Barents Sea, Kara Sea, Laptev Sea, East Siberian Sea, Chukchi Sea, and Beaufort Sea. And we have applied a 120 months rolling mean on the monthly anomaly time series data. So here is the sea surface temperature. We can see that Chukchi Sea is having the highest anomaly, and the Laptev Sea is the least anomaly. And in the sea surface salinity is concerned, the Laptev Sea is the least or a high freshening observed in the as far as sea surface salinity is concerned. And this is the lower plot figure shows the sea ice heat content anomaly, and we can see that sea ice concentration, almost all the region is having the same agreement as the declining is concerned. So as a summary, so we have concerned these 5 variables in the CSM2 vacuum model for both the historical and future scenario period. And we found that Greenland Sea and Barents Sea region are depicting a significant decline of sea ice.
One more minute.
Okay, sir. An increase in sea surface temperature about 3 degrees Celsius in the winter months in the future related to the present. Also that the declining trend of sea ice heat content is, or the Arctic domain is significant in both summer and winter, but the spatial mean value attains 0 by 2050 in December. And also that the freshening of Laptev Sea is greater than 2.5 PSU by the end of 2100. And further analysis, including different simulations and more ensemble members, are the future scope of study to better understand the Arctic sea ice variability. Thank you all for listening. Thanks.
Yeah, thank you, Suraj. You can unshare your screen. Yeah, so now we have next presentation by Rais Ahmed. Are you here, Rais Ahmed? Are you present? I don't see his name in the list. So if Rais Ahmed is not present, then the next one is Syed Tausif Ahmed. Syed Tausif Ahmed. Yes, I think these two presenters are not present. So if they are absent, then we have the next one at 12:05. So should we take a quick break of 5 minutes? So so that we can start the presentation at its scheduled time, 12:05. Dr. Sudhakar, please. Yeah.
Yeah, I think it's fine. I think, you can give a short break, and 12:05 we will again assemble back under. And you inform next speaker is who is the next speaker in advance, so that he or she will be, ready with the presentation.
Yes, sir. Yes, sir. So next speaker who will be presenting at 12:05 is Juhi Yadav. So she is present here. She can confirm.
Yes, sir, I'm there.
Okay, okay. So we will have your presentation at 12:05.
Okay, sir.
Excellent. We have about 7 minutes. We will assemble around 12:04 and then start at 12:05. Thank you.
I request that everyone be here. Just keep muted and keep your video off, and we'll start session at 12:05. Yeah, welcome back. Hope everyone is here. So we can now start with the presentation of Juhi Yadav. Yes, so you can share your slides.
Very good afternoon to all present here. Myself, Juhi Yadav, working as SRF at NCPUR. I'm going to present the study carried out under the guidance of Dr. Avinash Kumar and Dr. Rahul Mohan. The study is aimed to understand the sea ice variability in the Weddell Sea sector of Antarctica with respect to the ocean atmospheric forcing. In Antarctic, sea ice cover, which has been stable and was increasing, has suddenly shrunk to a historic low in the past 4 years, which is largely attributed to the warming climate, and particularly in the year 2016, which is also the lowest record year till date. Coming to the to my study area, Weddell Sea sector, the region demarcated with the red line shows the Weddell Sea, and here I have shown the time series plot of the annual and seasonal sea ice extent anomaly. From this plot, we have identified during the summer, the sea ice extent trend shows the positive, whereas in winter and spring it was negative. That was quite surprising to know in that, but this happens in the Weddell Sea sector. And another important thing was the analysis revealed that the annual sea ice extent, which increased by 21% in the year 1999, this was the lowest recorded year, and 2015, which was having the maximum sea ice extent, has declined by 20% in just last 4 years. And to know more about the sea ice extent differences in the Weddell Sea, we have studied the decadal trend for the sea surface temperature, zonal wind, and wind speed. In the Weddell Sea sector, the patterns and the forcings are working entirely different, because here the latitudinal difference and the latitudinal differences create the thermal differences, and that leads in the weakening and strengthening of the Weddell gyre. As we can see that in the summer, there is significant rise in sea ice concentration in the Weddell Sea. However, in winter and spring, the sea ice is just found in the coastal region of the Weddell Sea region, and that is mostly due to the sea ice advection and the easterlies intensification. While in summer, if we see, there is intensification of westerly wind and formation of strong Weddell gyre, and the Weddell gyre is associated with the cooling in the center, whereas warming in the north, which can be identified in the autumn, like the winds are northerly, bringing warm air and resulting into the sea ice advection. Later we have the time series seasonal plot is showing the anomaly for the sea ice extent, ocean atmospheric parameters, and climate indices. Here we have tried to identify that how the sea surface temperature or air temperature works for the sea ice variation. And here we have seen that in the summer season and spring, there is summer and spring, sea surface temperature is mainly playing a bigger role, while in autumn and winter, net heat flux, that means both ocean and atmosphere are responsible for any variations in this region. And coming to the climatic indices, we have also found that SAM is largely influencing, that too positive SAM is influencing winter and summer sea ice patterns. In summer, it is leading to the more sea ice, while in winters, positive SAM is resulting into the lower sea ice.
You have one more minute.
Okay. And this composite analysis has been performed to identify which actually parameter, that is either ocean or atmospheric, which is more responsible for this seasonal variability in the sea ice. And here we have found out that during austral summer and spring, the oceanic heating is the primary force resulting into the variation, while the instability occurring in the autumn and winter is highly influenced by the ocean and atmospheric forcings. So, and this work has been published in the highly impact peer-reviewed journal, that is Environmental Research Letter. By this, I will conclude saying that Weddell Sea sector is susceptible to the ongoing climate change, and it is experiencing a reduction in the sea ice extent. And seasonal sea ice concentration in the Weddell Sea sector is largely associated with the wind patterns, which results in the weakening and strengthening of the Weddell Gyre. And the present study revealed a strong relationship between the sea ice variability and the ocean atmospheric forcing. But this relationship is not constant over time. So we need a constant monitoring for this particular variability. Thank you, sir.
Yes, thank you, Juhi. You can unshare your screen. Yes, thank you, and it was nice presentation. Now we go to the next speaker, Raina Roy.
Yes, sir. Can you hear me?
Yes, yes, we can hear you. You can share your screen.
Okay, sir. Can you see this screen, sir?
Yes, we start with the first slide and make it full screen. Yes.
Good afternoon, one and all. My name is Raina Roy. So I would be presenting today on the topic polar processing in chemical ozone loss in the exceptional Arctic winters of 2011 and 2020. I'm an MSc graduate, and this work was done as a part of my MSc project dissertation under the guidance of Dr. Jayanarayanan Kuttipuram at Coral, Indian Institute of Technology, IIT Kharagpur. So let me begin with my presentation. So first of all, why are these two winters called exceptional winters or extreme winters? These two winters are referred to as extreme winters because they experienced unusually low temperatures compared to any of the previous Arctic winters. So as a result of these unusually low temperatures, they experienced severe ozone loss, which is similar to that of the Antarctic sector. So the severe ozone loss was, the winters were conducive for severe ozone loss because of the factors such as a very stable and long-lasting polar vortex that lasted until the late spring, and then they had large polar stratospheric cloud areas and very high chlorine activation. All of these promoted severe ozone loss for these winters. Now, as we all know, ozone loss was a phenomenon that was discovered in the Antarctic sector, and it was discovered by Farman et al. However, years later, it was discovered in the Arctic, and in the Arctic, it was first observed in 1988 to 1989 winter. And since its discovery, it has been a concern for the mankind due to the UV radiation that are possible due to the ozone layer depletion. However, the ozone loss in the Arctic is not as severe as that in the Antarctic, principally due to the meteorology of the Arctic winters and due to the varying stability of the Arctic polar vortex. So the Arctic polar vortex has an unstable nature due to the increased variability associated with the tropospheric forcing from the lower latitudes. In addition to this, the strength of the Arctic polar vortex can also be ascertained by various climatic variability factors such as the El Nino Southern Oscillation, the quasi-biennial oscillation, etc. By Holton-Tanz relation, we can see that if the QBO is said to be in the westerly phase, the strength of the Arctic polar vortex is said to be more stable. So you can see that in these two particular years, in the 2011 winter and in the 2020 winter, the QBO was seen to be in the westerly phase and the polar vortex was rather very stable. In addition to this, there are factors such as the Arctic sea ice reduction in the Arctic sea ice concentration that can possibly affect the strength of the polar vortex. So you can see in the figure 1, which shows the meteorology of the winters in detail. So the meteorology of the winters showed that the minimum temperature conditions were ideal for the PSC cloud formation. That is, the PSC clouds form at a threshold temperature of 195 Kelvin. So the temperature conditions remained below this for almost 4 months, and hence the PSC area, you can see that the black line represents the climatology of the winters. So it was much higher than that of the climatology, and a PSC area of 10 million kilometers square was found for both the winters. In addition to this, the strength of the polar vortex was also high because the mean heat flux forcing during these 2 years was comparatively very limited and was lesser than 20 kilometers second, which is kilometer per second, which is the climatology value. Now, About the data and methods, the meteorology of the windows is assessed by the help of mirror-to data sets. And then we have also studied the chemistry of the windows using the data sets from microwave limb sounder. And the chemistry is studied by studying the temporal evolution of trace gases such as the N2O and the chlorine activation for the window. And the ozone loss is calculated by two different methods, that is the passive tracer method as well as the vortex descent method. Each method has its own advantage, and that is why we have used two methods here. And the passive tracer method is is run using the chemical transport model SlimeCat. So the ozone loss calculations is performed inside the vortex. Now coming to the results and discussion, as we analyze the meteorology of the windows, we find that the conditions were very suitable for.
You have one more minute. You have one more minute.
Were very severe for ozone loss. And then you can see that from the chemistry of the windows, the chlorine activation for these particular windows began earlier than any of the previous Arctic windows, and the denitrification as well was very severe. The ozone loss amount in 2020 window was about 2.5 ppmv, and then in 2011 window it was seen to be around 2.3 ppmv. Coming to the conclusion of my study, so from this we can analyze that the ozone loss during these two winters was very much severe compared to any of the previously observed Arctic winters, and and perhaps the possible causes for the same would be due to the SST anomalies. It was stated in the study that in 2011 the SST anomaly in the North Pacific Ocean, negative SST anomaly, helped in sustaining the strength of the polar vortex. Similarly, the response of the Arctic sea ice loss as well. So the detailed analysis of these windows from our study would help in modeling ozone loss chemistry for future, and also in predicting the future ozone layer recovery. So I would like to thank Osicon coordinators and my dear guide for giving me this opportunity. Thank you so much.
Okay, thank you, Reina, for your nice presentation. You can unshare your screen.
Yes, sir.
And we have next presentation by Chitiza S.
Yes, sir.
Yes.
Yes, sir.
Share your presentation.
Yes, yes. Okay.
So you can see a green share screen
Yeah,
button.
yeah, yeah. Yes, yes. I have already. Is it visible, sir?
Yes, make it full screen.
Just. Can I
Yes.
start now?
Yes, start. Yeah.
So good afternoon to all. I'm Kshitija, MOES Research Fellow, joined to desk IIT now working at NCPR Goa under the guidance of Dr. Babla Jana. The topic of my presentation today is an updated trends of global sea ice condition. Today, global sea ice condition is a concern for every one of us across the world. The continuous warming and increase in CO2, as shown in the top left figure, over the years has resulted in anomalous rise in the temperature by 1.2 degrees Celsius since 1970. The variability of the sea ice at poles acts as a key indicator to climate change. It modulates albedo, reduces ocean atmospheric gas exchange, and has a major role in ocean atmospheric circulation, where ice sheet loss and decreasing ice extent defines the sea ice variability. To understand the sea ice variability, we have analyzed the sea ice data for 42 years. Figure on right side represents the sea ice extent from 1979 to 2020 for global, Antarctic, and Arctic region. The global warming has experienced a tremendous sea ice decline in Arctic, while Antarctic has observed an increasing trend. The large impact of global warming on sea ice is due to the geographical characteristics and the higher positive Arctic oscillation that diverges the sea ice away from the center. In southern hemisphere, the depletion of ozone due to global warming caused the cooling of stratosphere during 1979 to 2015. This weather system, along with increased meridional temperature gradient, strengthened the polar vortex, reinforcing the jet stream around the Antarctic. This intensified westerlies associated with positive SAM due to ozone hole in Antarctic shields the Antarctic to prevent the intrusion of warm air, thereby enhanced ice growth. But recently, the sea ice in Antarctic has declined 4 times, that is 0.44% per decade, as compared to the trend from 1979 to 2015 that globally influence the rate of decline to double from minus 1.22% per decade to minus 2.15% per decade. The detailed analysis of the sea ice variability is discussed further. The figure in left is the monthly ice extent, monthly sea ice deviation, and the yearly ice extent for Southern Ocean, and right figure is the seasonal variability of ice extent. The yearly trend of sea ice that dropped from 23.5 to 5.26 into 10 to the power 3 kilometers square per year has marked the highest ice extent in 2014 to 13.18 million square kilometer, and the lowest in 11.12 square kilometer. The monthly deviation in green line plot clearly shows the sudden downfall after 2015 to the highest in Jan 2015 and the lowest in December 2016. On the right side is the seasonal variability of the sea ice extent that declined more prominently in summer and autumn season. The figure represents the regional variability of the sea ice extent. The sea ice deviates largely in Weddell Sea, Ross Sea, and Indian Ocean sector, of the Southern Ocean to mark the tremendous decline during 2016 to 20, while Bell Emerson and Western Pacific observed the negligible change compared to other regions. The overall sea ice changes in recent years has occurred due to the meandering nature of intensified atmospheric zonal wave 3. So zonal wave 3 is an asymmetric component of circulation. It is marked by three alternating troughs and crest patterns of the atmospheric pressure centers located in Indian Pacific and Atlantic sectors. As an example, here is a normalized anomaly of the geopotential height at 500 HP in winter season that indicates the spatial intensification of zonal wave 3, where black dot represents the GH anomaly greater than 2 standard deviations away from mean, and plus mark indicates the anomaly that is 4 standard deviations away from mean. The strength of this large-scale atmospheric circulation is represented by zonal wave 3 index. It is the normalized deviation. It is the normalized deviation of the pressure field at each of the 3 ridges that defines ZW3 from its climatological mean at those locations. The ridge locations are as shown in the slide, that is 79.5 degree east, 32.25 degree west, and
you have 1 minute.
You have 1 minute, Kshitija.
Yes. And at 45 degrees south latitude. The ZW3 index shows the dominant positive phase in the overall time period from 2016 to 2020. The positive phase of ZW3 index denotes the meridional flow and negative phase denotes the zonal flow. Of all, 2017 observed the unprecedented sea ice decline. The decline in summer 2017 is attributed to amplification of ZW3 and negative SAM index that deviated ice extent to the lowest in March. The amplitude of ZW3 is an indication of large temperature gradient. Steeper temperature gradient influenced poleward transport of cyclones during winter 2017 that led to atmospheric warming, creating the extensive ice-free region and more sea ice decline in the ice concentration. So this in 2020, the ZW3 weakening during winters corresponds to the much little recovery of the sea ice. Anomalous atmospheric condition average during winters is discussed further. The polar transport of warm air during the formation of the frequent and the strong cyclones during winters is mainly attributed to the presence of deeper troughs and higher ridges in ZW3. Along with the increased temperature gradient associated with positive SAM. The impact of warming is seen in Western Ross, Bell Emerson, and Indian Ocean regions.
You may conclude, please.
So finally concluding, the sea ice in Southern Ocean has underwent a drastic change, that is about with a trend dropping from 23.26 to 5.26 into 10 to the power 3 kilometers square per year during 1979 to 2020, marking the anomalous decline. Amplification of the ZW3 observed a number of effects on sea ice conditions in Southern Ocean, such as frequent cyclones, increased ozone concentration over Antarctic, asymmetric distribution of sea ice, affecting advancing as well as the retreating time of sea ice. The warm air advection due to the poleward movement of these cyclones, increased water vapor content in the atmosphere, significantly increased air temperature and surface temperature of the oceans. These recent changes in Antarctic sea ice, if this is a part of natural variability or the effect of global warming, is difficult to conclude with these short time observations. Or is this the start of the tremendous decline in Antarctic like we observed in Arctic, or will it recover to normal as before? That is still a question. So with more number of observation, we'll be able to address this in future. Thank you.
Thank you, Kshitija. You can unshare your screen now.
Yes, sir.
So with this, we have completed all the presentations in this session. So now I invite Dr. M. Sudhakar, chairman of the session, to give his remarks.
Good afternoon. It's indeed a great pleasure to hear, so many presentations as well as excellent conduct of this session by my, two of my, senior colleagues. One is Dr. Vimlesh Pant from IIT Delhi, and Dr. Babulal Jana, from NCPOR Goa. And we have been on time. Actually, we had, although I think initially Dr. Vimlesh Pant has told that we will skip the break and all, still he has given a break also for a tea break. I'm sure that some of you have refreshed yourself and come back to this session. I think interestingly is that we had actually a number of scientific, papers of, 15 minutes duration. And I must thank all the actually authors who have given a, detailed, presentation fire session. It was, really interesting and all. In fact, it was dominated by actually girl students and research fellows and all. They have done an excellent job. In fact, of course, as far as the students and research fellows are concerned, I strongly feel is that it is an opportunity for them, as well as it's also a training ground for them and all, to ensure that they will understand actually how such seminars are conducted, how the presentations have to be done on time, strictly following the timelines, as well as to salient things to be brought out in your presentation. It's not that everything that is in the graph has to be explained, and everybody has done a good justice for their time slots, as well as the scientific content of their I think their individual presentations are concerned. Now, coming back to, we have started the day with Dr. Anil Kumar, who gave an overall, about the decade of achievements of Southern Ocean, and then the future plans, and followed by, we had a mix of modeling studies as well as mooring studies, and then also covering the both Arctic and Antarctic part and all that. I'm sure that all those who have attended this session have actually have understood a lot, and they have learned a lot, and they must have been actually really brainstormed about it and all, and to see that how the future studies of this country in Southern Ocean as well as Arctic Ocean. That is Arctic Ocean, of course, we are just confined to a small area of Svalbard around and all that. But I think we have to come up with a bigger plans and how we will also have a larger observation strategy as far as Arctic is concerned. It could be done by international collaborations, and before that, we should also have an ideas have to flow. I think with this, since we have been on time, and then I've taken 2 minutes extra beyond 12:25. I will thank my two of my senior colleagues, as well as all those who are in the background, who have ensured that the smooth conduct of this session happens and all, in terms of what is called as a virtual session is concerned. The only thing I didn't like it much is that I wanted to see the authors, the lead authors who were presenting and all this, in their photograph or the individual could have been brought on the frame and then removed, and then we could have gone for a presentation. So some of the authors, I know them, of course, and some I don't know them. It could be an excellent introduction to all others also as well. And however, I think next time I'm sure that there will not be virtual conference like this, and all, because it is, once in 100 years we will get this kind of opportunity, and it has come in our lifetime, unfortunately. Therefore, even now, if Dr. Vimlesh Pant thinks and all, if all are there around, all the authors and all, we would like to see them, and then I think it would be an encouragement to each and everyone. I take this opportunity to thank OSI, Governing Council, Director NCPOR, and Organizing Committee, Chairman, Dr. Anil Kumar, Dr. Avinash, and Babulal Jana, and all other colleagues and all who are close to my heart and all. I'm sure that they have done an excellent job and all. And we are almost coming to a conclusion and all that. And I'm actually delighted to be the chair of this session. And I have learned a lot and all, to hear about polar and cryospheric studies in this country. Thank you very much.
Thank you very much, sir, for your kind words and summarizing the proceedings of this session. As you suggested, so I request all the student participants and speakers, all the speakers, to please switch on your video for a few seconds. Yes, so everyone can switch on their videos. Yeah, before we formally conclude it. Okay, thank you. And now it's my time, my duty to give a vote of thanks. So thank you to the chairman for conducting the session smoothly, and to the coordinator, my fellow coordinator. And we had very good and informative presentations by all the speakers in this session. We thank the invited speaker, Dr. Anil Kumar, for his comprehensive talk on decadal Indian observational campaigns in the Southern Ocean and the future perspectives. We thank all the speakers of oral and quick presentations, and all the delegates and attendees to this technical session 13. We also thank Ocean Society of India and the organizing team of Osicon 21, a technical team who is working from the behind to make it possible on this online platform, for giving us this opportunity to conduct this technical session. Thank you all once again. Thank you.
Dr. Vimlesh, let me please thanks to Sudhakar sir and the coordinator Vimlesh, and the presenters and all participants for this smoothly conducting this session. Yeah, please. Yeah,
thank you all. So we can now end this session.
Yeah.
Mahesh, we'll continue now, or will there be a different link or session?
No, we can continue. Pick up from what they have concluded, so we can carry on from now.
Okay.
So before that, sir, I request all the previous attendees of previous session to please log out from Zoom, and we can attend from outside Zoom. So from a regular regular conference link. Thank you, and then you can proceed with your session.
Thank you.
Thank you.
Yes, Raja, I think we have to wait because others have to log in. We hardly have any members online right now. We'll wait for some time.
I believe they were supposed to log in by 12:30.
Yes.
I hope those who want to attend the session are around.
Yeah, I hope so.
Hi, Sudhakar. Hi, Mahesh.
Yeah.
Hello.
Good afternoon, sir. Good afternoon.
Rajiv.
Good afternoon. Good afternoon, sir.
Good afternoon. So, shall we start? We'll wait till, I think our invited speaker is.
Yes, he's very much here.
Good afternoon, sir.
Okay.
Good afternoon,
Dr. Sudhakar.
Good afternoon, Dr. Raju. Rajiv.
Good afternoon. Good afternoon. Good afternoon. And Dr. Jayasuri also is there, Jyoti.
Yeah, yes.
I think, since it's a small group and all, why not we switch on our video and show each other how we look.
Now I think we can see you.
Actually,
we can see you.
Girls
Good
have gone.
afternoon.
Girls have gone.
Rajiv,
Yep.
Regular presentations will start at 1:45, that is 13:45. I
Yes.
think we'll wait for a couple of minutes and we can start with the invited talk. So anyway, the others can access in through Zoom and through YouTube also.
Yes. Yeah. I mean,
Actually, when I looked at it, can you hear me?
Yes,
yeah.
Yes.
Yeah, the program is such that after the talk there is lunch. So maybe people may not join. So I'll be, I don't know.
No, but there are 16 people who are logged in YouTube, and then we also have people who are here.
So you can see it, is it?
Yes.
Yes.
YouTube, we can see there are people who are logged in.
YouTube, we can see.
Yes, yeah, we can. We can see on a separate link. YouTube also that there are people who are logged in there.
Okay. We are supposed to start at 12:30.
Yeah, now I believe it's already 12:35.
It's 12:35. Shall we make it 12:40? But we have to complete. On both sides, we are sandwiched because the valedictory function is there other side.
Yes.
This side is lunch break is there.
I'll finish on time. Don't worry.
we know you. We know you very
We
well.
we can eat into the lunch time, no problem. But they want to start the after lunch around 15 minutes earlier.
Yes.
Mahesh?
Yes, sir.
1:45.
1:45 will start.
Okay.
So I think, Rajiv, you can begin, then we'll continue with the presentation.
Okay. Yeah. Oh,
There are already members who are watching on YouTube.
sorry.
There are members who are watching on YouTube already.
Yes, yeah. That's what I saw that there are already 16 people who are there on YouTube as well. So I think we can start over here. Chairman, is that fine? We start now?
Yeah, I think we'll start because otherwise we'll not have time.
Okay. Thank you. So,
And
very good afternoon.
Sorry,
Yes.
how do they ask questions then? If they're not here, is it okay? I mean, there
They
is
have
no question answer. Huh?
They have both the options. They can type in their questions in the chat here, like 9 people who are around, they can type in here. And also they can type in the YouTube also, that I will keep on checking.
Oh, okay.
In case anybody is asking a question in YouTube, I'll refer that to you.
All right.
Okay, so good afternoon. We are in the session 16 on marine geology and geophysics of the Osicon 2021, which was supposed to be in 2020, now dragged on to 2021. And we have with us the session for this chairman is Dr. K. Kamesh Raju, our veteran scientist from National Institute of Oceanography and now associated with the National Center for Polar and Ocean Research. I'll just share his biodata. Dr. Kamesh Raju did MSc from Andhra University and PhD in Marine Science from Goa University. He has an extensive experience of 37 years in marine geology with focus on tectonics and geodynamics. He is associated with the RIDGE program and contributed to the understanding of the ocean floor tectonics at the dynamic plate boundaries. He led the team that located the first hydrothermal vent field over the Carlsberg Ridge, North Indian Ocean. He conducted the first 6,000-meter radius UV investigations over the Central Indian Ridge. He has served as the Inter-Ridge Steering Committee member representing Indian Ridge Group. His work in the Andaman Baika Basin has defined the configuration of the Baika spreading center in the Andaman Sea. He has conducted the first ocean bottom seismometer experiment in the Andaman Sea. He also led several research cruises as the chief scientist of the expeditions on board our research vessels, Sagar Kanya and Sindhu Sadhana. He has published more than 60 papers in very high impact national and international journals. And in recognition of his extensive work on ridge and geophysics, he has been awarded several prestigious awards, including the National Mineral Award in the year 2007 for excellence in applied geophysics. He was a NORAD fellow and also an INSA JSPS fellow, wherein he collaborated with Ocean Research Institute, Tokyo, Japan. He was invited as in visiting scientist by the Lamont Doherty Institute in USA and IPGP in Paris, France. He is a fellow of Indian Geophysical Union and member of AGU, OSI, AEG, GSI, etc. And he is currently working as visiting scientist at NCPOR Goa. A very cool and calm person. That's how I remember Dr. Kamesh Raju, always smiling and never getting irritated, agitated. In fact, he is the only person whom I never saw getting angry on anybody under any situation. I don't know how does he maintain a calm and cool posture. So over to you, Chairman, sir. Let us start this session. Thank you.
Thank you, Rajiv, for that excellent introduction. Actually, I'm thankful for your great introduction. Also, I'm thankful to the OSI President Dr. Ravichandran and Convener Anil Kumar and the organizing committee for giving me this opportunity to chair this session. It gives me an immense pleasure to again see you actually as and our colleagues again back in action here. So coming to today's session, this is a marine geology geophysics session. We have some interesting talks lined up. Most of all, we have with us an eminent geologist, well-decorated geologist, Professor Jyotiranjan Ray. Mahesh, would you like to put it on the screen? Put the slide? Or shall I continue?
Raju, will you be able to?
Yeah, I can share. I'll just share it.
Can you? Yeah, that would be better because that will give a better perspective. Yeah, Professor Jyotiranjan Ray did his MTech in applied geology from IIT Roorkee, and he received his PhD from PRL Ahmedabad for his work on carbonate alkaline magmatism in India. After carrying out postdoctoral research at PRL and the University of Ottawa in Canada and also in University of Hawaii, USA, he joined PRL as a reader in 2003, and now he is a senior professor at PRL and currently on deputation to National Center for Earth Science Studies, Census of MOES as its director. Professor Ray has a vast experience in research and teaching experience in the fields of geochemistry, radiogenic isotope geology, and igneous spectrology. He touched upon many fields, starting from the geochemical evolution of the Earth's mantle and studies on ancient sedimentary basins, subduction zone process, and also the landforms evolution and geoarchaeology. They also touched upon the submarine water, groundwater discharge into the coastal zones, which is actually of a great importance for the coastal zone people. He's made fundamental contributions in all these fields and published about 60 peer-reviewed papers in the reputed international and national journals. He has been awarded with several awards. I list few of them here. He was awarded with, he was recipient of Krishnan Gold Medal from IGU and the National Geoscience Award from Ministry of Mines, and also he is awarded with the prestigious Shanti Swarup Bhatnagar Award from CSIR. It gives me immense pleasure to invite Professor Ray to deliver his on the outstanding problems of the Indian Ocean tectonics. Professor Ray, we are very happy that you agreed to deliver your talk here, and we look forward to listening from you. Professor Ray.
Thank you.
Professor Jethranjan, we request you to.
Yeah, thank you very much. Is it visible?
Yeah, just please go to slideshow mode. We can see the slide.
Yeah, we are visible. You are visible and audible.
Is it full screen?
Yes.
Okay.
Please go ahead.
Thank you, Dr. Kamesh Raju, for your kind words, and thank you, Rajiv, for nicely organizing this. And I must at the outset thank Dr. Ravi Chandran, President OSI, for inviting me, and also all the organizers for doing this tremendous job of arranging this conference virtually. So let me see if I can do justice to the topic which I have chosen. All right. You must be wondering, I'm a geochemist, what I'm doing with tectonics. So I will justify that, and I'll take you through my experience, because in this country nowadays, very few people are any longer interested in going to the ocean bottom and doing research and trying to understand the very base on which everything else is actually built up. So from my experience, or what I'm learning now actually, so I'd like to share, and hopefully that will encourage some people to take up this challenging work which Dr. Kamesh Raju has already done, and his students are still doing it. So yes, so I'll start like this. So this is a picture from Google Earth. You can see of the Indian Ocean. It is unlike any other ocean, even though it is the third largest ocean in the world, but it is more complex than any other ocean basins. And there is a lot of information to be unraveled and still needs attention of researchers. Okay, just I'll take you through a little bit of how a geochemist should view tectonics and what we can learn from it. So as you all know about the Earth's interior, of course, geophysics tells us about the structure of the Earth. And so we have a thin crust and then a mantle, solid plastic mantle, and a liquid outer core and a solid inner core. So most of the things that we know about the interior actually is primarily through geophysical methods. Geophysics has told us how things look like inside. So it is mostly the physical properties that we know. What about chemical properties? So for that, we have to rely primarily on the volcanoes because they carry material from deep inside. So volcanoes basically serve as windows to Earth's mantle. So if you can study these volcanoes or volcanic material through time, you can understand how the interior has, particularly the solid plastic silicate mantle, has evolved through time. So that has been my focus of my work for a long time. And how that is linked to tectonics is what I want to show you. So over the years, for last 40 years, people have been studying all volcanic materials, particularly in ocean basins. You study the mid-oceanic basalts, and you study ocean island basalts because they tap the mantle and the oceanic crust is very thin. So therefore, very little modification undergoes geochemically per se. So therefore, if you study these rocks, you would have a fair good idea about the source rocks. And therefore, studying these source chemistry with time, one may be able to understand the evolution or chemical evolution of Earth's mantle right from its birth. So over the years, people have used many different techniques. The most powerful ones are the radiogenic isotope techniques, where radiogenic isotope ratios like strontium 87 to 86 or lead isotope ratios or neodymium isotope ratios of these rocks can tell you a lot about the source as well as the processes that undergoes during the melting as well as its passes to the crust. So if you see this tetrahedron, what you see, actually people have found out that Earth's mantle is not homogeneous. Let us put it that way. Whether it is geophysically, if you look at it, whether it is upper mantle or lower mantle or asthenospheric mantle or even much deeper mantle, they are chemically heterogeneous. So if you study the MURBs, let me yeah. So if you study the MARB, so you'll see that MARB or mid-oceanic ridge basalts, which are actually, they represent most of the ocean crust. So they represent a type of mantle which are highly depleted in large iron lithophile elements. This is what we know. If in the periodic table, if you look at the first group, second group elements, these are the elements plus certain rare earths. They fall into this. So whenever melting takes place in the part of the mantle, these elements, because of their large size and higher charge, they get removed into the melt. So this part of the mantle in last 4 billion years or so has become depleted in all these elements. So isotopically, because of this depletion that the parents are gone, so the ratios are quite low of strontium, quite high for neodymium and like that. Whereas ocean island basalts, which supposed to be tapping the deeper mantle, they give a very different scenario or story. They tell a very different story because their isotopic compositions are very diverse. If you look at this, there are composition, these are basically hotspots or the hotspots which are believed to be tapping the lower part of the mantle per se, let's say. So Hawaii, Azores, Cameroon, etc. All these have very different kind of isotopic compositions than the so-called MARB mantle. And why they are so different? Because all these years it is believed that because of the tectonics, or let's say plate tectonics, a lot of crustal stuff has gone in, and therefore it has contaminated that part of the mantle. And so therefore all these have gone into different directions, moving higher or lower in certain isotopic ratio, depending on what material they are recycling. So however, it is quite one people when tried to see what should have been the uniform composition when the mantle started from a magma ocean, they figured out probably there would have been a composition like FOJO. We call it focus zone. Some people call it C or common mantle. Some people call it prevalent mantle, like geophysicists call it crema. So that means there was a probably, this is a hypothesis of course, a composition which was very uniform, and then slowly, because of various geochemical processes led by tectonics, these things have moved away from this focus zone. So in a way, we can say the present day mantle is chemically heterogeneous. So why it is so and how it is so? The modern picture of mantle is very dynamic because we know there are convection currents inside it. And of course, we know subduction takes back a lot of crustal material back into the mantle, which is very chemically different from the mantle. So the heterogeneity that we see in these mantle-derived rocks are actually introduced from the top as well as from the bottom. How? For a long period of time, this subducted material is believed to be residing or stay along core mantle boundary. Some people earlier used to call it D prime. Now it has a different name. I'll tell you what. So they also introduce heterogeneity into the mantle. So mantle is basically is a churning pot where you get material from all kinds of places, right from the top to the bottom. and it is usually or most of the time it is driven by tectonics. So I call it tectonics controls mental chemistry. Right from the birth of the planet, because of this process in whatever way, whether there was plate tectonics or whether there was any other tectonics, because of the recycling, because of the material from inside comes up, it undergoes a lot of changes because of superficial processes. And then the changed material is put back into the mantle, and therefore the chemistry changes. So whatever element you take, its chemistry is changed in the mantle over a period of time or over the evolution of the earth. So if you want to study this in the past, we have to rely on the chemistry of the lavas or the magmas or these rocks, igneous rocks, which are derived at various tectonic centers. Let it be mid-oceanic ridges or subduction zones or even the shield hotspots volcanoes. So they tap different parts of the mantle. They tell us about different processes, and most of these are actually driven by tectonics. So that is the point. So if we study these rocks, a geochemist can also talk about tectonics. That is the point. So geophysicists will directly employ their methods and try to understand the interior through various geophysical techniques, whereas chemistry, which also involves geochronology, because it is also part of geochemistry, because of the elements that undergo decay and all that. So they can tell us about the processes or the tectonic processes of the past. So we can use chemistry, geochemistry, and geochronology and try to understand the tectonics. Now, I'll give you a couple of examples how I have done this in the past. In a very modest way, I have done this because I was never directly working in ocean basins. So in 2012, when I was a postdoc in Hawaii, I got an opportunity to work on the Nazca Ridge and Easter Sea Mountain chain, which was believed to be a hotspot track, but it was not proven then in the South Pacific. So there are chain of these volcanoes or sea mounts which were there, and we trace all these and try to establish whether they were produced by either Easter Island or we call it Salas y Gomez hotspot. So when the plate moves over a hotspot, which is tapping the lower mantle or deeper part of the mantle, so you get all these volcanoes which produce a track. So that is the old theory, and whether it really worked or not, so we did that. So all these samples were traced over a period of 50 days. So I participated in the cruise, and we got the samples and dated them by argon. So as you can, so we tried to establish whether this part of northern part of the ridge or the chain called Nazca Ridge, and this one is called Easter Sea Mountain chain, whether they are actually related or not. And if that is related, so it will tell us about the plate movement as well and the rate of movement. So that we found out through age and distance from the source, let's say the Easter Islands. So this is an example how you can use geochronologies to establish spreading rate or half spreading rate for that matter. So 11 centimeter per year or 18. So here the speed was higher than this one. So all these things we could establish. Not only that, using isotope techniques or isotope tracers, we established that indeed the source of all these volcanoes was on one island. So that means it was truly a hotspot track. And there are a lot of other information that it gave us, but I am not going to discuss that. So all I'm trying to say, geochemistry, geochronology, of course, will tell you about the tectonics. Then another example where a long time back, I, along with Dr. Kanchan Pandey, who is now in IIT Bombay, we worked on sillet traps. So sillet traps were traps like Deccan traps, but much smaller in scale. And it was not dated. We didn't know. People believed that it is probably part of Rajmahal traps. And whether it is linked to so-called hotspot of Kerguelen, that means Kerguelen hotspot in the southern Indian Ocean when it was active and the plate was moving on it. So it produced probably the 90th ridge. And in the beginning, it generated these flood basalts on the continent, which we call it Rajmahal, Sylhet, and Bengal traps, because there are a lot of traps which are now in the West Bengal, in the Bangladesh, buried below the alluvium. So anyway, so we dated this, and not only that, there are many other volcanic activities, or let's say magmatic activities associated with it, alkaline rocks, carbonated, etc. So a lot of dating we did, and we figured out that the emplacement of these things actually are co-eval with Rajmal as Bengal traps, and it happened between 116 and 107 million years ago. So, of course, we established geochemically that it is related to Rajmal traps. Not only that, it is related to the Kerguelen plume, if there was a plume. So, hotspot lavas of Kerguelen match with this chemistry of these basalts, pristine chemistry of these basalts. Not only that, we also found that this part of the mantle actually contains some recycled carbon in the plume head or in the plume. So this is interesting. I'll come back to this. In Indian Ocean, all whether it is mid-oceanic basalts or whether it is ocean island basalts, they're very unique in the sense that they contain some kind of recycled material, which is derived probably from some ancient subduction which happened, and it could have happened much before the Gondwana land breakup. So that is a hypothesis. Anyway, I'll discuss that. So here is another example where you can use geochronology, geochemistry, and try to understand the past tectonics. So recently, last 10, 12 years, we have been working on Andaman Islands, mainly trying to understand the evolution of this arc, particularly the Barren Island and Narcondam, and also trying to understand subduction zone processes. Dr. Raju has done a lot of work, and a lot of people from NIO have done this, but unfortunately, this work is not continuing. That is what worries me. There are a lot of information to be found out, and a lot of research is required. A lot of concerted effort is required, but unfortunately, it's not happening. Anyway, so some small effort we tried. So we did some work. So we tried to understand the chemistry of these volcanoes, their evolution, etc. So what we figured out, I have listed all of them here. But what is unique about these arc volcanoes are that the Barren Island, which is currently active, it has a very pristine isotopic composition. That means it is tapping a mantle in a subduction zone. You expect that the mantle weights, which is the source of these volcanoes, should be heavily contaminated with the fluids that is derived from the subducting slab. However, it so happens, yes, it is coming from that. However, it has compositions, isotopic composition, very similar to what you would expect in a mid-oceanic ridge. For example, the Southeast Indian Marb, it is very close to that. Whereas Narcondam, the northern counterpart of this arc volcano, so it is to the north, it is a much evolved volcano. Not only that, it has a lot of crustal contribution. That means the subducting slab really heavily contaminated the source of these volcanoes, this volcano, Narcondam particularly. This could be one meaning. There could be another meaning that maybe because the crustal structure here is not very well known, as the physicists pointed out. In the southern part, close to Indonesia, we know that there is a continental crust beneath this arc. There are magmatic arc actually. In the north, extreme north, we don't know. At Barren Island, we kind of established that it is probably an oceanic crust, which is in which the Barren Island is sitting. But Narcondam, I'm still not sure. Either this evolved nature of lava could mean that there may be some little bit of continental crust there, or it could mean also that we have a significant amount of crustal contamination because of the subduction. Nonetheless, this work is still ongoing. We are still trying to figure out how to model this. And then there are certain things which I have written, and there is some interesting aspects like there are some dacite tephra we get on the Andaman Islands. We've dated them to be 0.7 million years. Unfortunately, there is no volcano here where you can relate it. We somehow related it to some volcano in Indonesia, but I don't think it could have come from there, considering the volume of tephra it is found on Andamans. So it appears maybe it has come from some evolved volcano, which is no longer on subaerial. So it is somewhere in the ocean basin in the Andaman Sea, which we have not discovered yet. That is my suspicion. So we have to find out if that is true. Then we are looking at another volcano or another arc, which could be a different arc than what we are seeing today. So there are many such interesting aspects one can understand through chemistry of lavas that are erupted on the surface. And a small work with, I don't know, the title is visible. Can you see the title?
Can see the
Yeah, we
title.
can.
Yeah. So because I see all kinds of things. All right. So a nice, a small, interesting work we did. So you might have known about mud volcanoes. So they are basically mud diapirs which come and carry a lot of argillaceous matter like quartz and clays mostly, and they carry a lot of gases, particularly methane, and a lot of water. So on Andaman Islands, the Andaman Islands are made up of very old rocks. They are either Cretaceous ophiolites or Eocene age or slightly younger groups of sedimentary rocks, which are mainly turbidites. Now these are old rocks. So where from this marine organic matter bearing, thermogenic gas bearing, and ocean water bearing material is coming from? So we did a lot of work, including, so we did studied the chemistry of the gases, we studied the chemistry of the water, and we are trying to publish the chemistry of the mud itself. So we figured it out that this mud is actually deriving from the slab itself. So you can imagine if this is the slab which is subducting, the mud actually, or the solid mud is deriving from the slab. But it is not directly coming. Instead, it is forming some kind of melange, which is usually seen in accretionary subduction zones. So where you can have accumulation because of, particularly in Andaman, because of the oblique nature of subduction. So there is a lot of accumulation of these subduct sediments, which are underplating below the accretionary prism, and they are the ones which are, because of this lot of structure or faults which are there, or fractures through which they are actually coming out as mud volcanoes. So therefore, they are carrying organic matter which from a deeper level and which have been thermogenically converted to methane. So this is one interest. So the main conclusions that we kind of figured out through this work, that there is actually a tectonic melange at the base of Andaman accretionary prism, and mud volcanoes originate from the decolumn uh, quite deep. And not only that, there is one interesting aspect that we kind of figured out, or we are trying to propose this, that very little recycling is taking place at the subduction and recycling of sediments, which means if you don't push a lot of sediments, the arc volcanoes which are deriving from the mantle waves may not carry much of signature, which could be true why Barren Island is still a little bit primitive. All right, so this is what I had done earlier. So I'll come back to the Indian Ocean basin. So now Indian Ocean, right from the continental margins all the way to Antarctica, or maybe Kerguelen Island. So there are a lot of things which we know already because of contribution from geophysicists and some geochemists also. So roughly we know that, so this is a picture taken through GMT work, which is done by some Lemonkova. So here it basically shows the ages of a lithosphere. So you can see the youngest are at the mid-oceanic ridges, the oldest are close to the continental margin. So this ocean basin basically opened after the demise of Tethys. That's what people say. So it opened during the separation of a breakup of Pangaea, or we call it Gondwana land on the southern hemisphere, and opened around 160 million years. And this particular part in the southern east ridge would have opened during separation of Antarctica and Australia, around 135 to 125 million years. And the western part would have opened late in Cretaceous. And the present configuration, it is believed, would have been attained around 36 million years ago. And there is a lot of asymmetry in the accretionary process of the crust. The new crust that forms our mid-oceanic ridge, Indian Ocean ridge, is not symmetrical like Atlantic or Pacific. So that means if you want to try to find, and it's also very slow spreading ridge, so it is always difficult to actually estimate the spreading rate because of the asymmetry involved. All right, so this is a little bit we know already. Did I miss something? Sorry. This picture I forgot to show. This is actually a picture where all tectonic features of the Indian Ocean is shown. You have this mid-oceanic ridge, And plus, you see there are a lot of tectonic, a lot of marginal plateau, and we call it oceanic plateaus, you can say, and a lot of seismic uplifts are there. That means there is no seismicity, but those features are there. It's full of, Indian Ocean is full of such features. So most of these features are actually not understood yet, particularly those close to the Indian continental margin. It is not understood. So some good work has been done by NIO people, particularly Yatish. He has been trying to figure out what are the interesting aspects one can work on. So that would be geophysically done. And also there are more interesting works. I'll tell you what one can take up. So this is what it looks like, geological and tectonic features of the ocean island, Indian Ocean. So it has a complex topography. There are no deep trenches like Pacific or Atlantic. And of course, we have a lot of these features which are seismic in nature. All right. So Yatish is an IO person who is still working on these aspects, and particularly geophysics. So he produced a beautiful review. I happened to read it. So in 2020, last year. So what he says, these are the outstanding issues he has listed it. So there are many regions, if you see, close to the continent, western margin of India, there are many regions whose origin is not properly understood. For example, there is this Pratap Kuri Comorin Ridge and the Lakshmi Basin, and there is a Gop Basin close to, what you say, in the Kuri Creek. So all these things, there are very interesting features. And more interesting is that ONGC has been drilling these regions and they are finding basalts. And so, which means we are not sure where is actually the continent is ending and the ocean basin is starting. Or these are some lavas which were erupted like Deccan on the continents. So there are a lot of interesting stuff. So origin of these regions are still not understood properly. And so he leads that location of continent ocean boundary needs to be understood. Yes, because where the continental crust is ending, where the oceanic crust is beginning, that is will be of utmost importance, considering that India has moved a long distance from southern hemisphere. Similarly, a lot of dating is required. Timing and formation of all these basins are not known. For example, this separation of India and Sri Lanka because of there was probably a oceanic ridge or something in the Mannar Basin. So that is still not really understood. So I don't know who will do that unless we do it. And so there are many other things he lists. So I would advise you people to read that. It's a beautifully written article. So if you look at the chemistry, so now I come to what I can contribute or we can contribute. I'll get you through what we already know. So people have been studying all ocean basalts, whether it is mid-oceanic ridge basalts or ocean island basalts of Indian Ocean. What do you find here that when you study this Indian Ocean MURB, which is mid-oceanic ridge basalt, which are basically tapping the upper part of the mantle or asthenospheric mantle, they have similar isotopic composition than like that of Atlantic, MURB, or Pacific in general. However, there are a lot of these ones, particularly in the northern part, like Central Indian Ridge or even Carlsberg, they show values which can only be observed if you get a contamination in the mantle. Now, question is, this is supposed to be a depleted mantle which is tapped by mid-oceanic ridges. Then how is that this mantle is already contaminated? So there are a lot of theories. You can see some sedimentary rocks are also, ocean sediments are plotted here. So the theory is that, hypothesis is that probably even before the Indian Ocean opened, the mantle which existed here, it was already contaminated by some kind of subduction. Of course, subduction was happening all the time, but these have not homogenized yet. That's why you are able to see this contaminated upper mantle having some kind of recycled crustal signature. Recycled crustal signature is usually found either in the mantle wedge in a subduction zone, or you find them in ocean island basalts where the subducting slab may have gone very deep into the mantle and they are being tapped by deeper mantle plumes or hotspots. However, to have this kind of signature in mid-oceanic ridges, only in Indian Ocean marb you see this. So this is very unique. All right. So if you look at, I'm not plotting all data for ocean island basalts. So ocean island basalts were studied by a lot of people over the years. So ocean island basalts in the Indian Ocean, when initially they studied, they found it to be chemically very different. In fact, it had similar composition like that of what you see in Indian Ocean marb. That means it had a lot of recycled component. Not only that, it had something called Duple anomaly, which named after two people, Dupre and Allegre. So they saw that the composition, isotopic composition of basalts erupted at the ocean islands like Reunion or Kerguelen as a component which is very unique. Then over the years, people studied other.
Professor Ray, we have 2 more minutes.
Yes, yes,
We'll,
I'm there.
Right.
So when they tried to figure it out how it is, and then of course very recently it was discovered that actually through geophysics they found that on the mantle and the core mantle boundary, earlier it was called D prime, now they found that it is actually there exists a large low shear wave velocity province. They call it LLSPV, and there are 2 of them. Just showing a picture of it. That means one is close below the African continent. The other one is below South Pacific. So what is this? This is probably, that's what they hypothesize, is probably where all the old subducting material has been accumulating over a period of time. So if you have subducted material not mixing quickly and they're forming some kind of, let's say, graveyard from which if there is a melting, you are bringing up these ocean island basalts, they will like to give this kind of anomalous signature. So in Indian Ocean, we do see that. However, it is slightly different in the other part. So nonetheless, so there are these interesting things to be observed. Okay, so geochemically or geochronologically, I have listed some interesting problems which I think are interesting. One of the biggest problem in Indian Ocean is because there are a lot of reef jumps and particular downs means magnetic anomalies which are giving you the dates of the ocean floor. They are not properly established because not all of them are dated and the tagging points are probably not that good, or there have been different tonic features which because of which all the signals are obliterated. So there is a proper linking which is required. And not only that, these hotspot tracks need to be established properly. If they are really indeed tracks, for example, 80 degrees ridge, whether it's a hotspot track or something else. So there are many interesting questions I have just listed here. If you can, I mean, if anybody is interested, they should work on this. And I'm pretty sure we will be soon trying to get this, get into this kind of issues and try to resolve or understand the evolution of Indian Ocean mantle through time. Similarly, there are a lot of questions in the Andaman Sea. I am considering Andaman Sea is a different from the rest of the Indian Ocean because it has its own unique features. And there are many questions. I am because this place is very little studied except for Kamesh Raju and this group. And also geochemically, a lot of things are still unknown. So I invite everybody to get into this and try to resolve a lot of outstanding questions. Anything you pick up there is unknown. So a lot of work needs to be done. A lot of interesting things needs to be done because this is a very unique basin. So I have listed a few of them and that which I think are interesting. And if we can work and find out how these basins evolved, then we would have a comprehensive picture about the evolution of Indian Ocean Basin and its tectonics. So this is what I always, this is my slogan. There is a lot more information below the ocean bottom than what is above it, either in the sediments or below the sediments in the crust itself. So thank you very much for your time.
Thank you very much, Professor Ray. It's really, you touched upon many issues and many topics and many several provinces mid-ocean ridges, basins, and the Andaman Sea. As you have rightly mentioned, what impressed me is that Indian Ocean is very extremely complex. Actually, in a way, we are very fortunate to have this Indian Ocean at our backyard. And as you mentioned, who will study? We have to study. Yes, that's one more prominent thing you brought out. And as such, as you mentioned, and as it came out from your presentation very clearly, even though we know some of the first order features of the Indian Ocean, there are many detail. When we go into the detail, there are a lot of knowledge gaps. As you suggested, geochemistry and the geochronology is one of the tools which can actually give a more high resolution inferences than some of the geophysical methods which we employ. Because as you mentioned, the linking of magnetic anomalies and the ages, for example, that always has been a debate between the geologists and the geophysicists. Okay. And these are the things. And then, as you mentioned, in the Andaman Sea, yes, again, a separate domain and more exciting and more complex. One other thing you mentioned is about the linking of the volcanic nature of Barren Island with others, and going to Indian Ocean. Somebody is starting.
Yeah, tag team, can you please mute yourself?
Can you mute? Somebody is. Yeah. So actually, as you have rightly mentioned, I was talking about Andamans. Andamans is very close to our studies and our heart. As you said, we have to concentrate more on the submarine volcanoes, which are existing in the Andaman Sea. That might give you much more clues about the Barren Island volcanism and its roots and evolution. And also, when you said the Barren Island is least studied, most of the studies, unfortunately, as you said, have been concentrated on the subaerial part of the volcano.
Yes.
The surrounding regions also have to be studied in terms of maybe a kind of a OPS network, permanent network that routinely it has to be monitored. That might give us a lot of clues about its evolution and history. So there are a lot actually. If you talk about Indian Ocean, I think it can go on. We can always talk about it, and it's an excellent presentation. Happy that you agreed and you spared your time. Compliments for your studies and presentation. Thank you very much.
Thank you.
Rajiv. Yeah.
Thank you very much, Dr. Kamesh Raju. And I also thank Professor Ray for this excellent talk. Since it's now lunch break, Mahesh will now break and then meet at 1:45.
Yeah, probably we can log in at 1:40 and start right away at 1:40. I know it's a very short time, 20 minutes. We have to have a quick lunch.
We can, yeah, we can have.
I ate your lunch.
Virtual lunch.
And the first talk is by Professor A. Bhaskaran. So, of course, we have already emailed him that if he can be around by that time, then we'll start with his talk. In case he is unavailable because of some other reasons, then we'll start with whomsoever is available.
Yeah, that's fine. That's fine. Okay, let us, I think, conclude this. We once again thank Professor Jyotiranjan Ray for his excellent talk. Rajiv and Mahesh will come back at 13:40.
Yes, sir.
Thank you, everybody. Thank you.
Thank you, sir.
Thank you, sir. I think you will be available online.
Yeah, I'll see there on the other side.
Okay, thank you.
YouTube link, I'll be there.
Sure.
Thank you.
Sure. They are online, I think.
Okay. Yes, sir. Now
Yeah.
it's okay.
Is the speaker ready?
I think Professor.
Yeah, he is around.
Yeah, it's only.
Yes, happened. Good afternoon, sir.
We can hear you.
Good afternoon, sir.
Yes, we can hear you.
We can hear you. You can.
Are you visible my presentation, sir?
You can share your screen.
Welcome. So, good afternoon to everybody, sir. We are going to talk about that importance of geomorphological characters for setting up resource plans. We are going to see the contents, introductions, importance of seabed geomorphology and selecting intake and outfall, types of intake and outfall, method of data collections, and a typical location of seawater and outfall diffuser. What are the equipments we are going to use, the deployment of settings, and results and conclusions. Now going to introductions. For increasing demand of water in urban and agriculture area, also in semi-arid coastal regions, we have looked to alternative renewable water sources. So for that renewable water source, the seawater rivers osmosis discharge plants have become a essential water for such reasons. For desalination plants, the type of design and construction methodology of intake and outfall seems play the major roles. For the selection suitable corridor in arrived based on geomorphology, the seabed identified are based on shallow seismic survey and side scan survey. The seismic survey will enable to identify presence of buried rock, if any, and side scan give picture of the seabed. The most reliable suitable location will seawater intake scheme. The is focused on strategy to investigate to arrive most suitable corridor location will seawater intake scheme. The case study of one of the
and some interference is coming.
In the west
coast, all have to mute their mics.
Most of the stretches are present with bedrock due to that Western Garden, and the east coast moves dominantly sandy bed. What are the importance of geomorphology for selecting intake and outfall? Seabed geology is very essential to select the best route of pipeline, estimating cost, and stabilize the pipeline and evaluating the design parameters. The seabed geology is needed to determine the best location and selecting optimal alignment. The seabed is also necessary, whether it is clay or sandy bed or any gravel or stones, to identify the fast and pipeline route to seabed and seabed. For laying pipeline and seabed material should be determined probably before final design and constructions. In that case, we are using that subbottom profiles being increasingly used to detect the depth of different density layer, direct narrow view. Also, side scan, it will give the picture of the seabed, any borders or any obstructions there. Coming to the point, the seismic presentation and seabed classification test very usually recommended for determining the seabed potential faulty zone. The types of intake and outfall partition span. There is 4 types of intake and outfall is there. First method is submarine pipeline laid on the seafloor. The seabed is present with sandy bed across intertidal zone. Such area, such geological formations suitable for laying submarine pipeline on seafloor. And elevated trestle. This seabed is present with rocks across intertidal zone and extending the sea. The construction of piled trestle with intake well and seaward end. Both intake and outfall will be on top of the trestle. The outfall pipeline can be lowered on the trestle and suitable depth. And also, and third options, horizontal drain. Whether seafloor is soft sediment or sandstones or rugged item, that place we are suggest to horizontal drilling. And open channel. Open channel intake structures are used for collecting water from surface source. It mostly is used at lake, reservoir, and conveying further into the water treatment plant. These structures are mostly masonry construction to provide relatively clean water for free pollutions. The method of data collection for seabed investigations. One is bathymetry. The bathymetry is very important to laying the pipeline because we have extract bathymetry essential almost to investigations. For example, the planning submarine construction for undertaking environmental impact and shallow seismic survey. The shallow seismic surveys were done by high resolution Bentha subbottom profile. The shallow seismic survey view the subsurface of the geological subbottom. The profiles have different resolution and penetration to the seabed. This seismic velocity profile of surface can be obtained. This velocity models varies material density. The method is therefore ideal mapping for the interface bedrock. We come to the side scan. The side scan surveys are conducted by daily tiny benthos topfish. It is also very for conducting seafloor features. The side scan sonar maps texture of the seabed. It gives information on the biological information such as feature as sand ripples or boulders or any buried pipelines, any cables or work is there. Based on side scan data, seabed classification map can be identified different sediment types with targets. So we have selected two typical locations. One is the sandy coast. It is eastern side of the east coast. That is Srikakulam near Andhra Pradesh. And the left side is Dwarka near, it is Gujarat. It is on the rocky bed. These are the photographs when we taken the investigation on the geology investigations. This is the side scan image. And bottom is the shallow seismic survey. It gives the sediment penetration. And this is the subbottom profile survey. This is typical one we are given where we have taken like this. Subbottom profile survey and side scan sonar survey. And we come to the research and conclusion. We have conducted Srikakulam, Andhra Pradesh East Coast while interpreting the high resolution shallow seismic resections that the sediment deposits like sand or silty clay. The penetration also shows 6 to 50 meters below the seabed. So we can share that image. This is the sediment thickness map. It is near to 5 meters and extending to offshore 15 meters. So the presence of sandy bed and intertidal zone extending to the sea, such geological formation laying subterranean pipe is suitable. The pipeline will grow by seafloor. So this is the photos where taken site visit. This is the beach view, and it is the intertidal zone. These sediments all we have taken the offshores when we conduct the investigations. And we have seen that typical longitudinal section of seawater intake stream for the sandy coast. This is a intake head that we placed at 2 kilometers offshore and connected the submarine pipeline to the pump house. So the pipeline will be buried by below 1 meter. And this is also outfall diffusers. When you reject the brain discharge water, so we have selected a 2 kilometer diffuser part, and it may be connecting to the submarine pipeline to the plant. Another we have going to see the Dwarka. It is the fully rocky bottom. We have shared the cell interpressure map, typical sediment thickness maps. The gray color all entire is a bedrock, and we have a small sediment thickness here. This is a fully rock. So we have shared that typical image. See, the undulation is so. The bed is very rugged with rock water. So the seabed is observed with the hot rocks. The coast location resulting accordingly we suggest to vessel arrangements. These are the shore rocks, and this is the intertidal shore rocks. That borders also we have find during data collections. So in that area, we are suggesting to construct the trussel type. So this is the trussel type. Intake well we have prepared here, and outfall also we have placed a hanging type. I have shared some sample collection at field. So could you see here? This is a data collection. This is the side scan, well, the online data collections. See, it is give the clear picture of the seabed. We are collecting seabed feature as well as bathymetry. This is the bathymetry system, and it is the bathymetry profile. See how exactly we are scanning that seabed. So if you need, we can, any object we have find, we can measure on the onboard side. See. We have some objects, so we can be able to see 3D view format.
Dr. Bhaskaran, please conclude. Bhaskaran, please conclude.
Yes. So we can measure the 3D format also here. So this is the picture of the seabed. We have seen. So this is thank you. Acknowledge. I would like to express my sincere thanks to Dr. Chandramohan sir, former scientist NAO, and Dr. Terry Machado, National Center of Earth Science, for furnishing this support and guidance, sir. Thank you very much.
Thank you, Dr.
Thank you, sir.
Bhaskar. Thank you.
Rajiv, I think you can take over and invite next speaker.
Yeah, sure. There doesn't seem to be any questions. So thank you very much, Dr. Bhaskaran. Now we'll move on to the next talk, that is by Parth Sarathi Jena, and the title of the talk is Role of In situ and Meteoric and Beryllium in Quaternary Glaciation, Marine Chronology and Paleomagnetic Reconstruction.
Okay.
Bhaskaran, please unshare your presentation.
Partha, you can start.
Yes, sir. Is my voice audible, sir?
Yes, you are audible. We can see your presentation. Bhaskaran, can you please mute yourself? Yeah, thank you. Partha, please start.
So, good afternoon. My name is Partha Sarathi Jena. I am a final year PhD student at PRL. The title of today's presentation is Role of In situ and Meteoric Beryllium-10 in Quaternary Glaciation, Marine Chronology, and Paleomagnetic Reconstruction. So this presentation was supposed to be given by Professor Ravi Bhushan, but due to some work, I will be giving this presentation, and hopefully I will be able to convey the scientific points what Professor Bhushan wished to convey here. To start with, I will start with some introduction. What's so special about beryllium-10 and what is its major applications? First of all, beryllium-10 is a radioactive isotope. It has a half-life of 1.38 million years. The the interesting feature of beryllium-10 is it is actually produced through cosmic ray interactions. First of all, it can be produced in the atmosphere. When the cosmic ray they interact with nitrogen and oxygen in the atmosphere, beryllium-10 can be produced. And again, whenever some cosmic ray they reach the Earth's surface, they can also interact with silicon and oxygen. Here also beryllium-10 can be produced. So whatever the beryllium-10 is produced in the atmosphere, we term it as meteoric beryllium-10, and whatever is produced in the surface, we term it as in situ beryllium-10. Now, first of all, because beryllium-10 is radioactive, it can be used to date marine sediment cores. And again, because it is produced by a cosmic ray interaction, and cosmic ray flux, they also depend upon the geomagnetic field variation. It can be used to understand the past magnetic field variation. And again, the in situ beryllium-10, it can be used to understand the chronology of the past glaciation. So this is how this 10-minute talk will proceed. First, I will show the facility we have here at PRL, and then I will go to in situ beryllium-10 and its application, and then I will go to meteoric beryllium-10. So first of all, as we know, these cosmogenic radionuclide have a very low natural abundance, and for that we need an accelerator such that the molecular ions can be broken into atoms, and such that we can get enough blank level. So we have a 1 MB accelerator at PRL, and this has been tested for radiocarbon, beryllium-10, and 26 aluminum. Now, since 2016, we are measuring radiocarbon, and recently, in the last 3 years, we have started measuring beryllium-10, both measurement and processing. Now, typically, we are now able to get 10 to the power minus 14 to minus 15 range of blank. We are now able to get. Now, these are the ongoing scientific programs. Now, we are ongoing scientific programs. Basically, radiocarbon now we are using for chronology, ARC exchange in terms of carbon dioxide, and to study paleoventilation. And again, beryllium-10, we are similarly using it for chronology, again for quaternary glaciation and paleomagnetism. So I will start with use of in situ beryllium-10 to study past glaciation. So here you can see this. This is a basic schematic how it is used to date glaciation cycles. So first of all, when there is a glacial advance, this part of the rock that is actually shielded from the cosmic radiation because there is a glacier cover. And once the glacier retreats, now you can see in this picture, this part of the rock is exposed to the cosmic radiation. Now, in this part, beryllium-10 will start producing. Now, with time, its production will increase, so its concentration in that part of the rock. Now, if we can sample this part of the rock, we can measure the beryllium-10 concentration. We can tell since what time this part of the rock was exposed, so that we can link that to the glaciation. Now, to study this glaciation, we usually sample the moraine boulders. Those are sitting on the top of the moraine. We can sample the eroded bedrocks, particularly looking at the striation, parallel striation marks, which tell us about the direction of glacial movement. Now, we are using this exposure age dating to understand the glaciation cycle throughout the Ladakh region in the northwestern Himalaya. But in this presentation, I will show some of the results that we have got from the Tharu Valley. Tharu Valley is actually present in the southern part of Ladakh range. Here you can see this is the Ladakh range, and here is the Indus River. This is the Tharu Valley. Now, in the past, when the glacier advanced, it covered through the Tharu Valley. Now, these three samples we have actually collected from the boulders on the top of a moraine. However, these two samples we have collected on the valley wall. We climbed to the side of the valley wall and collected these two samples. Again, there is a difference between collecting these two these two samples. The bottom one we collected at a lower elevation, such that when the glacier advanced and retreated, it exposed this part of the sample. So this will tell us about actually the time of glaciation. And this part of the sample, this sample TR4, which we collected at a higher elevation, such that this has no link with the glaciation, and this is exposed since a very long time. So from the field, approximately, we can tell this will give a higher age. However, this will give the exact time of the glaciation. So this is the results what we got here. This is the ages, exposure ages, which I have listed here. First of all, what we got is that these boulders give a very scattered edge, and this is much higher these boulders are giving a much higher boulder age. That could be because these are there could be a complete incomplete removal of inheritance, or they could have originated due to mass wasting and they have no link with the glaciation. However, as expected, this gives a age of 25 to 40 kiloyears, and this one is much older as expected because this is getting exposed since a very long time. Now, actually, detailed investigation are still going on, but primarily from these results, we can conclude probably this glaciation happened during the last MIS2, and because of the lower temperature and probably due to increased westerlies precipitation, because the westerlies are a dominant source of moisture here. Because of these two factors, probably there was a glacial advance. Now, I will move to the next part where we are using meteoric beryllium to understand the past glaciations, magnetic field intensity variation, and to reconstruct chronology of the marine sediment course. So for that, we are now using two sediment cores, and we have measured the beryllium isotopes, both beryllium 10 and beryllium 9 in this course. So to start with, this is the results what we have got in the core SK31209. So first of all, these are our results compared to other available data. The first feature what we can see is that there is an increase in beryllium 10 to 9 production here. Actually, these are low resolution samples which we have completing up to last 43 kiloyears, and these are 10 high resolution samples that are centered at 41 kiloyears. This is basically to understand the past beryllium 10 production changes associated with the Luschamp event. During that 41 kiloyears, actually the last excursion event happened. So that these high resolution samples are basically to understand that event. Now here we have a increased beryllium 10 to 9 ratio. That is because of the overall decrease in Earth's geomagnetic field intensity. Now in these samples we have a peak at 41.2 kiloyears that is obviously associated with the Luschamp geomagnetic excursion. And during that event, we found a 60% increase in beryllium 10 to 9 ratio, which indicates the beryllium production was increased up to 60%. Now, again, we have the record for the core SK31208, but different from that, we have actually the beryllium 10 and 9 measurements throughout the core, that is up to 6 meters. So there are actually, you can see two features. If you can compare the present beryllium 10-9 ratio, you can take that as a standard. Then you can see two features. First of all, there is an increase in beryllium 10 to 9 ratio. One is here and another one is here. That is because of the associated with the magnetic field changes. The first one is obviously due to Luschamp event because that is dated through radiocarbon dating method at 41.2 kiloyears also here. However, for this event, we do not have the chronology, but I think that could be associated with the Iceland basin event that happened at around 190 kiloyears. But for this, that's why I have put a question mark here because I do not have the chronology for that. Again, apart from that, we can see a sequential decrease in the beryllium 10 to 9 ratio. That is because of the decay of beryllium 10. So, but for going with beryllium 10 dating, what we did is that we removed those points which have a higher beryllium 10 to 9 ratio compared to the present day beryllium 10 to 9 ratio. So after removing the data, what we have, we built the chronology of the core that goes up to 350 kiloyears. And for some depths, we could compare it with the radiocarbon dating method because beyond 50 kiloyears, we do not yet have any chronology to compare for the beryllium 10 method. But at least from this comparison, we can say that beryllium 10 dating method also gives a accurate ages, and this core goes up to 350 kiloyears. Now, this is the summary. First of all, we have used in situ beryllium to understand past glaciation, showing that the last glaciation happened at MIS2. And again, we have used meteoric beryllium 10 to understand past magnetic field variation, and so that shows there was a more than 50% increase in beryllium-10 production at 41.2 kiloyears. And again, we have tried to date a sediment core using beryllium-10 to 9 ratio. So thank you for giving this platform to present this talk. Further question can be, I can attend some question if there are, or there can be transferred to this email IDs. Over to coordinator. Thank you, sir.
Thank you, Partha. Thanks a lot. Are there any questions from the participants? I have a quick question, Partha. Why there is such a large error associated with beryllium chronology as compared to radiocarbon?
Yes, sir. Actually, the first problem is that the errors we have here is higher. And again, actually, we are testing this method, but the beryllium-10 dating method is actually well established for sediment cores older than 1 million years, because the decay of beryllium-10 is enough for that. But while testing for sediment cores younger than 1 million years, we are having that problem. So because the decay is not enough and the associated errors are large. So we are having this problem, but the associated errors are large because of the measurement errors, and because we are taking this the topmost part as the recent beryllium activity. So our errors associated with that also. So that's why the errors are higher.
Okay, thank you. If there are no further questions, we will thank Partha and move on to the next presentation. That's by Dr. Upasana Banerjee. And the title of our talk is Paleoclimate Variability and Global Teleconnection During North Gripean Meghalayan Stages from the Southern India. Upasana, you can start the presentation, please.
Hello, sir. Hello?
Yeah, we can hear you.
Yes, sir. Thank you, sir. Well, good afternoon, everyone. We all know about the recent climate change.
Please share your screen.
Acha, sorry. Is it visible?
You'll have a green color box with an notation share screen that you have to click on that.
I think
Green color box at the bottom of the screen.
Yes, sir. That I've shared it. Maybe some system preference it is.
We can't see your screen.
Ma'am, first open your PPT, then go to Zoom and click on green button, share screen.
And actually that I am doing it.
You also have to select the screen. You have to say the entire screen. Share.
So this desktop one, I have to.
Okay.
So maybe some system preference.
No, it's fine.
Ma'am, minimize all things. Then open your PPT.
Okay.
Minimize everything. Open your PPT.
Now PPT is open.
Then go to Zoom platform. You can minimize this PPT also. No problem. Go to Zoom. There is a green button, share screen.
No, that I'm doing it. Actually, it is asking for some system preference. It is asking security and privacy plant access. So maybe you can take the next presentation. I'll just do this system preference part. I'll do
Otherwise,
it.
Mahesh, do you have her presentation, or if you can share, Mahesh?
No, we don't have. If you can email me your presentation, I'm trying to share from my side. Till the time, Raju, you can go to the next presentation.
Okay, then maybe meanwhile we can move on to the next. We'll come back to Upasana a little later.
Yes, sir. That will be great.
Okay.
Okay.
Is Anjana around? Anjana, can you please start sharing, or can you present? Anjana Girish.
Yes, sir.
The title of our talk is Boron Isotope Study of Foraminiferal Carbonate from the Arabian Sea.
Okay, sir. 1 second.
Anjana, share your screen and then you can start.
Yes, sir. I am sharing. Sir, is it visible?
It's coming up. Yeah, it's visible. Just go on to the slideshow mode, please.
Sir, is it visible?
Yes, it's visible and you can start, please.
Okay, sir. Okay, good afternoon to all. I am Anjana Girishas from Cochin University of Science and Technology. And this is I am presenting my dissertation work done under the supervision of Dr. Wali Rahman, Scientist T, NCPR Goa. And my topic is titled as Boron Isotope Study of Foraminiferal Carbonate from Arabian Sea. We all know that carbon dioxide has a vital effect on global climate. And it is exchange and cycle between the ocean, land, and atmosphere by various processes such as respiration, photosynthesis, mineralization, etc. Carbon dioxide is a greenhouse gas, and it has the ability to trap heat. And this is a graph which represents the variation in carbon dioxide concentration from 1958 to around 2018. Here we can see that the carbon dioxide concentration has increased from 280 ppm to around 420 ppm by 2018. This increase in atmospheric carbon dioxide leads to the increase in oceanic carbon dioxide also. So this creates the reduction of oceanic pH. That is we can say that if the concentration of carbon dioxide in the atmosphere increases, it will lead to the reduction of oceanic pH. 1/3 of the carbon dioxide released by human activities is absorbed in the ocean, which leads to ocean acidification. In the present day, around 22 million tons of carbon dioxide is being absorbed by the ocean. Then we can have a look onto a greater time scale, that is from 8 lakh years. If you are observing the time range from 8 lakh years to around 1815, that is during the time of Industrial Revolution, we can see that the concentration of carbon dioxide has only been up to a maximum of 300 ppm. But after Industrial Revolution, from 1850 till 2020, the carbon dioxide concentration has changed from 300 ppm to 400 ppm. That is within a short time span of about 170 years. It has caused an increase of change in carbon dioxide concentration to 100 ppm, and the pH is reduced from 8.2 to 8.1. And if the emission of carbon dioxide in the present rate continues, then the concentration of carbon dioxide in the atmosphere will be 800 ppm and causing the reduction of oceanic pH to 7.7. Then carbon dioxide, when present in the atmosphere, is an inert gas, but when it gets dissolved into the ocean water, it get react with the H2O, that is carbon dioxide, dissolved carbon dioxide, react with water molecule and give rise to carbonic acid. And this carbonic acid dissociate and forms H+ ion and bicarbonate ion. This bicarbonate ion again dissociate and forms H+ ion and carbonate ion. That is 2 H+ ions are produced in this reaction, causing, that is increase in H+ ion will cause ocean acidification. The global warming and ocean acidification is known as the evil twins of increasing carbon dioxide. Then the impacts of ocean acidification. This is a reduced calcification and mortality, change in marine ecosystem, effect on tourism, decline in shell fisheries such as mussels, oysters, and crabs, change in fish behavior, and dissolution of calcium carbonate shell. Then ocean acidification make the shelled organisms difficult to make up their shell. And also it also affects the physiology of fishes, such as it will affect the respiratory and circulatory system of fish, and their life will also become miserable. And the calcium carbonate shell, which are basic in nature, will also gradually get dissolved by increasing ocean acidification. Then these are the objective of my studies: to compile the record of published past CO2 data, to compile the published boron isotope data of foraminifera and its corresponding pH, establish the method to separate boron from natural carbonate sample, and measure boron isotope ratio in foraminifera using MC-ICP-MS. Then now we can have a look how boron is used as a proxy. Boron as a pH proxy. Then boron in seawater exists in two forms, namely boric acid and borate ion. It has two isotopes, 10 boron and 11 boron, 20% and 80% respectively. And abundance of these compounds depends upon the pH. That is, with here we can see that with increase in pH, the concentration of borate ion in seawater is increasing, whereas the concentration of boric acid is decreasing. And also isotopic ratio. Isotopic ratio, delta 11 boron, both borate ion and boric acid is increasing with increase in pH. The organisms like foraminifera, during their shell formation, incorporate some amount of borate ion. By measuring the isotopic ratio, delta 11 boron of this borate ion, we can reconstruct a pH using the following formulas of delta 11 boron and pH. So by measuring the delta 11 boron of borate ion, which are incorporated by the foraminifera, we can reconstruct the oceanic pH. This is a compilation of carbon dioxide, delta 11 boron and pH data. Had compiled the data up to 55 million years. That is, here we can see that in the case of carbon dioxide concentration, here we can see that the carbon dioxide concentration was very high, around in between 50 to 55 million years ago. Corresponding its pH was also very low to around 7.7. And that is somewhere in the past, the pH was very low and the carbon dioxide concentration was very high. But this change in carbon dioxide concentration had increased gradually. It has it has passed through millions of years to reach to this maximum value. But if we observe to the present scenario, here we can see that the concentration of carbon dioxide is increasing at a faster rate. That is the pH of the ocean will be decreased or will also be decreased at a faster rate. That is the thing I need to say with this compilation of data. And this is my study area, a gravity core from southeastern Arabian Sea from a depth of about 2,700 meters was collected. And this core is subsampled at 1 centimeter interval and is wet sieved and is oven dried at 60 degrees Celsius for 12 hours. And the G rubber was separated. G rubber of size 300 to 350 micrometers used for the study. And around 3 milligram sample is required for boron isotope measurement. And the sample cleaning process involved mechanical cleaning, oxidative cleaning, weak acid leach, and dissolution. And after this, the sample is diluted in 1 normal HCl. And after this, we need to separate the boron from this other elemental matrix from the solution. So here we have two processes. One is microdistillation and other one is column chemistry. In microdistillation, the sample is loaded in the cap of this vial and is placed on a hot plate at 95 degrees Celsius for 20 hours. And the boron is collected on this conical corner. And this is used for the analysis using MC-ICP-MS. And the other method is column chemistry. In column chemistry, it's a 3 centimeter length column. Here the sample is loaded through the upper portion and is eluted through this one. Either of the two methods, anyone we can use for the separation of boron from other elemental matrix. Then I had done column chemistry with standard. For this purpose, I had used two columns, A and B, and a multi-elemental standard was used for the study. That is, it include boron with other 70 major, minor, and trace elements were present in that sample, in that standard. And there are some objective for column chemistry. That is, the column chemistry should show a good recovery, and there should be minimum loss of desired element. Here we can see that the collection of the boron had occurred at a step from step number 10 to step number 15, and maximum amount of boron was collected. That is around 1,500 nanograms of sample was loaded. Around 94 to 95% was a recovery. That is for boron isotope measurement, a recovery of about 90% is a good recovery, and that has performed well. Then the second objective is that there should not be any interfering element during the collection of boron. If you are observing these two graphs, it is clear that this is the first graph indicate major and minor element distribution of column B. That is, here we can see that during the collection of boron, that is from step number 10 to step number 15, no other interfering elements were present. Boron was only collected, and this is showing the maximum peak. And likewise, in case of rare earth element also, no other elements were eluted during the elution of boron. And here boron is showing the maximum peak. That is with column chemistry. Then to check whether this is working well for natural carbonate sample, I had also measured natural carbonate sample G-Ruber from this Arabian Sea. Then to check whether there is no isotopic fractionation had occurred, I had measured the sample after NOC chemistry, after doing column chemistry and from micro distillation method, and the result indicate that there were no isotopic fractionation occurred during all these process. Then this is my result and conclusion. That is, boron was separated from matrix with recovery greater than 94%. And I had also reconstructed pH and PCO2 value from delta 11 boron of Arabian Sea. And these values are good agreement with the modern value at the site. And I had obtained a pH of 8.2 and carbon dioxide PCO2 of 246.5. And this is all about my presentation. I am thanking you all for giving me an opportunity to present my work in this conference.
Thank you, Anjana, for a very crisp presentation and very clear presentation.
Thank you, sir.
And also for starting a new work in our country. People are hardly working on boron isotopes of biogenic carbonates. It's a really interesting work.
Thank you, sir.
Is there any question from the participants?
Rajiv sir, can I ask one question, please?
Yeah, Vikram, please go ahead.
Yeah, Anjana, it was a nice work. I'm interested to know, why did you choose GS Ruber for this study, and how the signals of boron isotopes, they vary in the mixed layer and thermocline dwelling foraminifera species?
Sir, G-Ruber was selected because it is found all throughout the year, and it is found on the mixed layer at a depth of about 0 to 50 meters. That's the reason why G-Ruber was selected for the study, and the calibration equation was also there. That's the main reason why we choose Ruber for the study. But I don't know much about the variation because I had done a dissertation work only for 3 months. So I had only know this much detail about this work.
Thank you. Thank you.
Any other question, quick question we can take? And if there are no more questions, then we thank Anjana. Thank you so much.
Okay, thank you.
For a nice presentation. With that, we again go back to Upasana. Let us see if she can share the screen this time. Upasana, are you around? Okay, Mahesh is sharing the screen for Upasana. If you can start the presentation.
You're able to see the presentation, Bharati?
Mahesh, you are not audible clearly.
Okay, you are able to see the presentation.
Yeah, we can see the presentation.
We need to check whether Upasana is online.
Yeah,
Upasana is not online. It's like.
No, she is not online now.
What about the other one? One more.
No, he is not presenting. No, he wrote an email that he will not be presenting. He's not well.
Somebody can contact Upasana. She was there.
Maybe again, instead of wasting time, we can move on to the quick presentations and then.
Yeah.
At a later stage.
I think we should do that.
Yeah, sorry, Mahesh?
You can keep it at the last.
Yeah, we can do that. Yes. Thank you. So we'll move on to the quick presentations. These are short presentations of 5 minutes. It's a nice introduction to this conference, I would say, because everyone gets a chance to show what they are presenting. So the first presentation is by IV Satya Chanakya. Is Satya Chanakya around? I think no, the person is not around. Then Zeba Nazreen. No, Upasana has come back. Upasana, would you like to start now?
Hello?
Yeah, Upasana, please go ahead.
Yes, sir. I'm so sorry.
No, it's fine, please.
So I've sent my presentation, I think.
Yes, Mahesh has
I have
uploaded.
shared.
Okay, thank you so much. Thank you. And I'm so sorry for the delay. Okay. Good afternoon, everyone. I'm Upasana Banerjee
Just a
from
minute.
National. Yes, sir.
Mahesh, can you go to presentation mode? Yeah, that's fine. Please.
Yes.
Upasana, go ahead.
Thank you so much, sir. Good afternoon, everyone. I'm Upasana Banerjee from National Center for Earth Science Studies. And the topic of my today's talk is paleoclimate variability and global tilting addiction during North Crippen Meghalayan stage from southern India. Well, climate change has become most upcoming topic, and to understand the present climate scenario, it is important to understand the past climate. Then only we'll be able to have a better future predictions. Unfortunately, the instrumental records seldom goes beyond last 2 centuries. So generally, people they look into natural archives, and our Indian climate is mainly controlled by the Indian summer monsoon. And the southern India acts as the gateway for the Indian summer monsoon and thus provides a crucial opportunity to understand the ISM variability. So in view of, can I have the next slide, please? So this will be my today's plan of talk, where I'll start with introduction followed by motivation objectives, then monsoon variability and its possible natural forcings and some inferences. Please, next slide, please. Well, as I said, our India witnessed 2 kinds of monsoon: the winter precipitation and the summer precipitation, and which is mainly associated with the lateral migration of the intertropical convergence zone. The peninsular India witnessed 2 types of monsoon, that is the summer monsoon and the northeast monsoon. Of course, the summer monsoon is the major monsoon phenomenon, which causes more than 70% of the rainfall over Indian subcontinent. And it is having 2 branches, the Arabian Sea branch and the Bay of Bengal branch, wherein the Arabian Sea branch is the most dominant branch over Indian subcontinent. And the northeast monsoon is mainly impacts the southeast Indian coast and some part of southern India. Next slide, please. Well, because to understand the present scenario, it is generally people have focused more on the Holocene epoch, which is the most recent interglacial period. Recently, the Holocene epoch has been broadly divided into 3. That is the Greenlandian stage, the North Crippen stage, and Meghalayan stage, based on 2 abrupt climatic events, the 8.2 kiloyear event and 4.2 kiloyear event. The 4.2 kiloyear event has been globally associated with cool environment, global cooling, and dry climate in the tropical regions. And it had the possible mechanism was found to be the southward migration of ITCZ, the cooling of North Atlantic surface water causing bond event, and the occurrence of El Nino type conditions. May I have next slide? Next slide, please. Yeah. The Holocene climate for Indian subcontinent and Northern Indian Ocean has been extensively studied. And people have found the 4.2 global event to be, it has been registered in both marine and continental records, and it has been registered as a ISM weakening period. Moreover, the 4.2 event was significantly registered in the region which witnessed the northernmost, in the continental part, in the northernmost, which witnessed northernmost extent of the ITCZ migration. Next. There are some animations. Next, please. Yeah. In spite of having so many studies, the transition period of North Caribbean and Meghalayan is still poorly understood. So the objective for our present study is to understand the response of monsoon variability towards this NM transition, and also to understand the possible natural forcing responsible for this transition, monsoon variability during this transition period. Next, please. To achieve these objectives, we have selected Shastanputta Lake located in the southern part of the Kerala, because since the Kerala acts as the gateway of Indian summer monsoon, so we selected this location. And a sediment core of nearly 3.7 meter was raised from a mudflat section, and the region is geologically, the lake is surrounded by laterites and alluvial sand and clay. And nearly 6 samples were selected for radiocarbon dating from PRL itself. And the sedimentation rate was around 0.16 to 0.6 centimeter per year. Average, it was around 0.2 centimeter years. Next, please. The sediment samples were analyzed for various organic carbon, nitrogen, and carbon isotopic values. And organic carbon almost remained consistent throughout the core, except during 3600 to 3750 calibrated year before present. Similarly, the delta 13C also remained consistent, except there was an enrichment in the delta 13C values during 3650 to 3750. In order to understand the TOC contribution, we plotted these on the biplot of TOC by TN versus delta 13C proposed by Lamb et al. 2006, wherein most of the sediment, wherein it was indicated that the TOC is derived from both in situ productivity and terrestrial region as well. Next, please. The samples were also analyzed for various geochemical proxies, which indicated that between the weathering and detrital proxy indicated that there was a fluctuating weathering conditions, but weak weathering conditions persisted between 4950 to 4350 calibrated year, whereas a high detrital flux was seen during 37, the green band you can refer, during 3750 to 3900 years, and there was abrupt decline in the both weathering and detrital proxy after 3500 year before present. The arrows, the red band, the red arrows you can see here. Next, please. More or less similar observations were seen for other trace elements and aluminum normalized. Of course, the work is still going on, and we are looking for other proxies as well. But that also shown reduced concentration during the same time period, like weak monsoon during 4950 to 4300, and after 3750 years, whereas a strong monsoon event occurred during 3800 to 3750 years. So we tried to look into the possible natural forcings for this, for which we compared it with other global records. Next, please. Yeah. So in natural global records, we included some natural climate forcings, which included solar and volcanic forcing, and some other climate variables like El Nino, Siberian high, and North Atlantic oscillations, which was there was next, please. There were reduced solar irradiance was observed during between 4800 to 5000, which very well was an agreement with the increased hematite stained grains from North Atlantic oscillation and increased El Nino. And it is a well-known fact that the increased El Nino event results in weak Indian summer monsoon. Next, please. Whereas there were some volcanic event occurred during the 3700, which was it is a well-known fact that volcanic event causes reduction in the causes cool climate, which corroborated with our detrital and weathering proxy where you can see a gradual, the blue arrows here, you can see that there was an abrupt decline in the weathering and terrestrial proxy. But the one thing, but the enhanced weathering and proxy between 3700 to 3900 that we got, it is little, we are little skeptical about it, because either it is because of the strengthening of Indian summer monsoon, as the TSI remained nearly consistently high, or it is because of the increased influence of northeast monsoon or winter precipitation, as there was enhanced Siberian high and southward migration of ITCZ. So we are still working on this on this event, why we got enhanced monsoon event. But rest of the things, yes, the initial and early mid North Caribbean, it was because of solar insolation, and the later part that we are getting is because of sudden volcanic episode led to reduced Indian summer monsoon. Next, please. The inferences are the monsoon has been fluctuating during NM transition, and there was a weak monsoon occurred during this 3750 to 3500, which was most probably due to the volcanic eruption that instigated the climate perturbation. And the fluctuating but peak monsoon during 49 to 50, 4900 to 4300 was associated with the solar forcing, which triggered the El Nino event. And the strengthening of monsoon spell that we got in our record during 39 to 37, it could be due to ISM strengthening, or it could be due to the northeast monsoon intensification. We are still working on this part. Thank you so much. I'm sorry for the problems.
Thank you, Upasana.
Thank you,
Is
sir.
there any question from the audience? Upasana, I have a quick question. You don't seem to have anything exactly at 4.2. That means the 4.2 kilo year event is not at all
I think,
visible.
sir, I think because Kerala witnessed the immediate monsoon strengthening, extensive monsoon we get in Kerala. So maybe it is not much registered, but minor fluctuations in form of minor fluctuations, maybe we are registering. So this is something, it is a recent data that we have got, so thought of presenting it.
And also, if I'm not mistaken, the sedimentation rate you said is roughly around 0.5 centimeter per year?
No, so it's around 0.2 centimeter.
Per year?
Per year, yes, sir.
So then at what interval you subsample the core?
Sir, it's around, because the core diameter was less, so we had to subsample at 5 centimeter interval.
I mean, that's what I was wondering, like if the sedimentation rate is such high, you could have done some better.
Yes, sir. Actually, the only problem was the diameter of the core, because the diameter was hardly 1 inch or 1.5 maximum. So to have sufficient number of sample, we had to sample it at 5 centimeters.
Okay. Thank you so much for
you,
nice presentation. Nice, interesting work. Any other question from an audience?
Yes, sir.
Yeah, Vikram.
Yeah, Upasana, I was just interested in one of your inferences. You said that the solar forcing led to El Nino-like conditions.
Okay.
Just wanted to have an idea, how is that directly related?
Actually, because if solar insolation reduces, it reduces the trade winds, and finally it reduces the strength of trade winds, and finally El Nino is associated with the trade wind intensity, because it weakens, then only El Nino causes. So that's how it is related. Because if you see in the plot, the trade wind is also getting weakened at the same time.
Yeah, because trade wind weakening is the prime reason for El Nino. But is that so much directly linked with the solar force? Anyways, thank you.
Thank you, sir.
Okay, thank you, Upasana. And with the permission of the chair, now we move on to the next presentation. We are going back from monsoon to tectonics.
Oh, thank you.
And that's a short presentation. I invite Ms. Zeba Nazreen to give a talk on crustal architecture and tectonic evolution of the Western Ghats and status of the major tectonic shear zones of southern granulite terrain and their offshore extension and integrated geophysical approach. Zeba, can you please start your presentation? And I hope you know you have 5 minutes.
Thank you, sir. Thank you for your introduction. So I'm Zeba Nasrin. I'm doing my research in CUSAC under the guidance of Dr. Ajay Kumar. Today I'm here to present for the topic, the crustal structure and tectonic evolution of the Western Ghats using geophysical approach with gravity and magnetic studies. So this is a geology and topography of the study area. The geology map has taken from Sunil et al. 2010. Here we can see the Moya, Bhavani and Bavali shear zones, the Palgat Kaveri shear zones, and the Achenkovil shear zones. From this, I have taken the topography map of the area using with the data, topography data by WGM 2012. I've taken the study area from 7 degree north to 15 degree north and 71 degree east to the 79 degree east longitude. The study area includes the land area and the offshore extension. The study area mainly includes lies in the SGT, which is a southern granite terrain, with special emphasis on the Western Ghats. So the gravity and magnetic anomalies taken from the study area, and the Borger anomaly map was prepared using the WGM 2012 data. Here we can see the data. The magenta color indicates the higher anomaly, and the deep blue or the cool blue indicates the lower anomaly of the area, lower gravity anomaly. And this is the magnetic anomaly, which is taken from the EMAG2 V3 data, like was similar to the case. So we can see the Palgat Kaveri shear zone features here, and the Moya Bhavani shear zone features, and the Achenkovil shear zones using the gravity and magnetic data. So to enhance the near and shallow features, I have filtered the both gravity and magnetic anomalies. Here's the gravity anomaly, filtered gravity anomaly. This is the high pass filtered gravity anomaly, which is a wavelength filtering, which enhances the near surface features. So we can see these are the near surface features, which is enhanced for a better interpretation of the data. So these features indicate that they are very near to surface, which doesn't have much interest or influence in the depth. And thus is the upward continued data. So here we can, this upward continuation has done to enhance the deepest features. So here we can see the deep blue feature seen here, which indicates that these anomalies extends from the depth to the shallower regions of this area, which means they have the effect from top to the deepest level. And this is the filtered magnetic anomaly maps. Here also we can see these all are the high frequencies of this area, which have filtered using which has high pass filtered. So these indicates the shallow features or very near surface features. By upward continuing, we are lacking some of the near features, which indicates that these anomalies are limited to very shallow depth, because they have removed wiped out from these areas, like by upward continuing. And this deep blue features is showing the deepest level of sources, like magnetic sources, and they are having still signatures in shallow features also. That's why they are showing deep color here. For understanding the depth to the interface of gravity and magnetic data, we have conducted the power spectrum analysis. So the power spectrum analysis is conducted by windowing these two 16 windows with the window size from 2 degree by 2 degree. So I have taken some of the power spectrum analysis. This is from 4 grids I have taken, from grid 1 and like that. So from this I have estimated the depth to the deepest layer. This is the slope from, this is the deepest layer, this is the intermediate layer, and this is the shallow layer, which is shallow or noise. So the deepest layer here, we have the depth estimated about 17.59. Then likewise, they are having different depth. Here we have 18.29. So these are the depth to the gravity interface, or like density contrast. Likewise, we have taken the spectrum analysis for magnetic data also. For that, we are getting similar. This is the deepest layer. So the depth to the deepest layer we have estimated from this slope, that is 13.4, 13.34, 17, like that we have. So these grid 1 and grid 13, we have estimated, taken both for magnetic and gravity data. So from this, we can see that there is a depth difference in grid 1 gravity as well as magnetic. This indicates that the depth to the gravity interface and magnetic interface may differ, or it's different, because the depth to the gravity interface or density interface represents the upper to say to the crust mantle boundary, but the gravity or density contrast can affect the features from lower depths also, because the density is varying. I mean, it can get the effect from there also. But in the case of magnetic, we are...
Just one line. Sum up, please. Your time is up. Please. Just one line.
Okay, so the magnetization and gravity contrast is different because Curie isotherm I have taken. The Curie depth just ranges till here. Thank you, Simon.
Thank you. We'll move on to the next presentation. That's by Ms. Naina V. Haridas, and the title of the talk is Reconstruction of Indian Monsoon Variability since Last Glacial Maxima from the Bay of Bengal. Again, from tectonics, we are going back to monsoon. Naina, please.
Sir, am I audible?
Yes, please go ahead.
My presentation is shared?
Yes, it is visible.
Okay, sir. It's full screen, right? Full screen? Yeah.
Yes.
Good afternoon, everyone. I am Naina V. Haridas. I joined as an MOS JRF in IETM DUS and currently doing this PhD in National Center for Earth Science Studies. My presentation is on reconstruction of Indian monsoon variability since last glacial maxima from Bay of Bengal. It's a known fact that Indian monsoon is a dynamic climate system which affects the agriculture and socio-economic aspect of the Indian subcontinent and the nearby areas. And Indian monsoon is classified into Indian summer monsoon and Indian winter monsoon, which is caused by the lateral migration of intertropical convergence zone. Indian summer monsoon causes a majority of the precipitation over the Indian subcontinent, whereas northeast monsoon is confined to the eastern coast of India and in the northeastern region. The Indian subcontinent is surrounded by northern Indian Ocean, which has two distinct subbasins, Arabian Sea and Bay of Bengal. Both of these basins are located almost in the same latitude, but exhibit distinct characteristics in terms of temperature, salinity, and productivity. And my research mainly focuses on the Bay of Bengal, which is the northeastern extended arm of the Indian Ocean. It is a unique basin that witnessed both the influences of Indian summer monsoon and northeast monsoon. And the studies exclusively focusing on Bay of Bengal sedimentary records addressing Indian monsoon variability are less. In view of this, the objective of my research is to address the Indian monsoon variability since last glacial maxima from the sedimentary records of Bay of Bengal, and to address the interplay of Indian summer monsoon and northeast monsoon during the major climatic events since past 20 kilo year. In order to achieve the objectives, we have collected studies exclusively from the Bay of Bengal, and we have discussed the studies in, we have broadly discussed the studies in Northern Bay of Bengal, Eastern, Western, and Southern region. The studies from Northern Bay of Bengal have suggested that during last glacial maxima, intensified northeast monsoon with simultaneous weakening of Indian summer monsoon has been reported. During LGM, similarly, an increased peninsular river influx has been reported, and the sea surface temperature has been reported to shown at degrees of 2 degrees Celsius. And during the early Holocene time period, based on the depleted delta ETNO values, IXM strengthening has been reported. From the southern Bay of Bengal, this sediment input from the Irrawaddy River has been dominant, which suggested intensified northeast monsoon during the time period from 5 to 7 kilo year, 14, 19, and 25 kilo year. And during LGM, the sediment input from the Himalayan rivers has shown a reduced input, and sea surface temperature has shown a in degrees of 3 degrees Celsius, And during the early Holocene time period, along with the enhanced solar insolation, ISM strengthening has been reported from the southern Bay of Bengal sedimentary records. From the western Bay of Bengal, based on the isotopic and MG by CAA measurements on foraminifera, has suggested a cooler sea surface temperature during last glacial maxima compared to the present climate. The sediment provenance studies from the western Bay of Bengal has reported that the sediment contribution from Himalayan rivers, especially from the Ganges rivers, has shown a degrees of 30% during the LGM, which could be as a result of the Indian summer monsoon weakening. And during the boiling Alarod period, which is a warm period, during this time period, the depleted delta 18 value suggested strengthened ISM and around 14.7 kiloyear, a rise of SST by 1.4 degrees Celsius has been reported, which demarcated the onset of boiling Alarod period. Later, this warm period is followed by a cold period called Younger Dryas period, during which enriched delta 18 value suggested weakened ISM. And during the early Holocene, the depleted delta 18 value suggested strengthened ISM along with extensive precipitation in the Ganges, Brahmaputra, and Meghna river catchment. And during the late Holocene, the enriched delta 18 value suggested an overall drier climate. From the eastern Bay of Bengal sedimentary records, the oxygen isotopic studies has revealed during last glacial maxima, higher evaporation has been observed, and a generally 3 degrees Celsius cooler sea surface temperature has been reported during LGM. And the major rivers debouching into the Andaman Sea are Irrawaddy, Salvina, and Sidgongs. And during the LGM period, the discharge from this river has been decreased, which could be as a result of weakened ISM. And during around 8 kiloyear, that is during early Holocene time period, the discharge from this river has been increased, suggesting stronger Indian summer monsoon. And the isotopic studies in clay sediments from the Andaman Sea has revealed ISM weakening during last glacial maxima and during Younger Dryas period. And during the boiling Alarod and during the early Holocene, strengthened ISM has been observed. The most of the studies has demonstrated intensified northeast monsoon with simultaneous weakening of ISM during last glacial maxima. During last glacial maxima, the sediment and water discharge from the Peninsula River has been increased with an reduced discharge from the Himalayan rivers. And the boiling Alarod period and a strengthened Indian summer monsoon has been reported. And during the Younger Dryas period, weakened Indian summer monsoon is reported. And in the early Holocene, along with the enhanced solar insolation, strengthened Indian summer monsoon is observed, and followed by weakening of Indian summer monsoon during the late Holocene time period. Most of the studies doesn't demarcate the climatic condition during the Hendrick events, which could be due to the low sample resolution. And the sediment provenance study at different locations of the Bay of Bengal should be extensively studied, and the northeast monsoon variability along with ISM could be better resolved by more in-depth study from the sedimentary records from the Bay of Bengal.
Thank you, Naina. It was like chasing again, but trying to complete it in time. Thanks a lot. You could do that in 5 minutes. Thank you.
Yeah. Okay.
We'll move on to the next presentation, again related to monsoons by Jitu Shaji. Paleoclimate and sea level variability during Holocene epoch from coastal lowland sediments of Kerala, southwest India. Jitu, please.
Yes. So can you hear me?
Yeah, we can.
So can you see my screen?
Yes, we can. Please start.
Okay. Good afternoon, everyone. My name is Jitu Shaji. I'm a research scholar in National Center for Earth Science Studies. And my topic of presentation is on paleoclimate and sea level variability during Holocene epoch from coastal lowland sediments of Kerala, southwest India. As we all know, Indian summer monsoon is a major climatic phenomenon that our country experiences, which contributes more than 70% of the rainfall over the Indian subcontinent, thereby influencing the socio-economic status of our country. And the southwest coast of India acts as a gateway for the Indian summer monsoon and provides an excellent opportunities to study the climatic variations along with the sea level changes in the region. And we have retrieved a sediment core from Kuttur region of Pathanamthitta district of Kerala state. And as you can see as a star here, represented by the star here. And the area is drained by Manimala River and Pamba River. And the general geology is of Chanakya group of rocks and a laterite terrain nearby. And is located on the southeast portion of the Vembanad Lagoon. These are some field photographs, and we have collected a 32-meter long using rotary drilling method. And we have performed the cinematological, and geochronological, geochemical, and palynological studies for the Kutur sediment core. And based on the cinematological data, the majority of sediment type is of silty clay and clay in the from the sediment core. And based on the Pejrup's diagram, we can see that it has been deposited mostly under calm to slightly turbulent energy conditions. And we have also analyzed for certain spores and pollens also. And certain spores and pollens can be indicative of characteristic climatic conditions. For example, the spores of Collini exhalata can be indicative of high rainfall conditions, and the presence of foraminiferal linings and Cosinoticus species, which is a marine diatom, can also be indicative of marine influences in the area. So the palynological study shows a transition from a terrestrial environment with the marine incursions to a tropical humid conditions. And we have also analyzed for the major and trace elements for the Kutu sediment core. And based on the data, we have seen that from around 9.4 to 7.6 kiloyear BP, there has been an enhanced detrital influence, suggesting an ISM strengthening during that time period, which is also corroborated by the palynological data. And from around 3.4 to 2.5 kiloyear, there has been a reduced detrital influx. But from around 3.4 to 3.2 kiloyear, there has been an intermittent monsoon spell indicated by the increasing detrital flux into the in the region. And at around 1.8 kiloyear BP, we can see there is an abrupt increase in the detrital flux, mostly could be due to the increase strengthening of Indian summer monsoon due to the Roman warm period at that time. And coming to paleoweathering proxies, majority of the proxies are actually showing an increased but consistent values from around 9.4 to 7.6 kiloyear BP. But from around 3.4 to 2.5, even though there was a weakening of intensive monsoon at that time period, the values are showing a marginal spike. This could be due to the influx of materials from the nearby laterite terrain. At around 1.8 kiloyear pp, which cooperates with the Roman warm period, there has been abrupt changes in the values can be seen, which could be due to the fluctuating hydrodynamic conditions during that time period. And we have also plotted data in ACNK and ACNK FM diagram, and it all shows that the samples has undergone comparatively intense chemical weathering, and when the samples, as you can see in the ACNK diagram, is plotted more towards the AL203 apex, suggesting undergoing an intense chemical weathering conditions, and when extrapolated backwards shows a intermediate source of composition. And when ICV values are plotted against CAA values, we can see that the samples, majority of the samples have undergone intense weathering and are texturally mature. This is a paper in 2014 done by my guide. He has explained the evolution of Weberad Lagoon in tandem with sea level and climate variability during the Holocene epoch. And based on the data and comparing with our data, we could, based on the present study location, it possibly highlights the southward extension of the Weberad Lagoon. Based on the studies that we have done on the Kutu sediment core, we have come to the inferences such as the sediments has been deposited under calm to slightly turbulent energy conditions, and from around 9.6 to 7.4 kiloyear BP, high detrital flux at the marine transgression has been observed in the study area. And from around 3.4 to 2.2, there has been a weak monsoon with an intermittent monsoon spell at 3.4 to 3.2 kiloyear BP was also observed. The weathering proxies suggest intense chemical weathering along with mixed sources, and the presence of marine influence in the study area located south of Weberad Lagoon demonstrate the possible southward extension of the lagoon during Holocene, which gradually attains its present configuration after 3.4 kiloyear BP. Thank you.
So, dot in time, 5 minutes. Very good.
Thank you, sir.
Just a quick clarification. You had, how did you date this core?
So we used rotor drilling method. We used a team, like we consulted with a team, and we took it from like it's a private company. We collaborated with them.
Asking, how did you date? How did you get the chronology for it?
Okay, date. Okay, sir. We are using AMS facilities, sir.
So there were certain reversals of age as well.
Yes, sir. Yes, sir. So at some portions there was some reversals was there.
So then how can you? I mean, if there are several age reversals, how can you have a linear chronology then?
Sir, it's actually very less when comparatively. When compared to the old length, the reversals are very less. Like at some portions, maybe due to the intermixing or something, some ages has been reversed.
Right. think that portion you need to look into little more detail. Anyway, thanks a lot.
Yes, sir. Thank you, sir. Thank you for your session, sir.
We'll move on to the next presentation by Mr. Tejeshwar Das. Another interesting talk on magnesium bicalcium of marine carbonates as a paleotemperature proxy, a case study of the southeastern Arabian Sea for the past 40 kilo years. Tejeshwar, please.
Am I audible, sir?
Yes, please go ahead.
Okay. So good afternoon, everyone. So this is my wait. Good afternoon, everyone, and this is my topic which I am going to present here. I am a JRF in start. Should I start my video or
No, it's fine. It's okay. Go ahead.
Oh, thank you. So this is my topic, MGYC of marine carbonates as a paleotemperature proxy, a case study from the southeastern Arabian Sea for the past 40 years under the supervision of Dr. Manish Tiwari from NCPOR Goa. So moving on to the topic. It's not moving on. Okay, so these are my objectives. As you all know, the South Asian monsoon induces intense biogeochemical changes in the Arabian Sea, which makes it an important area to study the past monsoon variability. The Southeast monsoon causes strong upwelling in the Western Arabian Sea, but moderate upwelling in the Eastern Arabian Sea during summer that reduces the SST. So due to intense convecting mixing due to northeast monsoon in the Eastern Arabian Sea, intense precipitation also occurs, which also affects the Western Ghats of the southeast part of the India. So these are my objectives to cover. To accurately quantify the climate variability in terms of oceanic temperature and salinity changes from Eastern Arabian Sea since last glacial period, and to understand the past monsoon variability using new temperature and salinity data acquired using this study. So this is my study area. Core location is from the southern coast of the southern tip of Indian territory. It's XK 274-1G recovered from this location, and core length is 376 centimeter, water depth of 1491 meter, and a span goes up to 6.1 to 43.1 kilohertz pp. And the sampling resolution is at every 1 centimeter. So this region is interesting area because it is affected by the region is experienced upwelling during summer, leading to high productivity in this region, but the south part of it experiences moderate productivity. So productivity generally ceases towards the south, and mostly this some productivity is noted, and it is due to the deepening of mixed layer depth. So these are the proxies which used to reconstruct the climate of that region. The trace element proxies MGY-CA of planktic foraminifera of G river for quantifying SST, and oxygen and carbon isotope ratios planktic foraminifera G river. So G river is a oligotropic species, mixed layer species. So it typically denotes the SST. So this all analysis has been done in NCPOR. NCPOR is optical emission spectrometry in paleothermometer lab of NCPOR, and the delta 13C and delta 18O has been done in marine stable isotope lab. IRMS is the instrument which is used for calculating the delta 13C and delta 18O. So these are the preliminary results of my core. This is the quantification of SST from the southeastern Arabian Sea, in which we have used these calibration equations to quantify the SST from Dickens et al. 2002. So this is my whole result and the comparison plot with Saraswat sir 2005 and Govila and Naidu 2010. So here we can see that this is the interesting part where since the last glacial and the recent deglaciation and the Holocene has been correlating well with all those studies, but this MIS3 SST has been is continuously more than, I think, the recent or Holocene period. So this is the interesting part. We are looking into this matter for further study. And this is the most interesting thing. And since delta 18O and delta 13C measurement are underway, are ongoing, so we cannot specifically tell the salinity and this all these relations in MIS3. But in during this LGM, this data also corresponds to our next slide, where I have denoted the delta 13C and delta 18O signatures, which shows that these delta 13C values vary between 0.93 to 1.91 per mil. The delta 13C value can overall indicate the ambient productivity. So the last glacial maximum was 3 degrees Celsius cooler. It was 3 degrees Celsius cooler than the present. The delta 18O values was average around 0.5 per mil, where it was higher during the MIS2, indicating lower SST and higher salinity. The values become low for average around -2 per mil during the early Holocene, suggesting higher SST and lower salinity during that period. So due to this is a preliminary result, and SST variability addresses the changes in climate. It is a sensitive parameter and can be affected by pH, salinity, and other carbonate concentration ratios and all. So further we will study these parameters to quantify the non-thermal effect on this SST. Thank you.
Okay, any quick question from the participants? Tejeshwar, this data seems to be, I don't know, I mean, not in, maybe it's like new area or something, but not in line with what has been done from this region. You are showing much warmer MIS3 and MIS4 than the Holocene.
Yes, sir. So
And
this
also
is
a temperature increase of almost 10 degrees centigrade from the LGM to recent. I think you need to look at that again. Mahesh, you want to add something? Mahesh?
Seems to be very high. This is your
Yes.
NGCA ratio seems to be very high during MIS3.
Sir.
Probably you need to recheck. It's
Sir,
pretty high for that period.
Sir, since it is like continuous for very high resolution data, and for all 40 samples it is found that temperature only. So I don't think it might be the case where I may be contributing that error. But anyway, I'll look into that. So thank you, sir.
Yep. Thank you. Thanks a lot, Tejeshwar. So we'll move on to the next presentation now. That's by Sarat Chandra Prasad, again on the monsoon variability, and the title of his talk is South Asian Summer Monsoon Variability During the Mid-Piancesium Warm Period. Sarat.
Yes, sir. Yes, sir. Hello. Can you hear me, sir?
Yes, we can hear.
Yes. This is first slide. Good afternoon, everyone. Myself, I am Sarat Chandra Prasad from NCPR. Hereby, I am presenting a monsoon reconstruction work from the marine sediment coasts. The title of the work is the South Asian Summer Monsoon Variability During the Mid-Piancesian Warm Period. As we know, the monsoon is the socio-economic background of the highly populated region of the Asian continent, and it is formed as a hello.
Just a small suggestion. I mean, this we know, so better you can concentrate more on your results part.
Yes, sir.
We had more time.
Yes, sir. And this modern variability of the monsoon is known for the unexpected changes with the extreme climatic extremes, and hence it is highly required to understand a warm period monsoon variability. To understand this warm period as some variability, we reconstruct the warm phase as some variability of the Earth's near climatic history. This period this period is known as the mid-Piancesian warm period, which is abbreviated as the MPWP. And why it is considered as a climatic analog is because of that it is this period is having a similar modern atmospheric PCO2 around 400 ppmv and a similar to modern geographic and climatic boundaries. For that, I am using the IODP sediment course, which is named as U1456, which is collected from a water depth of 330. Actually, it is 3,036 meter water depth from the Arabian Sea. And based on the available chronology, we selected the MPWP sections, and the major element geochemistry is measured using the ICP OES. The geochemical proxies are identified after understanding the inter-elemental association of the elements using the PCA, and a proxy strategy is developed for the heterogeneous inputs, weathering, plasticity, and productivity, which collectively represents the SISM variability during the MPWP. These are the results, which is the SISM variability during the mid to late Persian. I used the weathering proxies as the Mg by AL and K by AL, and the clusterity for T by Ca, and heterogeneous input is the concentration of titanium. Two productivity proxies on the different phases are used to understand the productivity variability, and we found that the gray bars indicated in the figure, which is having a higher monsoon, which is indicated by the high weathering and terrestrial input, and productivity, which is in close correspondence with the global climatic pattern. And here we can see that the productivity proxies are indicating a near similar pattern without any big changes, which indicating that the enhanced stratification leads to this low productivity during the MPWP. And the weathering proxies indicated all these proxies collectively indicated a intensification of this monsoon at 2.95 MA, which is not in correspondence with the northern hemisphere glaciation or Tibetan uplift or the Himalayan exhumation during that period. Hence, it suggested an oceanographic cause, which can be caused due to the tectonic reorganization of the Indonesian gateway and changed the thermal structure of the equatorial and the southern equatorial Indian Ocean, and leads to the intensification of the monsoon. This spectral analysis and violet tensor analysis indicated that the eccentricity is the major Earth's orbital parameters which governed during that mid-Paleocene warm period. And I'm concluding that the mid to late Paleocene interglacials have a strong monsoon, and which is in close correspondence with the climatic patterns, and the Earth's orbital parameters, which is oriented towards the eccentricity modulations. The obliquity parameter came in action only during the late Pliocene or the late Paleocene, which is identified with the help of the violet scalograms. A monsoon event, intensification event at 2.95 is also identified by this work, which is induced by the oceanographic forcing by the reorganization of the Indonesian through flow. That's it, sir. Thank you.
Thank you, Sarath. It was well ahead of time, even in less than 5 minutes. Thank you so much. Any questions from the participants or anyone? Okay, no question. Then we thank Sarath, and then we move on to the next presentation by Dr. Vikram Pratap Singh. And the title of his talk is Intensification of Oyashio Current as Possible Cause for Reduction in Western Pacific Warm Pool during last 1 million year. Lentic foramiferal evidences from the Sulusi. Vikram, please.
Thank you, sir. Is my screen visible?
Yes, it is visible. Please go ahead.
Okay, thank you, sir. Hello, everyone. My talk today is on the intensification of Oyashio current as the possible cause for reduction in the Western Pacific warm pool during last 1 million year. I have put possible cause in quotes because I got some evidences from this almost equatorial marginal sea, the Sulu Sea, of all the East Asian marginal seas Sulu Sea is a very important and strategic sea, wherein if we see the current dynamics over here, the ocean circulation pattern, the Sulu Sea, it is connected to the Western Pacific and the South China Sea through these several straits. So if we see over here, the trade winds, they cause the formation of this Western Pacific warm pool by bringing in the waters from the Pacific Ocean. Then near the Mindanao, the North Equatorial Current bifurcates into the northward moving Hiroshima and the southward moving Mindanao Current. Furthermore, through these several straits, the Pacific Ocean water enters the South China Sea, and from there, this water enters this relatively pericratonic basin of the Sulu Sea. So basically, the Sulu Sea gets water from the South China Sea through these Mindoro and the Balabac Strait. Then it gets water from the Western Pacific Ocean, or more to be more specific, the Western Pacific warm pool through the Dipolog Strait, and then it gives its water to the Celebes Sea through the Sibitu Passage. So we can see here that the Sulu Sea, it may give us a snapshot of the conditions of these oceans and these seas as it gets the input of water from all these areas. My study site was the ODP core 769B drilled in the leg 124, and it is at a water depth of almost 3,600 meters. While studying the planktic foraminiferal evidences from this core, I found these results wherein uh, I saw I took four important groups. One was Culinatina obliquloculata, the relative abundance correlated with GS ruber, and then temperate fauna, wherein I used Globorotalia inflata, Neogloboquadrina pachyderma sinistral, and Globigerina quinqueloba. Now, normally being an equatorial ocean, the warm water species were very high over here. But I got these 5 instances of an extreme decline in the relative population abundance of Polyneatin obliquloculata, which is a globally reported event and has been named as Polyneatina minimum events PME. So when I correlated these events, I found these 5 typical instances wherein I saw a low but a significant rise and presence of the temperate faunal species, and I correlated them with the delta O18 records of Ruber. And within those 5 instances, I found a positive excursion in the delta 18 records, which I have presumed that they could be due to they could be cooling events. And if we look at the dynamics of the oceans in that area, the only reason for the influx of this cold water over here is the Oyasho, is the cold fertile Oyasho current. What we have inferred over here is that the reduction of the trade winds during these periods had led to a reduced Western Pacific warm pool, which was coincidentally also supported with an increase in the influx of cold waters of the Oyashio current. The cold waters of Oyashio current did not allow the Western Pacific warm pool to expand much, and then the extreme cooling over here is supported from the increase in the temperate fauna. These were those events wherein the Polyneatina population declined to almost zero. Other than this, we have also found some of the PME events, but we have correlated them as El Nino events because there was almost no significant increase in the temperate fauna, and the delta 18 records were also showing a negative excursion. Apart from these significant foraminiferal events, we also found an increase in the relative abundance of productivity indicators, more specifically Neogloboquadrina deuteratrii. So what we have presumed over here is that the increased influence of Oyashio current due to the migration of northern polar front, it led to the influx of cold eutrophic waters and the entry of these waters in the Sulu Sea via the South China Sea Straits. They led to the increase in the fertility conditions, leading to an increase in the productivity indicators of these planktic foraminiferal species. So the inferences which we got over here is that the 5 events that of the reduction in Western Pacific warm pool, which were corroborated on the basis of the reduced relative abundance of obliquloculata, were due to the intensification of the cold Oyashio current.
And we have inferred it based on the low but significant increase in the cold water temperate species and positive excursion of delta 18O values of GS Ruber. And then the reduction of Western Pacific warm pool restricts the influx of warm Pacific waters in the Sulu Sea, which would have caused the lowering of the sea surface temperatures. And these glacial events are very well marked with the delta 18O episodes from the Sulu Sea. Thank you.
Thanks a lot, Vikram. Any questions or queries from participants? If there are no questions, we thank you, Vikram, and we move on to the next presentation by Mr. Vikas Kumar. And the title of his talk is Southern Ocean Linked to Indian Monsoon Variability During the Last Glacial Period. I understand this paper is recently published in a very reputed journal, that is Paleoceanography and Paleoclimatology. Vikas, please.
Thank you, sir. Unfortunately, I'm getting the same error which Upasana was getting because I'm using a Mac system. So maybe I will request Dr. Mahesh to share my presentation.
Okay, just a moment. Yes, Vikas?
Yeah. Okay. Thank you, Dr. Mahesh. Good afternoon, everyone. I'm Vikas Kumar from NCPR, and the title of my presentation is Southern Ocean Linked to Indian Monsoon Variability During the Last Glacial Period. Can you please move on to the next slide? Can you please share the next slide? Yeah. So this work is basically based on a sediment core ABPS4 which we collected from the Indian sector of the Southern Ocean. And for convenience, we will refer to this region as SML, which in short stands for Southern Mid Latitude. So what we basically did was, this is a 40,000 year record. So what we basically did was measured magnesium by calcium ratios on the foraminifera shells. And because we can also grow these things in the laboratory and collect a lot of core top samples, we have lots of paired magnesium by calcium and sea surface temperature values, which can then be used to regress the geochemical data onto climate variable of interest, which is sea surface temperature in this case. And so I used a Bayesian calibration model to map this geochemical data to sea surface temperature. And the primary rationale behind this study was to generate high-res quantitative climate data in the undersampled Indian sector of Southern Ocean, and perhaps use this data to infer the effect of southern latitude climate on tropical climate system, which is largely driven by Indian monsoon circulation. So can you move on to the next slide? So directly moving to the results, we observed coldest conditions during LGM, so no surprises there. But anomalously, we observed warmer MIS3. For the first time, I also saw Tejaswar had shown something very similar to this, but this is from southern mid-latitude region. I will try to explain why we believe there could be a reason behind this. And the glacial interglacial transition was of 4 degrees Celsius magnitude. And the overall, the deglacial evolution was of Antarctic style with HS1 warming and ACR cooling. Now, we also used an intermediate complexity Earth system model to compare with our record, where we observed reasonably high correspondence between the reconstructed and the model simulated data, which shares all the millennial scale features, and also the values are within 1 sigma range of our own data. We also compared our record with the northern and tropical Indian Ocean records, where we observed that the millennial scale features were matching with the SML record. And also the Eastern Arabian Sea and Northern Bay of Bengal surface hydrography records were similar to the SML conditions. Can you move on to the next slide? So trying to answer that question, why we get warmer MIS3, we observed this not only in our record, but also in the simulated model data. So we do not doubt the accuracy of these reported values. Now, this core is located very close to the region where the Indian Ocean exchanges a lot of heat and salt with the Atlantic basin. So changes in heat transfer in this region can impact the surface temperature variability. So to check that, what we did was we computed the east-west zonal gradient in surface temperature in the Indian Ocean and the and the South Atlantic. And we observed that a higher east-west gradient during MS3 compared to those appearing during the Holocene suggests that the Douglas return current carried more heat into the SML region during MS3. This was most likely due to the decrease in cross-basin exchange with reduced Douglas leakage, as the subtropical front occupied a more northerly position during the last glacial period. And evidently, the highest gradient values are observed during LGM when the northward STF movement would have likely peaked. Please go to the next slide. So we also compared our record with the SML SST record with monsoon record, and we observed a near one-to-one coupling between millennial scale oscillations and SML SSTs in millennial scale oscillations in Indian monsoon circulations and SML SSTs. And low SML SSTs were invariably associated with higher monsoon strength and vice versa. So next slide, please. Next slide, please. In order to explore some of the mechanism behind this tight association between SML SSTs and Indian monsoon circulation, we looked at this gradient in surface temperature between the northern and the tropical Indian Ocean. And what we see on the right is a plot of scatter between the surface temperature gradient and SML SSTs. We clearly see ellipsoidal densities, which suggest a strong covariance between the two. And for reference, we also compared it with NINO 3.4, which shows circular densities, suggesting that Eastern Equatorial Pacific was not a dominant driver of such millennial scale oscillations during this period. Can we go to the next slide? So not only the thermodynamics, even the dynamics seems to be tightly coupled to the SML SSTs pertaining to the Indian monsoon circulation. So on the left, what we see is again the surface temperature gradient in the equatorial Indian Ocean compares very well with the SML SSTs. And on the right, again, the SML SSTs appears to be tightly coupled to a dynamical aspect of Indian monsoon circulation, which is vertical shear in zonal wind. So both thermodynamics and dynamics appear to be tightly coupled to the SML SSTs during the period. Can we go to the next slide? While the association between surface temperature gradient in the Indian Ocean and SML SSTs would have likely been facilitated via oceanic tunneling of anomalies, we could also possibly have a direct atmospheric bridge connecting the SML SSTs influencing Indian summer monsoon, and that is through modulation of mascarene climate in the mascarene high, because the core is located very close to the southern limit of the mascarene high. So what we did was we computed the cross-equatorial pressure gradient between the mascarene high and the northern Arabian Sea. And on the left, we can see that during the glacial, while the trend between SML SSTs and the cross-equatorial pressure gradient was positively correlated on the orbital scale, there is a clear anti-correlation on the millennial scale. This aspect is more clear when we turn to MIS3, where orbital trends are not very strong. So we get a clear anti-correlation between the cross-equatorial pressure gradient and the SML SSTs. So with this analysis, I would like to thank.
Thank you, Vikas. Since time is less, we'll move on to the last presentation of this session, and that's again from the same lab by Shubham Tripathi. And the title of his talk is Denitrification and Hydrographic Variability During Mid-Pleistocene Transition, Results from IPP Expedition 355. And part of these results were published again in a very good journal, scientific report some time back. So Shubham, over to you.
Hi everybody, I'm Shubham Tripathi, and I will give you a bird eye view of denitrification and hydrographic variability during the mid-Pleistocene transition. And these results are from IODP Expedition 355. And sir, this is the last chapter of my PhD and it is not yet published. So yeah, so this is the location of site study, and I will discuss the results from IODP site U1457. I will directly go to the, I will directly like to highlight the findings of the study. So we find that the productivity of the Eastern Arabian Sea and the Western Arabian Sea shows a synchronous variation during the mid-Pleistocene transition. And during this study, the study is spanning from MIS 18 to MIS 28. So during that period, we have found this. and the denitrification record from Western Arabian Sea show a similarity in the variability, but the intensity of denitrification is high in the Eastern Arabian Sea. In the hydrographic part, we find that the mixed layer temperature shows a huge variability in MIS 21 with an average value of 23 degrees Celsius across the MPT in the early MIS 21, and it reaches as low as 19 degrees Celsius in the late phase of MIS 21. The precision and insulation 15 degrees south matches well with the variability of oxygen isotope of G cyclifer, and it co-varied in some of the MISs during the mid-Pleistocene transition. We also did the spectral analysis, and the continuous wavelet transform shows that 24 kiloyear periodicity dominates from 0.97 million years to 0.85 million year. The periodicity of 24 kiloyear and 65 kiloyear could be explained by precessional cycles and multiple precessional cycles. Also, the record reveal and provide evidence that southeastern monsoon variability is mainly driven by precession, and there is an influence of precession and insolation 15 degrees south on the southeastern monsoon, and these results are corroborated to the findings of Bolton et al. 2013 and Jagirjoadis et al. 2018 that the southeastern monsoon is sensitive to the southern hemispheric warming. Now I will jump to the results on the basis of which I have told you all these findings. So the figure 1 is showing the variability of denitrification and productivity in the Eastern Arabian Sea. And we can see that from MIS 21, variability from MIS 28 to 18. The first panel is showing the variability of denitrification. We can see very huge variabilities there. But on the basis of 6 per mil threshold, we can see that during this period, denitrification is almost very high. And it is supported by productivity. So panel B and panel C, these two are the productivity proxies. And we can see that when the denitrification is high, productivity is high. So it is supporting the denitrification. Also, we did the provenance analysis, and on the basis of that, we find that most of this sedimentary organic matter is from the marine origin. And in figure 2, we have compared our variability records from Western Arabian Sea. So panel E, F, and G are the records from the Western Arabian Sea. And as I have discussed already, that the intensity of denitrification is high in Eastern Arabian Sea as compared to the intensity in the Western Arabian Sea. So this figure shows that a clear heterogeneity exists in Western Arabian Sea and in between Eastern Arabian Sea. And again, coming to the hydrographic variability, panel A is showing the delta oxygen 18 of G cyclifer variability, and then mixed layer variability is shown by panel B. And we have compared these two records with precession and insolation 15 degrees south. So in the early MISs, that is from MIS 28 to MIS 25, we can see 1-to-1 match of monsoon variability, which is shown by this panel A, and precession and insolation. And as we move towards the MIS 18, we can see that the amplitude of precession and insolation 15 degrees getting lowered, and which is and even the monsoon is following this variability. So we can say that the monsoon variability is driven by precision and insolation 15 degrees south. And the temperature, we can see that it is also showing very huge variability, and MIS 25 has noticed a very high temperature, but unfortunately in this data, we don't have data from Eastern Arabian Sea, but studies by P.L. Gibbard and Martin H. They show that after this MIS, there is a huge variability in the temperature, and we have observed that in our results. The cross-wavelet transform shows the cyclicity of 65 kiloyear, 24 kiloyear, 15 kiloyear, and 6.9 kiloyear. And I have already discussed that this can be explained by precessional and insolation 15 degrees south. So this is all about my.
Thank you, Shubham. Thanks a lot for being in time. Just a quick question. How did you get the chronology for this section of the site?
Yeah, so we have done the oxygen isotope stratigraphy. So we have used G cyclifer data. Is it visible? So we have got 11 control points. On the basis of that, we reconstructed the oxygen, this SDIP model.
Okay. Thank you so much. And with this, we conclude all the talks, both longer talks and the short talks. I now hand over to the chairman and my co-coordinator, Mahesh.
Okay, Chairman, sir, I think he can conclude because we are well in time. We are at 3:45 p.m.
Yeah, I think quickly we should wind up actually. It's very good, excellent presentations. It's very, I mean,
I think some problem with his audio video. I think he's logged out. Meanwhile, Mahesh, can you summarize the talks? Let him join, then he can continue
I
afterwards.
think he's online. We'll wait for a couple of seconds.
we are coming up with the Oceans 22. Oceans 22 conference to be held in Chennai, February 2022. I think there is already call for papers. I think there is a one session on marine geology geophysics. Most of you can participate and submit abstracts. Finally, I thank OSI and organizers for giving me this opportunity. And thanks again to Rajiv and Mahesh for excellent coordination. Thank you.
Thank you, sir. Thank you, sir. We can wait.
Mahesh.
Yes, sir.
You can conclude that, sir.
Yes, sir. Thank you, Chairman, sir, and thank you, Rajiv. Now we can join the valedictory function that is going to start very soon. So we can conclude this session. Thank you. Thanks. Thank you, everyone.
Thank you, Mahesh.
We are all supposed to leave this platform.
Yes, sir. We can join on. Go to the YouTube link that is available.
Okay.
Prasad, can you hear me? You are mute, I think. You are mute, I think.
Yes, I can hear you, Pattabhiya.
Yes, I can hear you. Hi, Mani. Hi, Mani.
Good evening to all of you.
Some echo is coming and
am I audible?
Yes.
Yes, Mani.
Okay, fine.
Yeah, I think it's fine now. Avinash, I'm hearing my voice with a lag again.
What is the problem?
No, once I speak,
no, I think
after
you
some time it is echoing.
No. Please unmute. Oh, yeah.
आप इससे आवाज मत कीजिएगा completely. Here it is on. So, yeah, please, I think. Sir, at least you play only one system, no YouTube. Otherwise, it will be echo sound will be there.
Yes, Avinash, I see that. No, I just closed the YouTube.
Yeah. Because of YouTube, there will be a conflict.
Patavi, you got both, all the 7 plus 7, no?
Yes, Ravi.
Okay.
Yeah, but it is not as per the session. No, it is different sessions like.
Yes. It is
No need to read the papers, no?
No, just the name only announced. Even we are not able to make the certificate ready. Only thing is, you can.
Sir, lot of echo is there. Sir, lot of echo is there.
I think not for everyone, sir. I think you may just play only one system only. Our is fine. We don't have any echo.
Ravi, you are saying something. It got.
No. What I was telling is, you just tell them that the certificate and the award, Momento will send it to you by post.
Okay, Ravi. Okay, done.
Vibration, all vibration.
ललित जी अभी भी नहीं कनेक्ट हुआ क्या अभी तक नहीं कनेक्ट हुआ मेरा
क्यों कनेक्ट हुआ
ये अभी वाईफाई पे चल रहा है म्यूट कर दिया
सही है ना
बैकग्राउंड हटाओ ना
अविनाश जी बैकग्राउंड हटा दो हाथ कट रहा है केवल कोट आ रहा है बैकग्राउंड हटा दो नहीं तेरा कट रहा है पूरा शोल्डर वोल्डर सब जा रहा है
It is like that only. Background is keeping like that only.
Shoulder gone because of the color, right? Otherwise, no, you get content.
रिफ्लेक्शन का इफेक्ट हो रहा है
No, still yeah. The problem is the background. Now it is okay. You will just turn, it will go.
No, you cannot move. When you are in the background, you cannot move.
You have to be still.
Now, Surya, fine.
Hi, Josia and Smita.
Hi, good evening, Bharati.
Good evening.
Good evening, all. Good evening.
Good evening, Josia. Yeah.
Good evening, Josia.
Good evening.
Good evening, Kurian sir. Good evening, sir. Sir, you have to unmute, sir.
Yes, good afternoon to everybody.
Yeah,
Good
afternoon, sir.
Professor Prasad, good afternoon.
Good afternoon, sir. Good evening, sir.
Yes, Avinash, good afternoon.
Yeah, good evening.
Sir. Good afternoon, sir.
Good afternoon. So I think how your conference went very well.
Yes, sir.
Yes, sir. It went very smoothly.
Good. So it was both hybrid come physical or only online?
Online, sir.
Completely online, sir. Virtual mode.
Sir, now session is live on YouTube.
Right.
Yeah. So whether we will wait for 4 o'clock or we'll start now?
No, we'll wait.
We'll wait for the time, 4 o'clock.
Yeah. There is still 4-5 minutes.
Yeah.
Yes.
I thought, let me get in little early so that if there are any hiccups.
Yeah. Just Sir, one request that whether you are sharing your PPT or we will be sharing your PPT.
Sir, please unmute yourself.
Sorry. We will try. I will try, but let me see.
Okay, sir. We have also one copy. Okay, sir.
Yeah. Is visible?
Not yet, sir.
It has come?
Yeah, it has come, sir.
Okay. Okay.
Yes, sir.
So
Now you can unshare, sir.
yeah.
There will be in the top, sir.
Yeah.
The top, it is the red one is there, sir.
Yeah. I'm not very familiar, so that's why I stop share.
Yeah, it is working.
So I will try, but in case if it doesn't happen.
Yeah, we have some copy.
Because normally I use our e-classroom, so but today being a holiday, I thought I will do it from home. So Goa, it is raining or it's dry?
Now it's dry, sir. Not raining.
Not much. Huh?
Yeah, some small spell will be there.
So Korea, how's situation in Cochin?
Sorry, you mean the COVID?
COVID.
Yeah, it is a bit, high.
High.
Yeah, we are mostly at home.
Yeah.
No other activity.
So Onam at home only, or you will celebrate?
Yes, sir. We have no other option. No
Sir,
other
with
option.
permission, we can start now. It is 4 o'clock.
Yeah. Sure.
Curiosity is more important than knowledge because curiosity leads to learn more. If science has to grow, the younger generation, who are the future of the country, should take up the challenge. Very good evening and warm welcome to all the honorable dignitaries, eminent speakers, scientists, researchers, and dear students present here. I, Dr. Avinash Kumar, feel privileged and take a noble duty to welcome the gathering to the valedictory function of the 7th National Conference of the Ocean Society of India, Osicon 21, for the theme of Ocean for Sustainable Development. Ocean, the largest ecosystem of the Earth, home to millions of species, is the best indicator of ongoing climate change. And this conference is aimed to recalibrate our relationship with our ocean. On behalf of organizing committee, I would like to express my sincere appreciation and gratitude to all the distinguished chairpersons, moderators, presenters, and participants who have participated their work and presented their work, which I think have made 3 days conference very successful and fruitful. To be honest, the COVID-19 outbreak has made us highly concerned about the hosting Osicon 2021 in person. And we had a sense that some complicancy may arise if host the virtual platform. But with the support of all the organizing committee members, speakers, chairpersons, moderator, and especially the presenters, made online event great success. So now I would like to invite Dr. Manimurli, Joint Secretary, OSI, Principal Scientist of National Institute of Oceanography, to give the welcome address. Please, Dr. Manimurli.
Thank you, Avinash. Greetings from Goa. Good evening to all of you. Now we have come to the end of the 7th edition of Ocean Society of India Conference, Osicon 21, organized jointly by OSI and NCPOR. All the sessions on all 3 days were successfully completed. A big thanks to the local organizing committee. The conference had 13 invited talks, more than 100 oral presentations, as well as more than 100 poster presentations, covering 7 themes, especially first time in Osicon history, a theme on mathematics in ocean sciences. On behalf of the OSI and Osicon 21 organizing committee, first, I welcome our chief guest for the valedictory function, Dr. Shailesh Nayak, first honorary fellow of OSI, Director NIAS, and former Secretary MOES, for kindly agreeing to be here with us on this wonderful evening. Thank you, sir, for joining with us. OSI is proud that you will be the first honorary fellow, and on behalf of each and every one present over here, I convey our congratulations to you, sir, and we are all honored with your esteemed presence here virtually. We are very eager to listen your plenary talk, sir. I also welcome Vice President of OSI, Dr. N.P. Kurian, former Director, NSS, to be here with us for this valedictory function. We all appreciate the effort put forth by the technical committee for reviewing and selecting good quality abstracts for this conference. With great pleasure, I welcome the chairman of the technical committee, Dr. Prasad K. Bhaskaran, Joint Secretary of OSI, Professor IIT Kharagpur, to this function. I also warmly welcome Dr. Pattabi Ramarao, Scientist G in KAIS, Hyderabad, Dr. Josiah Joseph, Scientist NIOT Chennai, who are GC members of OSI. They will be announcing the best presentations for oral, poster, and student competition program. I welcome Dr. Smita Balraj, Treasurer OSI, Scientist CMLRE, who is safeguarding OSI funds through this function. Finally,
I welcome the registered delegates, invited speakers, chairmen and coordinators of all the sessions, presenters, participants, research students, scientists and sponsors. My special invitation to National Advisory Committee, members of local organizing committee and technical committee to this valedictory function. Their tireless efforts are felt in this conference. I'll be failing in my task if I don't mention Dr. Ravichandran, Director NCPOR, Chairman Osicon 21, President OSI in this welcome address. Sir, your guidance and consistent support has made Osicon 21 a grand success. I welcome you to this valedictory function. Osicon 21 was a launching pad for many young researchers in the field of oceanography. I wish all those budding early career researchers to achieve greater heights in future. Osicon 21 has given a benchmark in the history of virtual conference in India. We are sure that pandemic situation will not prevent us anymore from listening the wonderful scientific presentations. With these words, I wholeheartedly welcome everyone who are part of this conference, as well as who are all watching this function through your YouTube live from various parts of the country to this valedictory function. This is Mani Murali, Joint Secretary OSI. Jai Hind. Over to Avinash.
Yes. Thank you, Dr. Mani Murali, for your motivational words. Before going the next, I would like to quote one quote by Sadhguru. He says that logic is simple if you do the right thing. The right thing will happen to you even without your intent. So as this conference, which was organized to bring all the eminent researchers and scientists together, today it has successfully completed its 7th edition. That has to be on virtual platform. I request OSI Fellow 2021, Professor Prasad K. Bhaskaran from IIT Kharagpur, Joint Secretary OSI and Chairman of Technical Committee Osicon 2021, to kindly briefly summarize the conference outcome. Sir, please.
Thank you, Dr. Avinash. So good evening, esteemed members of the Ocean Society of India, ladies and gentlemen. It is a matter of great pleasure and honor to give a briefing on Osicon 2021. Firstly, I would like to start with a little bit of history behind the OSI conference, Osicon. Since 2009, the Ocean Society of India has initiated in organizing the biennial conference, Osicon. There were 6 conferences already held, and the previous Osicon 2019 was held at CMLRE, Cochin. All these 6 conferences were hosted by leading academic and research institutes such as Andhra University, Visakhapatnam, the National Institute of Ocean Technology, Chennai, the Indian Institute of Tropical Meteorology at Pune, the National Institute of Oceanography, Goa, and the National Center for Earth Science Studies at Thiruvananthapuram. And the 6th one was held at CMLRE, Cochin. So this is the 7th National Conference of OSI, the Osicon 2021. This conference has been very successful in bringing and bridging together the professionals and the students working in the broad area of ocean sciences, engineering and technology, and allied fields in sharing their knowledge. The theme of Osicon 2021 this year was Ocean for Sustainable Development. Osicon 2021 was organized in 3 parallel sessions on each day. During these 3 days, we had a total of 13 invited talks, a total of 216 abstracts, 113 oral presentations, and 103 poster presentations. The invited talks were delivered by eminent personalities from organizations such as CM Malawi Cochin, Incois Hyderabad, University of Maryland, USA, NIO Goa, Cotton University Guwahati, NCCR Chennai, IITM Pune, Sanctuary Beach Private Limited Singapore, NCPR Goa, IIRS Dehradun, NIOT Chennai, and NCES Thiruvananthapuram. There were a total of 7 themes that covered various aspects on marine ecosystems and biogeochemistry of the ocean, coastal and open ocean processes, climate change, polar science and cryosphere, ocean engineering and technology, marine geology and geophysics, mathematics in ocean sciences. A total of 38 abstracts were received for the award category. The theme climate change had a total of 7, 5 oral and 2 poster. Coastal and open ocean processes had a total of 10, 6 oral and 4 poster. Marine ecosystem and biogeochemistry of the oceans had a total of 12, 5 oral presentations and 7 posters. Mathematics in ocean science had a total of 2, and both were oral. Ocean engineering and technology had a total of 5, and all the 5 were oral. Polar science and cryosphere studies had a total of 2, both were under the oral category. Also this year, in this pandemic situation, we have received very active participation and very good quality papers from the students and researchers from the length and breadth of this country. All the technical sessions had very good presentations and deliberations. I take this opportunity to thank all the members of the National Advisory Committee, the Technical Committee, Organizing Committee, and the GC members for rendering their active support in conducting the review process of all the abstracts received for Osicon 2021 in a timely manner and very smoothly. It was a wonderful experience, and I look forward for the active support. Thank you, one and all.
Thank you so much, sir, for giving your brief remarks about technical and Osicon 2021. That was really wonderful for us. If you're to become more with gathering. So please. I think he has not joined.
Dr. Avinash, is it for me?
Yes.
I just missed that part, Okay, yeah. So good evening, one and all. Respected Chief Guest of the Day, Dr. Shailesh Naik, Honorary Fellow, OSI, Director NIAS, and former Secretary to Government of India, Ministry of Earth Sciences, Professor Prasad Bhaskaran, Dr. Pattavi Ramarao, Dr. Mani Murali, Dr. Josiah Joseph, Dr. Smita Balraj, and other distinguished members of the Governing Council of OSI, delegates of the Osicon 21, members of OSI National and Local Organizing Committee, and other distinguished attendees of this valedictory function. It's a matter of great satisfaction that we have successfully completed the Osicon 21, and we are in the concluding session. It is my pleasure to tell a few words in this concluding session. Osicon 21 is the 7th biennial conference of the OSI, as has been told by Professor Prasad Bhaskaran. The first one was at Visakhapatnam in 2009. As heard from the report just now presented by the Chairman Technical Committee, the conference had more than 300 registered delegates and 216 papers. Out of that, 113 was oral. There were 13 invited talks by eminent scientists on emerging areas related to the focal theme of the conference. In terms of participation and technical contents, this conference really excelled. This conference will always be remembered for the innovative way it was organized. That we have been able to conduct it successfully in spite of the pandemic is a matter of great satisfaction. Sorry. The whole credit goes to Dr. Ravichandran and the whole team from the NCPOR. Let us give a big hand to the whole team. The feedbacks that we receive from different delegates is indeed very positive. Though all of us miss the personal meeting, this is indeed a unique experience. OSI, since its inception in 2006, has come a long way, as was narrated by Dr. Ravichandran in the inaugural session. We have a life membership of around 550, which is expected to grow considerably in the coming years. It already has 3 chapters at Cochin, Chennai, and Pune. We are expected to have 3 more chapters at Goa, Delhi, Kharagpur very soon. The membership is expected to grow considerably in the coming years. Our tie-up with the Indian Meteorological Society, IMS, has increased our visibility considerably. OSI is observer at International Seabed Authority, ISBA, and member of the Federation of Indian Geoscience Association, FIGA. In addition to biennial Osicon conferences, we have periodically organized seminars, workshops, panel discussions, webinar series, etc. on themes of topical relevance. These are just some of our achievements. Now coming to what we can do for the future, the OSI can play a dominant role in the development of ocean sciences and technology in the country. We are passing through a challenging times, as is evident from the just released IPCC report. Climate change is going to play havoc with the lives and livelihood of people of the country. I think today's news, you must have read about the flood that is happening in Japan, which is unprecedented. In these changing times, OSI will have to shoulder increasing responsibilities. We need to come out with action programs that can contribute to sustainable development of the seas around India. Dr. Rajivan, former secretary of MOES, in his inaugural address was referring to the dearth of trained manpower in the field of ocean sciences and technology. He was also referring to the newly approved mission mode program on deep ocean mission and the blue economy policy of Government of India. In this context, it is indeed heartening that Dr. Shailesh Naik is going to deliver a talk on stewardship of blue economy just after this. OSI, with its enhanced footage across the country, can play a pivotal role in the development of human resources in the field of ocean science and technology. One of the major objectives of OSI has been to attract young minds to the ocean science and technology. Our webinar series, initiated during the pandemic, is indeed a powerful tool in dissemination of knowledge to the community at large, particularly to the youngsters. The PG Dissertation Award Program, which is under implementation for the last 2 academic years, is very much in that line. The online competition for marine science students on Science We Need for the Ocean We Want organized as part of Osicon 21, is a novel attempt on the part of OSI. Dr. Rajivan in his inaugural address was stressing on the need for developments in ocean modeling. OSI had conducted 2 hands-on trainings on mathematical modeling for students and researchers. The first one, ROMS at CUSAT in November 2012, OCMOD 19 at CUFOS in June 2019. Unfortunately, due to the pandemic, these efforts were discontinued, but I think it is time now we need to live with the pandemic and continue with such programs. I understand that the OSI Cochin chapter under the chairmanship of Professor Jayachandran has chalked out a program on sensitizing school students on ocean sciences. This Catch Them Young policy can be extended to the other regions of the country too. Another aspect is the knowledge gap that is existing between the scientists and decision makers. This is particularly true as regards coastal management. It is high time that the decision makers are apprised on the coastal processes and the need for site-specific scientific assessment for choosing appropriate coastal protection strategies. This is applicable in other fields like exploitation of coastal ocean resources, tourism potential, pollution abatement, etc. OSI can think of conducting regular training programs for policymakers and engineers to alleviate the knowledge gap and that is prevalent in different disciplines. OSI can also think of tie-up with the coastal NGOs who can be the focal points for our efforts in sensitizing the local community on coastal ocean processes and creating a litter-free coast. The Cochin chapter, with the support of a local NGO, had organized such an event in 2019, but it was again discontinued due to the pandemic. The different the chapters of the OSI can have tie-up with NGOs at different locations and carry out such cleaning operations as well as conduct awareness programs. These are just a few issues which I felt, which came to my mind that I should present here. There may be several other areas in which we as a community can contribute. On behalf of the OSI GC, I request each and every member of the OSI to contribute their might to attain the objectives of the OSI. I also request your support in enrolling as many members as possible in the OSI. Let us look forward to a pandemic-free Osicon 23. Thank you all for the patient listening.
Thank you so much, sir, for your motivational word and nicely briefing about the background of OSI and their aims and objective. Now we will be most awaited program we are moving. It is our honor for us to have an eminent personality for the today's chief guest, Dr. Shailesh Nayak, Director NIAS and former Secretary Ministry of Earth Sciences, among us. In the Osicon 2021, Dr. Shailesh Nayak sir has been honored by the first honorary fellow of OSI. Sir is one of the distinguished earth scientists of India, specialized in coastal and ocean processes, air-sea interaction, coastal hazard, coastal geomorphology, geological geomorphic processes. Dr. Shailesh Nayak sir is a person of acknowledged eminent in ocean science and allied field, and led the conceptualization, installation, and operationalization of the first tsunami early warning system of India, which is being successfully utilized by the country in the Indian Ocean Rim. As a secretary of MOES, Dr. Shailesh Nayak sir has initiated several new programs, centers, activities relating to monsoon prediction, global climate change, and the use of earth system science for overall societal benefit. Dr. Shailesh Nayak sir, a fellow of Indian Academy of Science, National Academy of Science, and many other scientific societies of India. Define success on your own terms, achieve it by your own rule, and build a life you are be proud of live. On this note, I request sir to kindly give your remarks. Sir, please. Sir, please unmute your.
Thank you very much for this honor which has been bestowed on me by the Ocean Society of India. I accept it with a great humility, and I really found me honored and privileged to be a fellow of such an important society. I also like to thank you, all of you, for excusing me for not attending the inaugural function because of my health, and you gave me another opportunity to present my views on the blue economy. I will share my screen now. So let's see. Is it visible?
Yes, sir.
Yeah.
Okay. So thank you very much. And I was very happy also to listen to the what happened during this conference. And I really very proud that such a good number of presentations done and a lot of work has been done in this, and especially for the young researchers. As we know that in the last few years, the word blue economy has been coined several places. So I thought this would be a good topic to talk to you about my views on this. Actually, the blue economy is basically the economic activity which is dependent on ocean. But there are three more issues that we also need, that it should be inclusive. That means inclusive of a social development, also ensuring the environmental and ecological security. So this is what we want, is that since we know that the economic development has led to degradation of the environment, and that is why we need, when we are planning the ocean-dependent economy, we have to be very, very careful that we don't disturb or do minimal damage to environment and ecology. But at the same time, we continue to grow, improve the quality of life of people, and do the inclusive social development. So this was the basic concept, and this was first time introduced by Professor Gunter Pauli in UN, essentially in the view of the climate change, that because of the climate change, we may have to depend more on the ocean in the coming years. And then subsequently, you know, the third World Summit, the UN SDGs, and the Blue Economy Summit, which happened in Nairobi in 2018, all supported this idea, and India is committed to the blue economy. Now, there are several issues which we need to address. The fisheries and ecosystem, minerals, energy resources, marine spatial planning. In India, we also called as a coastal regulation zone, water quality, hazards, and the response mechanism. There are several international laws and the treaty, those we need to understand, shipping industries, manufacturing industries, security and strategic dimensions, and the how we develop the accounting framework, that whatever the economic benefit is coming out from the ocean, that accounting framework currently is not available. So we need to build that also, and to build overall policy, which Ministry of Earth Science is now engaged in developing this policy. Today, I'm not going to talk about all this. I will pick up only the 4 topics briefly, considering the time what we have available. Now, the first is the minerals. We have plenty of placer minerals, both on the beach and nearer to the shore, up to 100 meter, especially along the Kerala, Tamil Nadu, Andhra, Orissa, and Maharashtra. And these minerals are basically ilmenite, rutile, kyanite, garnet, zircon, monazite, and especially ilmenite is one of the largest reserves, about 22% of the world reserves. Now, currently on the beach side, there is some mining going on, but on the ocean, which is near shore, there have been identified blocks 5 minutes by 5 minutes by Ministry of Mines. However, there is not much development is happening because of a variety of reasons. There are many issues, but we have not been able to exploit these resources yet. And the total value of these resources is about 150 billion. So it's a huge resource. And we have all the technology for mining, for beneficiation, everything is available. So this is one area which we need to address and see that how we can develop this sector. Second, of course, the deep sea minerals, polymetallic nodules, we know all about this. Last 2 decades, a lot of work has been done. India has about 75,000 square kilometers in Central Indian Ocean. And now the first mining site of 12.5 meter by 12.5 kilometer has been also identified. All the work related to environment, beneficiation, everything has been done. The total value of this resource is 187 billion. So it's a quite huge resource which we have. Now, the next stage we will come that the certain technologies are to be developed. The other polymetallic sulfides, which is mid-oceanic ridges, which currently the exploration work is going on. And I understand that some of the vents have been identified and the detailed analysis of the rocks and all those things is undergoing, especially in NCPOR. And this is very important for the availability of a copper, lead, zinc, but more important, there is a gold, silver, palladium, platinum also is available. So this is another area which is very important. And we have about 10,000 square kilometer area which is to be explored. It may take some time to completely explore and find out how much resources is available. But the initial indications are very positive. The cobalt is one which is a very critical mineral in high-tech industries, and India do not have resources on land. And they have located almost 2 decades back a resource on Central Indian Ocean. Still, the exploration rights are yet to be taken, but I'm sure that in coming years, we would be taking up. So if you can see that we are going very systematically, we have tried to explore the areas and where we have some positive, we have gone right up to developing the mining site. The exploration for the polymetallic sulfide is going on, and for the ferromagnesium crust will be taken up in near future. The third issue is about the energy, especially the ocean-related energy, offshore wind, which has a tremendous potential and is about 61 gigawatts on Gujarat and Tamil Nadu coast. There was a proposal for 1,000 megawatt offshore wind farm in Gujarat. However, I understand now there is some likely to be shifted maybe to Tamil Nadu. Current cost is about 10 rupees, which is quite high, but I'm sure that with the development of technology and this will further reduce. The major issue in developing offshore wind farms is you need a very specialized kind of an infrastructure. You need a very custom-built vessels. You need a port where there is a special facilities to take the turbine to the sites and then service them and several other things. So this is also is very critical. The developing farm alone is not going to resolve the issue. We also need very specialized infrastructure on the port. And that is why currently this total cost of building infrastructure and all is relatively high. So there are certain issues which we need to address. I'm sure in coming years, we would be able to address them. The wave and energy, there are experiments done, but the issue is how we can scale it up. The ocean current has a tremendous scope because you can generate large amount of energy from this. But here, the major issue is the turbine. We need to build a turbine which can be used to take of this ocean currents. Thermal energy is another very huge resource, but it is still under experimental stage. We need to learn many things before we would be able to generate. But otherwise, it's a huge resource. I mean, the resource is so high that all our energy needs can be satisfied by this. Now, this is some of the technologies which is being developed by NIOT. And the first thing which is required is that you need to understand the seabed characteristics. So based on that, you can design your mining equipment. So the soil tester, which can measure all kinds of properties of the soil, its strength and many other properties, is been developed, tested right up to 6,000 meters. So this is one of the major achievement, I would say, that this could be done in a time completely indigenously. The second, which is very important development, is the remotely operable vehicle, which also can go up to right up to 6,000 meters. It is kind of a satellite which has can take a payload of 150 kg, and you can measure all the properties, whatever you need. And it has arms, you can collect the samples. And this also has been tested up to 6,000 meters. And the mining equipment, what we call as a crawler, is also has been developed. And this will collect the nodules and make it slurry and give it up to push it up to the ship. And this, I understand that will be tested in 6,000 meters this season. So basically, we are now ready with the all technologies. Of course, when actual mining starts, you will have to scale it up. You have to collaborate with the industry to make such equipment in many numbers. Also, there are many other issues of bringing those material back to, or you develop a platform and process there itself. So there are issues, but I'm sure that in next 10 years or so, we would master all these aspects. Water is one of the most important aspects, and India has developed this at an IoT, the low temperature thermal desalination, is one of the classic example of the innovation which has been done by India. This works on a very simple principle. They taken the water, saline water from the surface, which would be about 22 to 24 degrees centigrade temperature, and brought to the vacuum chamber. It boils and evaporates. The vapor is collected in another chamber, and it is cooled down by bringing water from about 800 meters or so. And you get a fresh water. It's a very simple physics in this, but the engineering is very critical. And India has 6 plants now on Lakshadweep Islands, and the Agati plant has been working for last 15 years. So this is really an operational, and the important part that's completely changed the life of the Lakshadweep Islanders. Their health issue has been resolved. There were a lot of issues about stomach-related ailments because the water they were having was dirty, and so this now has dramatically improved that. Similar principle is now being tried for the power plants, and also ultimately we need to scale it up to 10 million liters on ocean-based plant, which also the work is undergoing. So I think this is a kind of a thing which is India has developed this technology and shown that how it could be really useful. And this is environmentally very friendly, unlike RO, which releases very highly saline bitten into the west into the sea, while this is not, this uses only about 8 to 10% water. So whatever is released is more or less the same kind. Coming to the living resources, what we need to do is we need to build models. There is some work is being done in CMLRE that how we would be able to predict the stock of the fishery annually, every year after the year, like what we do in a crop. And this, of course, there's a very complex process to understand the physical and biological interactions. And this maybe for different species would be quite different. So we need to do this. And I'm sure that if we can do, then we can plan our fishing strategy that whatever the kind of potential available for particular area in a particular time, accordingly we can decide that fishing, how much fishing should be allowed. So this is another major area which is work is being done. There was a lot of mention about the climate change, and there is a definite shift which has been seen, especially in oil sardine and mackerel. These were the majorly earlier available on Kerala and Karnataka coast. But after 1985, it has been seen that the Kerala and Karnataka do not have that much catch of the sardine and mackerel, but at the same time, the catch has increased in Goa and Maharashtra, as well as on the east coast, both Andhra and Tamil Nadu. Now, this is very important because as the further climate or ocean warming takes place, this kind of fishery, which is one of the most important fishery of India, can dramatically change. Actually, last year, the Maharashtra has a bumper catch of the sardine. So many times this low catch on Kerala and Karnataka was considered because the overfishing, but it's not that. I think that there is a change is happening. And I think there may be many other species, there could be many such change. So we need to look into these aspects also. The algal bloom is another major area which can affect the fisheries. And it's very nice that the system for algal bloom monitoring and the informing the fisherman and the all other concerned that when it is likely to happen, when it is likely to grow, and when it is likely to decay. So this is another very important from the economic point of view, which service has been developed. There is a lot of work done by CMLRE on the deep sea fishery, and large amount of resources have been found, especially in the depth right up to 2,000 meters. Of course, to harness this resource, you need a lot of new technology and processing, and the vessels would be needed. But there is a huge amount of resources available. The current estimate is about 3.3 million tons, which is more or less same as what we are catching today, about 3.6 million tons. So this is a huge resource is available. Also, there is a lot of experiments in the ornamental fishery on the Lakshadweep Island, very successfully done. And I'm sure that it also provided a lot of employment to women on the island. So this is one, I think we need to further scale it up. Similarly, the open sea cages growing cobia and milkfish has been very well successful. Again, here we need to further scale it up to a level where fishermen can regularly use this. The CMFRI has now been doing black lip pearl. They have understood the complete life cycle in the lab. I'm sure that in coming years, we would be able to operationalize this technology also. And I think we need not have to restrict ourselves only to the Indian water. In Antarctica also, the krill is one of the very huge resource, and India is not currently utilizing its share in the krill. And I think in coming years, we should do. It has very important because this is a omega B, this major comes from the krill. So this also is another area which we need to look at. And since all the ocean activity will be conducted from the coast, so we need a planning, science-based planning of all different activities which we take on the coastal and marine, and how do we manage so that development is sustainable. So in India, we have a coastal regulation zone, which has 3 notifications, 91, 2011, and 19. And India is one of the very few countries in the world where the coastal zone management plans for the entire coast is available on a very high resolution. I mean, 1:25,000 scale. So this is extremely important, and this could be achieved because there was a large amount of people who have been now, each state has now understood the importance of the coastal zone management, and the plans have been made. So these are the kind of maps which has been produced for the entire country, and these maps are then converted into a coastal zone management maps. The other important aspect of the economic development that we need to identify which are the areas on the coast which are vulnerable. And fortunately, India has the complete understanding about the coastal vulnerability. The maps for the entire Indian coast is now available. It is very complex process by generating this coastal vulnerability index, but this has been done and the maps are available for everybody to see. And recently to develop the tourism, the certification process, there is a European Federation for Environmental Education. They give a certified if your beach has certain safety, the kind of condition of the beach, the water quality, the facilities on the beach, depending on all these aspects, the blue flag certification is given. And India has now joined. Already India has 8 beaches which has been certified as the blue flag beaches. Another 10 beaches has been submitted to FEE, and I understand by September we are likely to get another 10. The idea is that to develop about 100 beaches on the Indian coast, which are very safe, water quality is good, and all other facilities on the beach is available. So this could be another important area of economy where the high-end tourism can be developed. At the same time, when you want the understanding of the science is going to be always very critical. And if you don't do that, all the services and the benefits which we want will not sustain for a long time. So the second International Indian Ocean Expedition was launched in 2015 after considering, because the Indian Ocean, there are several issues which are yet to be understood about what its societal benefits and some of the science issues about the boundary current dynamics, monsoon, ocean circulation, extreme events, and various biological, physical, biogeochemical processes. So there are a large number of projects, and many countries have been involved in this. And India has taken a major initiative to push this. And this is now up to 2025. So I think will provide a lot of new information which will be coming from the Indian Ocean, we would be able to utilize for the economic benefit. And all this information, which is now being integrated as a digital ocean. So all heterogeneous data, I think this is something which is a classic, which has been done at INCOIS, that all the information, whatever available, you can put it the way, and you can retrieve in the way you want along a transect or in the 3D or a 4D or a point. So this is what I think is going to be very critical for us for the blue economy. And I think the most important is what I see is that the investment in ocean is going to increase. And we have seen that this year, the government of India has already declared a deep ocean mission to know about the resource, to build service and the technology. So that, and similar thing, I'm sure that will be continuing. Now, the most important is that the various scientific data which all of you are collecting, and also some of the environmental data. Now we have to learn to integrate this information along with the social and economic data. Because unless we do that, we won't be able to develop a system where we can say that protecting environment also and is also makes an economic sense. So in the blue economy, I think this is the most important aspect, that we have to build a framework where we integrate the scientific data with the environmental, social, and the economic data. Then only what I said in the beginning, that the social inclusion and ensuring environmental and ecological security along with the economic development can happen. So to do this, we need an institutional framework and a policy. And if we can do this, I'm sure that ocean will provide a sustainable growth. Thank you very much for giving me this opportunity and accommodating me in the valedictory address. Thank you very much.
My sincere thanks to you, sir, to enlighten us about the blue economy and terms of boosting the Indian ocean research and economy by deep mineral resources and renewable energy. Here comes the most awaited time for all the presenters. Awards not only bring the honors to awardee, but also motivates the young minds. Before I request Dr. Patabi Ramarao, GC member OSI, and scientist G, INCOIS, to kindly announce the award, I would like to quote a few lines by Sanford: learn how to be a loser, because it's important to be a loser to be a winner. Now invite Dr. Patabi Ramarao to kindly announce the Best Paper Award under the category of Oral and Quick Presentations to recognize and appreciate the best work presented by researcher in Osicon 2021. Sir, please.
Thank you, Avinash. Our chief guest of the valedictory function, Dr. Sailesh Naik, Director NIAS and former Secretary MOES and first Honorary Fellow of OSI. Dr. Ravichandran, President OSI, Dr. N.P. Kurian, Vice President of OSI, esteemed office bearers and members of the OSI, Organizing Committee of Osicon 2021, chairs and coordinators of the technical sessions and delegates of Osicon. Good evening and greetings from Hyderabad. At the outset, I would like to thank the organizing committee for giving me this opportunity to announce the awardees for best oral and poster presentations in the Osicon 2021. I thank all the chairs and coordinators of the technical sessions for the successful conduct of technical sessions and also selecting the best oral and poster presentations. On behalf of the organizing committee, it's my privilege to announce the best oral and poster presentation awards. Now I announce the oral presentation category. The first award goes to Sunanda N, from IIT Kharagpur in the thematic session MEBO. Second award goes to Samiran Mandal, IIT Bhubaneswar, in the thematic session COPE. The third award goes to Akhil Varghese Kufos in OET theme. Biswajit Haldar, NIOT, this is the fourth award under OET theme. The next one goes to Sritama Bagh from Presidency University under CC theme. The sixth award goes to Kshitija from NCPOR in thematic session PSC. And the last in the category of best oral presentation goes to Vaishnavi from VIT Chennai in the thematic session MOS. Now I announce the awardees for the best presentation in the poster category. The first one goes to Diksha Sharma from CSIR NIO from thematic session MEBO. And next award goes to Shruti Shah from NIO Goa, again under theme MEBO. The third award goes to Mithun Shah Hussain from KUSAT under thematic session COOP. Next award goes to Abdul Aziz from NIO Kochi under thematic session COOP. The fifth award goes to Akash Trivedi from ICER Pune under thematic session CC. The sixth award goes to Anita Kerkar from NCPOR under thematic session CC. The next award, the last award in the category of best poster presentation goes to Juhi Yadav from NCPOR POS. I now congratulate all the awardees in the best poster as well as the oral categories. Awardees may please note that the organizing committee will send the memento and certification to all of you soon. May I now take this opportunity on behalf of Inquis. The previous one was on behalf of Governing Council of Osicon. Now I would like to take this opportunity on behalf of Inquis to inform you all that Inquis would like to host the next Osicon in 2023 at Hyderabad, and a detailed proposal will be submitted to OSIGC soon, and I request OSIGC to accept our proposal. Thank you all. Thank you once again for this opportunity. Over to you, Avinash.
Thank you, sir. Thank you, sir, for announcing the awards. Wishing all the awardees many congratulations on receiving the best awards. The best awardees are motivators for all the young researchers and students who are heading towards the journey of research. Now I request Dr. K. Joshua Joseph, OSI member, Scientist E, NIOT, to brief about the students' competition and declaring the winners. Dr. Joshua, please. It's muted, please. Unmute.
Very good evening to all of you. It's my great privilege and pleasure to announce the winners of the online competition for students. Ocean Society of India has selected Ocean for Sustainable Development as the focal theme for Osicon 2021. OSI has entrusted the responsibility with a committee to conduct an online competition for students from oceanic and atmospheric science and technology background from various universities, research institutions across India under this focal theme. The competition was mainly aimed to propose a roadmap for achieving the societal outcomes proposed by the United Nations Decade of Ocean Science, with clean energy, clean ocean, healthy ocean, predictable ocean, sustainable ocean, and transparent ocean. Out of the 10 proposals received, 5 were selected for the final round based on the novelty of the proposal, relevance to the topic, and realistic approach. The students made a presentation for 10 minutes, followed by 5 minutes discussion on 4th August 2021. The proposals put forward many novel approaches in achieving the societal outcome. I'm very happy to note that we have a very promising talent among our younger generation. I'm honored to announce the results now. Mr. Mithun Shah Hussain from Kochi University of Science and Technology, Kochi, has won the first prize with his proposal, Real-Time Bloom Radar and Forecasting Dashboard, a machine learning application under the theme Predictable Ocean. Congratulations, Mithun. Miss Maria James from IIT Bhubaneswar secured a second prize with a proposal for floating hybrid offshore wind farms in deep waters of the Indian Ocean, focusing on the theme Sustainable and Transparent Ocean. Congratulations, Maria. Miss Devika JC from Kerala University of Fisheries and Ocean Studies, Kochi, is selected for the consolation prize for her proposal on green nano remediation for ocean cleanup as a solution for oil and microplastic pollution. Congratulations, Devika. Miss Vikrant Tepala from IIT Kharagpur and Miss Anvida Ulhaskerkar from NCPOR Goa are selected for the certificate of appreciation. Congratulations to the winners. I would like to extend my sincere thanks to the committee members, Dr. Vimalesh Pant from IIT Delhi, Professor KVSR Prasad from Andhra University, and Dr. B.R. Smita from CMLRA. I take this occasion to acknowledge the OSI GC members for the guidance and support during various stages of the competition. I am honored to be part of such a unique competition and thank the OSI for this opportunity. Thank you very much.
Thank you, Dr. Joshia, for your announcement. My heartiest congratulations to all the awardees. Always remember, dedication and hard work always pay you back. So this award ceremony is over right now. So I'll request all the participants who has been participated, they can download their certificates from the website right now in virtual platform. It may be available another 2 to 3 days. Later on, it may be removed from there. So it will be difficult for organizer to provide you with the participation certificate. So it is kindly requested to please download your participation certificate from virtual platform. So as we express our gratitude, we must never forget that the highest appreciation is not the utter word, but we live by them. Thanksgiving is the best way for expressing the gratitude. On this note, I request Dr. Smita Balraj, OSI Treasurer, GC, Scientist D, CMLRI, to please propose the vote of thanks. Dr. Smita, please.
Thank you, Avinash. Respected Chief Guest of today, Dr. Shailesh Nayak, Honorable Fellow OSI, Director NIAS and former Secretary of MOES, Professor Bhaskaran, IIT Kharagpur and Chairman Technical Committee Osicon 21, Dr. Mani Murali, Joint Secretary of OSI, Principal Scientist at NIO, Dr. N.P. Kurian, the Vice President of OSI and the former Director of NSAS, Dr. Patabi Ramarao, Member OSI GC and Scientist G in COIS, Hyderabad, Dr. K. Josiah Joseph, OSI GC Member and Scientist E to NIOT, distinguished delegates, invitees, students, my dear colleagues, and office bearers of OSI, ladies and gentlemen. We sincerely thank our chief guest, Dr. Shailesh Nayak, Director NIAS and former Secretary MOES, for being with us today to give your blessings and the kind consent from your end to deliver a plenary talk on one of the very profound and significant current topic towards stewardship of blue economy. Your plenary talk was thought-provoking and valuable to the oceanography community. Thank you so much, sir. I extend my sincere thanks to the Governing Council and all the members of OSI for the wholehearted support to organize the 3-day conference. We place on record our sincere thanks to invited distinguished speakers for delivering their invited talks in the conference. All the talks were very informative and enlightening, especially for the students, research scholars, and young scientists. I would take to express my heartiest gratitude to the Technical Committee Chairman, Professor P. Bhaskaran, and all the eminent members of the Technical Committee involved in scientific program planning. The kind cooperation and support has thoroughly contributed to make the conference successful. Our sincere thanks to the chairman of all the sessions, coordinators, participants, all members of the advisory committee and organizing committee, OSI local chapters and all OSI members, scientists, research fellows, technical staff from NCPOR and all the organizations and universities across the country who have participated and supported this conference. We appreciate all the delegates and students who have attended Osicon 21 by submitting the research papers and posters, which we arranged as quick oral presentations. One of our main aims to attract young researchers in the field of ocean science is fulfilled by their overwhelming response. I sincerely thank Dr. M. Ravichandran, President of OSI and Director NCPOR Goa, for accepting to conduct Osicon 21 from Goa and also for successful completion of the same. Thank you, sir, for your enormous contributions throughout the Osicon 21 journey. The vote of thanks has taken a rather long time, but a big round of thanks to our conference local organizing team of NCPOR, Dr. N. Anil Kumar, Dr. Avinash Kumar, Dr. Rohit Srivastava, Dr. Ravi K. Nayak, Mr. Lalit Ahirwar, Dr. P. Sabu, and Rajini Kanda Misra, who have been with us and beyond. Let us not forget the backbone of this grand function. Our teams who went an extra mile and worked the tail off and made this dream a reality. They all worked very hard to make this conference successful. I also sincerely thank our sponsors. Without the support, we would not have hosted virtually through cloud. Big thanks to MNC for hosting this virtual conference. Special thanks to Mr. Rakesh Rao for providing welcome video of Osicon 21. We cannot ignore the support and cooperation we got from Administration and Finance Division of NCPOR for the valuable supports, especially Mr. Anup, Administrative Officer and his team. Thanks are due to everyone who have supported to this workshop directly or indirectly from the beginning and stood for the cause. I apologize if I have missed any individuals who have supported directly or indirectly. Thank you very much. Thank you.
Thank you so much, Dr. Smita, for your kind words about our journey. Last but not least, I feel honored to have respected dignitaries and the large community of scientific researchers on the virtual platform. Together, and not only, this conference session also will be available on YouTube. And right now it is available all the sessions for every time. So anybody can watch whatever the session we have missed out. Coming together is a beginning. Stay together is a progress, and working together is a success. We are truly humbled by everyone present here. No conference can be successful without the teamwork. I am thankful to all the participants and the organizers. I wish all good luck and the scientific endeavor with gratitude for the everything, success, victory with yours. Stay safe, stay blessed. Thank you. Namaskar.
Thank you all. Thank you all.
Thank you all.
Thank you.
Thank you all.
Thank you.
Thank you so much, sir. Thanks for all your support. Thank you very much.
Thank you, sir. Now we will close the session now.